Hey there, Sam! Now before you continue to watch this series, I will assume that you already have a good understanding of PHP, Composer, MySQL, and the concept of MVC. If any of those sounds a bit unfamiliar to you, you might want to read up before continuing. I have attached a few resources in the description below, so feel free to check them out. So here I've got a fresh installation of Laravel, and if this is the first time that you're working with a web framework, this might look a little bit intimidating to you. If you're unsure on how to create a new Laravel project, simply go to your terminal and type in Composer, create project, Laravel/Laravel, and your project name. This command will create a new folder with the same name as your project, and it will generate all the files required for us to run Laravel. You should see something pretty similar to what I have here on my screen. If you want more information on how to install a Laravel project, simply head to the documentation and browse to the installation guide. And again, the link is in the description. Okay, back to our code editor. We see a lot of files and folders here, and they do look quite scary. We have app, bootstrap, config, database, public, and all other kinds of scary stuff. But don't be scared, you don't have to learn them all at once. Let's do a quick rundown on the folder structure in Laravel. Laravel is built based on the MVC software architecture, so we'll be seeing a lot of MVC-related terminology in the files and folders. Let's start with the app folder. So the app folder is where we'll spend 90% of our backend development time. This is where we put in our main app logic and all the code related to our app. Next, we have the bootstrap folder. As the name suggests, this is where Laravel bootstrap or set up our app. You don't really need to touch this folder. It is just one of those folders that is required by Laravel to work properly. The config folder stores all the configuration of our app. Things like database connection, authentication driver, mailing provider are all defined in here. The database folder contains all the code related to our database, and that includes the migration files, which is how we define our database schema. In other words, how we define our tables in our database. We also have seeders and factories in our database folder, and they are responsible to populate dummy data in our database. The public folder contains static resources. In other words, the public-facing HTML files, JavaScript, CSS, or images. Everything we put in here will be accessible by the public, so make sure you don't put in anything sensitive in here. The resources folder is where we put in all the front-end stuff. These are the source JavaScript and CSS files that are yet to compress and minified. The length folder is where we put in a translation mapping for our app. The routes folder is where we put in all of our app routes. This includes the web routes for the user interface, API routes for incoming HTTP requests, channels for WebSocket broadcasting, and console for CLI commands. The storage folder is where the app stores things like cache, log files, images, and other generic files uploaded by our app user. The test folder is where we put in our unit test and feature test, and the vendor folder is a directory created by Composer where it puts all the project dependencies in here. And that's about it for the folders. Let's go through the files now. The files that you can see here are mainly configuration files. I'll go through the important ones here. The editor config file is just a file telling your text editor on how to format your code. The .env file is where we store all of our environmental variables. The git ignore file tells Git to untrack all the files and folders listed in here. The reason why we want to untrack files and folders is because these files normally contain sensitive data, like your credentials or API tokens, or just simply too big to push it to our Git repository. styleCI.yaml is the configuration file for styleCI, which is a software that auto-formats your code. Artisan is Laravel's main command line interface. This file is the main script that runs the CLI. We're going to be using it very frequently in this series, so stay tuned for that. Composer.json is required by Composer to manage our project dependency and also store other metadata. Similar to Composer.json, package.json is required by npm for a similar purpose. phpunit.xml is the configuration file for us to run PHP unit test. Server.php allows Laravel to run a development web server without using external web server software like Apache on Nginx. And finally, Webpack.mix.js is a wrapper around Webpack for us to easily bundle our front-end assets. So that's a quick overview on the files and folder structure of Laravel. I hope that makes things a little bit less scary than before. Now let's talk about how Laravel handles incoming requests. The index.php file in the public folder is the main entry point of the whole app. Let's look at what's going on here. The first thing it does is to check if our app is in maintenance mode or not. Maintenance mode is the mode where we stop all of our web services in order for us to do maintenance work like fixing a bug or upgrading our software. If we're not in maintenance mode, Laravel will then load the autoload script provided by Composer to load all of the PHP classes in our app. Once that's done, we're importing an app instance from app.php inside the Bootstrap folder. Let's take a look at what's going on in there. So here we're creating a new application instance. You can think of this app instance as a giant object that contains all sorts of information regarding our app. For example, the base path of our app, in other words, the location of our project in a computer, or information like how many users are currently logged into our app, all of the HTTP routes in our app, the environmental variables and the configuration details, and other app information. This information is not typically handled by the app instance directly. Instead, we create classes for which Laravel codes services to take care of this information for us. For example, if we want to know how many users are logged in at the moment, there will be an authentication service class living somewhere in our app that handles all the authentication logic and information for us. However, we still need a way to connect this service to our app instance. And Laravel does this through something called the service container. You can think of the service container as a big box attached to the app instance, and we will put all the services that we want inside this giant box. Let's visualize this to make this more concrete. So here is our app instance, and attached to it is a giant box where we call it the service container. And in our app, we would have a lot of services. For example, an authentication service that handles the user authentication, a routes service that configure and provide us information about the routes in our app, a storage service that takes care of all the file system operations, and lots of other services. Now, in order for the app to interact with these services, we need to put these services inside the container. In Laravel terms, to bind the service into the container, so the app instance can interact with these services. Now, there are two ways to bind a service into the container. One is to call the bind method directly from the app instance, which we'll see later. And the other way is to use something called the service provider. The service provider is basically a class that tells Laravel on how it should bind a service inside a container. It is much more powerful than calling the bind method from the app instance directly. We'll learn more about service provider in more details in the upcoming lessons. Alright, now let's look at how we can bind a service into the container from the app instance directly. So there are two variants where we want to bind a service into the container. One is to call the singleton method from the app instance, and the other one is to call the bind method. With the singleton variant, there will be only one service instance throughout the whole app. So that means every time we try to instantiate an object from this service out from the container, we're always going to get the same instance of the service class. So here in this file, Laravel has bound 3 services into the container using the singleton variant: the HTTP kernel, the console kernel, and the exception handler. If we want to use the bind variant instead of the singleton variant, we just need to call the bind method from the app instance. With the bind method, when we try to instantiate a service class from the container, we'll get a new instance every time. Alright, once we have bound the 3 services, Laravel simply returns the app instance from this file. So in summary, this file simply creates a new app instance and bind 3 services to the app's container. Let's go back to our index.php file, and as we can see, immediately after importing the app instance, Laravel called the make method from the app instance. The make method is how Laravel resolve or instantiate a service class from the container. So here, we're simply getting a HTTP kernel instance from the container. In software engineering, kernel means the core of a software. So the HTTP kernel here, you can think of it as an object that does all the heavy work and connects all the puzzles together for our application to work. The kernel takes in a HTTP request, which is represented by the code here, and generate a response internally, which will be included in the HTTP response to send back to the client. We then call the send method to send the HTTP response back to the client. The file ends by calling the terminate method on our kernel instance, and this method is responsible to shut down the app by calling the terminate method in each middleware. If this doesn't make sense to you, don't worry. We will talk more about it when we learn about middleware. And this is it. This is an overview on how Laravel bootstraps itself and takes care of the incoming request. There are certainly a lot of magic involved in here, especially the kernel class, and that deserves a video on its own to discuss more about it. That's it for now, and make sure everything in this video makes sense before moving on. Key takeaway for this lesson: the index.php file in the public folder is the main entry file of Laravel. The service container is a giant box that keeps app services together. It allows the app to interact with the services. A service is just a fancy word for classes in our app. The app needs to bind a service to the container before resolving it from the container. You can think of binding as putting a service into the box, and resolving as taking out the service from the box. Singleton service can only have one instance. A kernel is the core of an app that does all the heavy work for us. That's it for now, and I'll see you again in the next video. Hey there, Sam. So in the last video, we talked about how Laravel handles an incoming request and sends back a HTTP response by using the kernel. But what's inside the kernel anyway? Let's find out. And now we're in the kernel file. On the first glance, it looks pretty scary. We have middleware, which is an array of classes, and then we have middleware groups. And again, an array of middleware grouped by a key. By default, it only has two groups, web and API. And scrolling a little bit further down, we have routes middleware, which is basically key and value pairs of middleware. So what is going on here? Before we move on, we first need to understand what is exactly a middleware. Middleware, to put it simply, is just a function that runs before the request hits our router. Middleware is one of the MVC core components. If you're not familiar with MVC, I highly recommend you to watch my other video where I talked about MVC in details. The link is in the description. And here is a brief explanation on how middleware works. Suppose the right-hand side is the server environment. When the HTTP request first came in, the request will first pass through a series of middleware before the request hits the router. And the router will then pass on the request to the other components inside the app. A middleware is just a function that contains logic to either modify the request or act as a security guard to check whether the request should be allowed to continue to go inside our app or not. Let's go back to our code. In Laravel, middleware is in the form of a class. Just by looking at the class name, we kind of know what these middleware are doing. These middleware, as described in the documentation, are global middleware that runs through every request. Let's look at a few intuitive ones here. For example, the prevent request during maintenance middleware would not allow any request to pass through if we are in maintenance mode. The trim strings middleware would cut off any blank space on the left and right hand side of all the request fields. And the convert empty strings to now, as the name suggests, will convert empty strings in a request to now. And now let's learn how to create our own middleware. Middleware in Laravel is just a class. The easiest way to create a middleware is to use the php artisan command. Let's go to our terminal and type in php artisan make middleware and followed by our middleware class name. And just for demonstration, I'll give it a stupid name. I'll just call it say cheese middleware. The middleware creator will be located in our app folder, http, middleware, and say cheese middleware. Inside the file, you can tell it's a very simple class with just one method. Code handle. The handle method will contain the logic of the middleware. And it has two arguments, request and next. Request is a representation of the incoming HTTP request. And next is a callback function to call the next middleware. Because middleware is a series of security guards in our app, if we don't call the next callback function, that means the current middleware has failed and our app will block the current request to prevent it from moving further into our app. So here, just for demonstration, I'll dump a string when the request passed through our say cheese middleware. And we'll go back to our kernel.php and put our middleware at the very top of our middleware list. Let's try our code. Let's go to the terminal and run php artisan serve to start a development web server. Go to our browser and we see hey cheese as part of our response. Now let's see what happens if we don't call the next function. Let's go back to our middleware. Instead of returning a result of the next function, I'm going to return now. We'll go back to our browser again, hit refresh, and we see an error. What happened here is that the handle method in the middleware should either return another middleware, which is the result of the next function, or a HTTP response. So if we don't want to move on to the next middleware and return a JSON response, we should return a new JSON response object and pass in a payload. So back in our browser and hit refresh, we now see our JSON response inside the body. Now just to show you the next function is actually calling the next middleware, I'm going to go back to kernel. And trust proxies is the next middleware in line in the middleware series. So let's go in there and override the handle method, and I'll dump another string. So now back inside our cheese middleware, if we call the next function, we should see hey trust proxies inside the browser. Let's give it a go, hit refresh, and there we go. And if we don't call the next function, we'll no longer see our hey trust proxy string. Let's go back to our browser again, and we're back to before. And that is middleware in a nutshell. Now that you understand more about middleware, we can go back and talk more about the kernel. Inside the kernel file, we have three middleware-related properties. The middleware array, which is the global middleware. The middleware groups, where we can group middleware under one key. So the web middleware group here would represent all the middleware that we see inside this array. And the same applies to the API group. Once we created this group, we can then assign a group name to our routes, which you'll see later when we learn more about routes in a future video. And for the routes middleware array, we can assign a middleware alias to a certain middleware class. For example, the authenticate middleware class has an alias of Auth, and authorize has an alias of can. So once we have given a middleware an alias, just like the documentation described here, we can assign them to middleware groups or use them individually in any routes. The Throttle request middleware has an alias of Throttle. So if we go back up to the middleware groups, we can see it being used inside the API group. However, the alias looks a bit different here. It has a colon and a string API. So if we put a colon after any alias, whatever comes after the colon becomes the parameter to be passed on to the handle method in the middleware. So in this case here, we're passing the string API as an additional argument to the Throttle request middleware. So if we look inside the Throttle middleware, we can see inside the handle method, the string API is going to pass as the max attempt argument. Alright, let's move on. Now I want to talk about what the kernel is doing behind the scene. Let's go back to our kernel and we'll navigate to the base HTTP kernel class. The primary function of this class is the handle method, because it is what being called inside the index.php file. So what's going on inside this handle method? The main thing to look after here is this send request through router method. Let's take a look inside it. And the documentation here says that this function will send a given request through the middleware or router. And if we read the code here, we kind of can tell that it is sending a request through the middleware and then dispatch it to the router. But before that code is being executed, there's an interesting line here that calls the bootstrap method inside this class. Let's look at what's inside it. And it says bootstrap the application for HTTP request. Let's take a look at what is the bootstrappers. And we see an array of bootstrappers that basically tells us what they're doing. Bootstrap is just another word for setting up the application. So from here, we can tell that the bootstrap method is doing the following task for us. It loads the environmental variables, loads the app configuration, handle exception, register facades and providers. You might be unfamiliar with the concept of facades and providers, but don't worry. I promise I'll talk more about them in details in a future video. For now, just think of them as the core components in Laravel for the application to work. And the bootstrap method is just helping us to set up these components. So back to our send request through router method. This method will simply set up the application and pass our request through the middleware and the router. So in summary, the handle method inside the kernel will bootstrap the app and send a request to the router through a series of middleware and return us a response. And back inside index.php, we then call the send function to send a response back to the client just before we terminate the application. Now let's take a look at what's happening inside the terminate method of the kernel. The terminate method, based on the documentation here, will simply call the terminate method on any middleware if they exist. So in every middleware, other than the handle method, we can actually define another method called terminate, which will be run by the kernel terminate method. Let's try this out. We'll go back to our cheese middleware and create a new method called terminate. And the terminate method should accept two arguments, the request and response. And all I'm going to do here is to dump by. So if we go back to our browser and refresh, scroll down and we see by as the last element in the response. And that's it. That's a quick overview on kernel and middleware. Key takeaway for this lesson: middleware are functions that run before the request hits the router. The handle method in the middleware contains the main logic, and the terminate method cleans up the app just before the app is shut down. The kernel is responsible to pass the request to the router through a series of middleware. The kernel bootstraps the application by setting up the environment variable in the .env file and the configuration of our app, exception handling, and register facade and service provider. That's it for now, and I'll see you again in the next video. Hey there, Sam. So in the previous video, we talked about there's always a box called the service container attached to our app. And just a quick recap, here's our app, and there's a container attached to our app instance. And as we develop our app, we're going to have a lot of different classes that do different things. And Laravel calls these classes services. However, by default, these services are just hanging around without connecting to our app instance. So to put these services into the container, there are two ways. Either we call the bind method directly from our app instance, or we use the service provider. Let's explore on how we can use a service provider. In simple terms, Service provider is just a class that tells Laravel on how to instantiate a service. For example, suppose we have a service called geolocation, and the purpose of this service is to retrieve geolocation data of a certain location. But for this geolocation service to work, it might be dependent on other classes to work. For example, a map class to approximate the location, and also a satellite class to pinpoint the exact location. So since geolocation is dependent on map and satellite, at the time when we want to instantiate a geolocation service, we might want to create a new instance for each map and satellite and load them into the constructor of geolocation. So our geolocation constructor will look something like this. But here's the issue. Every time we want to create a new geolocation instance, we will have to create a new map instance and satellite instance beforehand, so we can pass them along to geolocation, and that makes things a little bit tedious. And this is exactly where service provider comes into the rescue. And again, service provider is just a class that helps us to instantiate services. In other words, once we set up a service provider for geolocation, the map instance and satellite instance will be automatically loaded or injected into geolocation. In programming terms, if a class instance is loaded into another class instance, it is known as dependency injection. So the keywords here are depend and inject. Geolocation is dependent on map and satellite, and we're injecting them into the constructor of geolocation. That's enough talking, let's dive into the code. First thing first, let's create our services. We'll create a new folder in our app directory called services. And this is where we'll put in our geolocation, map and satellite services. Let's create a folder for each of them and their corresponding service class. Once we're done, let's go to geolocation and we'll implement the constructor. The constructor of geolocation will take in an instance of map and satellite and make them into private properties. Now let's also create a dummy method just for testing. I'll call it search, and it accepts a string argument, which is the location name that the user wants to search. While we are on here, let's create some dummy methods in satellite and map as well. So in the map class, I'll create a new method called findAddress that takes in a string address, and the function will do its magic and return an array of information about the location. Next, let's go to our satellite class, and we'll create a dummy method called pinpoint that accepts an argument info, which is the array returned by our map class. And this function will return a geo coordinate, which is the latitude and longitude of a location. I'll just hardcode the values for this demo. And now back to our geolocation class, we'll make use of those two methods that we just created. So in the search method, we will pass the name argument into the findAddress method inside our map class. Once we got the location info, we can easily get the coordinates by calling the pinpoint method from our satellite class instance. And the result of this search function should be the geocoordinates of a location. So we can just return the result of our pinpoint method in this function. And now our class implementation are completed. It is time to create a service provider for our geolocation class. The easiest way to create a service provider is to use phpartisan command. So let's go to our terminal and type in phpartisan make provider, followed by our service provider name. I'll call it geolocation service provider. Once that's completed, and if we navigate to the provider folder inside our app directory, you'll see our geolocation service provider file created in there. Now let's take a look at the structure of a service provider. There are only two methods in it, a register method and a boot method. The register method is where we tell Laravel on how we want to instantiate our class. This is also the place where we load all the configurations that is needed by our class. And here's the place where we bind our class into the service container. Let's try to bind our geolocation service into the container. To do that, we need the app instance. Thankfully, the app instance is one of the properties of the base service provider class. So we can just call this app, and we can call either the bind method or the singleton method. I'm going to go ahead with the bind method because we don't need a singleton in our case here. The first argument in the bind method is the service name. You can put anything you want as a service name, but the best practice is always to use the class name. So I'll pass in the full qualified class name of the geolocation class. And the second argument is where we tell Laravel on how do we create this service. We should pass in a callback function that returns an instance of the geolocation class. And the callback function accepts the app argument just in case we need to access the app instance. And now inside the callback function, let's create our geolocation service. We'll first create a new instance of the map class and also the satellite class. Once we have created them, we'll simply return a new geolocation instance and pass in the map and satellite instances. And now the next step is to register our service provider. We go to config and app.php and put our geolocation service provider inside the provider array. And that's it. We have just registered our geolocation service inside the service container. Let's try it out. We're going to go to our terminal and run php artisan tinker. Tinker is an easy-to-use PHP shell environment provided by Laravel. It's great for development purpose like now, and we'll be using it a lot of time in the future as well. Anyway, let's test if our geolocation service can be resolved correctly. To resolve a service out from the container, there are two ways to do it. One is to call the global app helper function and pass in the container name, which in our case here is the class name of our geolocation class. Hit enter, and it works. We have now resolved our geolocation service out from the container. The second way is to call the make method from an app instance. To do that, again, we can call the app helper function, and by default, the app function will return us the current app instance. And from there, we can call the make method and pass in the container name again. And this resolves our geolocation service once again from the container. Alright, once we got our service instance, let's try to call our search method. And if everything works correctly, we should see our dummy array value return from the function. Hit enter. Whoops, I made a mistake here. Let's try again. And it works. Can you see how easy it is to instantiate any service by using the service provider? We no longer need to worry about the arguments inside a class constructor if we're using a service provider to instantiate a class. And that is a very powerful feature provided by Laravel to us. Okay, let me show you one more thing before we move on. Whatever we return in the callback function is whatever we resolve from the container. So if we return a dummy string inside the callback function of the bind method, the next time when we resolved our geolocation service, we'll just get a string called AAAAA. Let's go back to our terminal, run php artisan tinker again, and we'll try to resolve our geolocation service one more time. But this time it returns the dummy string. And this is what I meant by whatever we bind to the container is whatever we resolve later on. Okay, now let's move on. Let's talk about the boot method in the service provider. The boot method is called after every single service provider in our app is registered. You can put anything you want in there, but it is generally for things like event listener or function calls that requires the other services in our app. So just as an example, if the satellite happens to be malfunction, we might want to send an email to notify the admin using a mailing service in our app. And the boot method is exactly the location on where we can put this kind of logic in. The usage of the boot method is pretty advanced, and most of the time you don't even need to touch it, so you don't have to worry about it that much. And now, here's one more thing I want to talk about before we end the lesson. If we don't put our service provider inside the app config file, by default, Laravel will try to automatically resolve the service for you. That means Laravel will try to do what we did inside the register method on its own. So it will look inside the geolocation service and figure out what dependency is required and inject them accordingly. So if we go back to Tinker, restart the app and try to resolve geolocation again from the container, it will still work. And this feature of Laravel is known as automatic dependency resolution. However, it only works when the service constructor has arguments based on other classes. If we've got arguments that's a string, a number, or other data type, then the auto resolution will not work. Let's try it quickly. If I add a new string argument to the geolocation service and go back to our terminal, restart Tinker, and resolve the service again, and now we see an error because Laravel can't figure out what to put in as a string argument. To solve this issue, we'll need to manually define our service provider and put it inside the app config file, just like what we did before. And that's a brief overview on service provider in Laravel. Key takeaway for this lesson: service providers are classes that instruct Laravel on how to instantiate a service or class. The register method is where we define our class binding, and the boot method is called after all services are registered. We need to put our service provider in a provider array in the app config to activate our service provider. Otherwise, Laravel will just automatically resolve the service on its own using the automatic resolution feature. That's it for now, and I'll see you again in the next video. Hey there, Sam! So in the previous video, we talked about how we can resolve a container instance by using the global app helper function and also a Laravel feature called the automatic dependency resolution. And just for demonstration, I've created a dummy class called playground. And if I want to resolve an instance of my geolocation class here, all I need to do is to use the app function and pass in the class name of my geolocation service, and Laravel will resolve an instance out from the service container. If we don't want to use the add helper function, we can also take advantage of the automatic dependency resolution feature by type hinting or injecting the service inside the constructor. So those are the two known ways that we have discussed so far to resolve a service instance out from the container. However, there's a third way for us to resolve a service instance out from the container, and it's something called Facade in Laravel. In short, Facade is a class that allows us to statically code the service methods. I will show you what I mean. Our geolocation service has a method called search. To call this search method, we first need to get an instance of our geolocation service. However, if we have created a facade for our geolocation service, we can simply call the search method statically. For example, let's go back to Playground, and let's say we have created a facade for geolocation, and we call it geolocation facade. We then can simply call the search method statically from the facade class. And that's it. That's how facade looks like when we actually use them. You can think of facade as a static counterpart of our main class. Okay, now, let's learn how we can create the facade. It is actually pretty simple. I'll create a new class and call it geolocation facade, and all facade must extend the facade base class in Laravel. For our facade to work, we simply need to override one method from the facade base class, and the method is called getFacadeAccessor. And inside the method body, we simply need to return the class name of our service, which in our case here is geolocation. And that's it. Simple as that. We have just created a facade for our geolocation class. Let's try to use our facade. Back in Playground, we'll import our geolocation facade namespace and dump the result of the search method. And let's go to terminal and run php artisan tinker, and we'll resolve an instance of our Playground class. And the result of the search method got dumped inside the console. And that means our facade is working. Now we do have one issue. Although using facade is very convenient, but it is not that friendly on our text editor. The text editor is not smart enough to detect all the methods available to us in the original service class. So there won't be any method autocomplete when we use facade. So what can we do about this? We can insert some PHP documentation to tell our text editor about the methods available. Depending on which editor you're using, you might want to do a little bit of configuration for it to work. I'm using PHP Storm, and the autocomplete works without having me to do any kind of configuration. If you're not familiar with the syntax of PHP documentation, I have attached a few resources, and as always, the link is in the description. Alright, let's go back to our Playground. And now, the autocomplete works. At this point, you might have a question. Should we use dependency injection or facade to resolve a service instance from the container? And here's my answer. They both work and can do the job just fine. It is your personal preference to pick either one of them. I tend to use dependency injection rather than facade, because facade seems a bit magical to me and does not provide auto-completion out of the box. By default, Laravel has a lot of facade provided to us already. And here's a list of facade defined by Laravel. The link again is in the description. They are all very useful facades, and we'll be using some of them in the upcoming videos. Key takeaway for this lesson: facade allows us to statically call service instance methods, providing us a convenient way to call service methods. You can think of facade as a static counterpart of a service class. That's it for now, and I'll see you again in the next video. Hey there, Sam! Here's what we're going to build in this series. We're going to build a Google Docs clone. I'll show you step by step on how to build this from scratch by using Laravel. There'll be two parts for this series. One will be focusing on the backend, where we build the API, and for the other part, we'll be focusing on building the front end. And I'll teach you step by step on how to build an amazing UI using Vue.js and a design framework called Fortify. And here's a quick demo on how our app will look like and the main features that we'll be building. This is the login screen with all the authentication features built in, including the forget your password link and also the registration page. Let's try to log in, and our login form has built-in validation to make sure the user type in the proper credentials. I'll log in using a dummy account. And there we go, this is our homepage. So the idea of this app is to have an online collaboration platform for team members to share notes and documentation with each other. It is sort of like Google Docs, but simpler. So here on the homepage, I'm logged in as the admin. I can see all the notes or posts that I'm involved in. If I click on one of them, I can edit a post content. And if I hit refresh, the modified text still remains. And this text editor also supports Markdown syntax. If I want a heading, I just need to put a hash, and we get a heading. If we want a code block, just type in triple backticks, and it will immediately show up in the text editor. So on and so forth. And now if I open up a new private window, and log into the app as a different user, we can see all the users that are currently on this page showing up on the screen. Furthermore, we can also see the cursor position of each user, and that is a very convenient collaborative feature in our app. We can also invite new users to collaborate on this document by simply clicking on the Share button and type in the user's name. The users will be able to collaborate in real time. So if I enter some content on the left-hand screen, it will show up after a while on the right-hand screen without refreshing the page. And just something extra, we also support dark mode. And we just need to click on the moon icon on the app bar. And that's about it for this app. In the first part of this series, I'll show you step by step on how to create the backend API server for this app in Laravel. There's quite a bit going on behind the scene, including authentication, validation, and also setting up a Websocket server for the real-time collaboration. In part 2 of this series, I'll show you step by step on how to build this UI using Vue.js and Vuetify, which is a component library based on material design and Vue.js. There will be a lot of information packed in this series, so get ready and I'll see you in the next video. Hey there, Sam! Every time I start a new project, the first thing I will do is to design a UI and the database schema. In other words, design the Entity Relationship Diagram, or ERD for short. An ERD is basically a diagram that defines what are the fields in each table and the relationship between each table. You can design your ERD on anywhere, whether you're using pen or paper, on a whiteboard, or using a software. It doesn't really matter as long as it works for you. For me, I like to use this software called Draw.io. It is a very powerful tool and it's free and open source. The link is in the description if you're interested. I'm going to go ahead and create a new diagram. The first thing we want to do is to put down all the models in our app. Each model should have a table. Let's create one in Draw.io. I'll start with the users table. The users will have an ID, created at and updated at fields. The users table should collect all the information about a user. For example, name, email, password, and so on. We'll add these details to the table later. Since this app is about writing posts, we should also create a post table that holds data about the post. For example, the post title and the post body. Again, we'll add the specifics later. Now, a user can write a lot of posts, but at the same time, a post can be written by many users. So that means this is a many-to-many relationship. And to achieve this in MySQL, we'll need a pivot table. In other words, an intermediate table that records the relationship between two tables. By convention, the pivot table name should be the singular form of both tables, arranged in alphabetical order. In our case here, we have post and users. So the pivot table name should be post user, because the character P comes before the character U in alphabetical order. And inside the pivot table, we'll put in the foreign key for both of the related tables, which will be the user ID and the post ID. Then we will point the ID of the user table to its foreign key in the pivot table and specify it's a many-to-many relationship by using the shorthand end-to-end. And do take note of the arrow direction. It flows from the user table to the post table because the user is the parent. Now, if this is still a little bit fuzzy to you, here's a small example to show you how pivot table works. Suppose we have 2 users and 3 posts. User 1 is involved in 3 of these posts, and user 2 is only involved in P1 and P2. Now, if you want to record this information in the pivot table, it will look something like this. So in the pivot table, there are 2 columns, user ID and post ID. User 1 has post 1, so the first row will put in user ID 1 has post ID 1. User 1 also has post 2, so the second row will put in user ID 1, post ID 2. And the same with post 3. Now for the second user, we'll do the same. And that's it. That's how we connect 2 tables in a many-to-many relationship. Okay, back to the diagram. A post could also have comments. Let's create a new table for that. A comment is written by a user and belongs to a post. So that means we need to put down the foreign key for both tables. Let's do that. I'll put down user ID and post ID, and then link the parent table to it. And this time, both of them would have one-to-many relationship, for which we'll use the one-to-end shorthand. Alright, that's all of our tables in a nutshell. Let's complete each table with their fields in details. Alright, now all the fields has been filled in. You might be wondering, why did I put JSON for the post body and the comment body? Why not just use string? And the reason is, the library that we're going to use later on for the text editing part of the app is pretty complicated because it has to handle different type of text formatting options, like setting some text as headings, apply different font sizes and colors, and so on. So if we just store the post content as a string, we wouldn't be able to easily store the formatting options. And that's the reason why we want to use JSON to store the post body and comment body. And now let's dive into the code and set up all the tables. The first thing we want to do is to set up our database connection and create a database for our app. Go to the .env file and change the MySQL connection details to your own setup. Then I'll create a new database in my MySQL instance, and I'll do that in MySQL Workbench. I'll click on the Add New Schema button and give my new schema a name of Live Post. Click on Apply and apply again. And that's it. We have now created a new schema in our MySQL server. And now the next step will be create our database tables that we just designed in our newly created schema. And Laravel makes this extremely easy for us by using a concept called migration. So migration is essentially version control for our database. It is a series of files that perform schema operations on a database. For example, creating new tables, updating columns, adding columns, or dropping tables. Laravel stores all the migration files inside database and migration. And as you can see here, by default, Laravel has already got 3 migration files out of the box. And they are there to create 3 tables: the user table, password reset tables, and failed jobs table. Every migration file has its specific convention for the file name. It consists of 2 parts. The first part is the timestamp, and the second part is the operation. Laravel will throw us an error if we don't follow this convention when we create a new migration file. So the migration file for create user table was created on 2014 October 12th, so on and so forth. And Laravel will run these migration files in chronological order. So that means in this case here, Laravel will run the create user table migration file first because it is the oldest among the 3, and then the create password resets table migration file, and finally the create failed job table. And since the migration files are run in chronological order, we need to be very careful to not create a table that's dependent on the others to be the first to run. So what I mean by that is, if the failed jobs table here has a user ID foreign key, in other words, is dependent on the user table, it should be run after the users table has been created. If we try to change its timestamp to a date earlier than the create users table, Laravel will throw us an error when we run the migration. So just be aware of that when it comes to creating migration files. Anyway, let's investigate what's inside the create users table migration file. As you can see, it's a normal PHP class, and it consists of 2 methods, up and down. In the up method is where we put in the logic for the main operation in this migration file, which in this case is to create the users table. We mentioned that migration is a version control system for our database, so sometimes we might want to roll back our schema operations, and we do exactly that in the down method. So the down method is where we put in a logic to roll back the migration. So in this case, if the up method is to create a user table, then the down method will be the opposite of it, which is to delete the user table. And now let's talk about how we can create our table. As you can see here, Laravel makes it very easy for us to create columns in our table. We call the create method from the schema facade and pass in a table name, which is user in our case here. And in the second argument, we supply a callback function, which defines how the table will be like. So if you look at the code here, the table will have an ID column, which serves as the primary key, and a string column for name, and another string column for the user's email. And we can change SQL attribute after defining the column, and in this case, we're making the email column unique. The timestamp method will create a datetime column, and the nullable attribute will just allow null values for this column. The remember token method is a helper method provided by Laravel to create a remember token for authentication. And the timestamps methods here would create the created at and updated at datetime columns. Alright, let's create our migration files now. Laravel actually provides us a few artisan commands to generate all this boilerplate for us. Let's go to our terminal and type in PHP Artisan, and it will list down all the available commands provided by the Artisan console. What we are after are the make commands, the make model commands in particular. We can find out what it does by typing in PHP Artisan make command --help, and Artisan will print out the documentation. This command is used to make a new model, and it has a variety of options here. We'll be using the all option because we need all the components listed here for our API server. It does look scary, especially the components listed here, but don't worry, we'll go through them one by one in the future videos. Alright, let's use Artisan to create our post model. We'll type in PHP Artisan, make model, and the model name will be post, and supply the all option and the API option to generate the API controller, which is ideal for an API server. And now if you look inside the migration folder, you can see a new file has been generated for us. And that's the boilerplate that Laravel has generated through the Artisan command. We also need a comments model, so let's create that as well. Again, we'll go to the terminal and type in PHP Artisan, make model, comment, and pass in the same option as before. Alright, sweet. We now have got the boilerplate for the comments model as well. Let's do a commit. Before we start setting up our migration files, we'll go to our terminal again and type in git status to verify all the files that have been changed. Once that's okay, we'll type in git add dot to stage all the changes. I'm using an alias here, GA, which is a shorthand for git add. If you're using a Unix-based system like Mac OS or Linux, you can install this wonderful shell framework called allmyzsh to get these awesome shortcuts and a sexy terminal just like mine. I can guarantee you're gonna save a lot of hours in the long run. The link is in the description if you're interested. And after that, we'll commit our changes. Again, I'm using a shorthand here, GCAM, which stands for git commit-m. Once we're done, I'll just push to my remote repository by typing in git push. Again, GGP is a shorthand for git push. Alright, back to our code. We'll now set up our migration file to create a post table. Our post table needs a string title and also a nullable JSON body. So we'll call the string method on the table object, and the name of the column is title. And for the body, we'll call the JSON method, the column name is body, and chain the nullable method after it. And that's it. Next, let's set up our comments table. Again, we need a nullable JSON body, which is the same as the body column in the post table. The comments table has two foreign keys, the user ID and the post ID. To create a user ID foreign key, we can call the foreign ID method, which will make the column an unsigned big integer. In other words, user ID will have a type of unsigned big integer. After we have created a column, we need to apply our foreign constraint to it. And Laravel makes it very similar as we're doing it on a raw SQL query. To do that, we'll call the foreign method and specify the user ID column. And after that, we'll call the on method and pass in the parent's table name, which in our case here will be users. And then we'll call the references method, which will pass in the referencing column in the parent table. And once we're done, we'll apply the cascade on delete constraint on this foreign key. And that's it. And we'll do the same for post ID. And we're done for comments. And lastly, we need to create a migration file to create a pivot table for both users and posts. Unfortunately, at the time of recording this video, there's no Artisan command that can generate a boilerplate for a pivot table, so we have to create this manually. Let's copy and paste our comments migration file and rename it to create post user pivot table. And change the timestamp to a later date than the users and post migration files. And in the file, we'll rename the class name to create post user pivot table and also the table name to post user. The pivot table doesn't need an ID, so let's delete it, and also the body column, and also the timestamp. We'll make both user ID and post ID into an index so we can improve the performance of the query. And next, we'll set the post ID and user ID to be the primary key of this table by calling the primary method. And last but not least, we should change the table name inside the down method from comments to post user as well. And that's it, that's our pivot table. Let's try if our migration works. We'll go to terminal and type in PHP Artisan, migrate. And it seems like it's all working. Let's verify them in our MySQL server. We'll go to Workbench and click on the second icon when we hover on the table, and we can see the columns and their data type are created correctly. So now we can confirm our migrations are working fine. And we're done. Let's make another commit. And we're good to go. There's quite a bit of information to take in this lesson, but do try to understand them as much as possible before you move on to the next lesson. Key takeaway for this lesson: migration is a concept of version control for a database. Laravel will run migration files in chronological order. In other words, by following the timestamp in the migration file name. The Artisan console is a wonderful tool to generate boilerplate for our project. By using it effectively, we can save a lot of time. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! We have created our tables, and now it's time to populate the tables with dummy data for testing purposes. In programming terms, this is known as seeding. So the next time when you hear someone mention about the word seed, it simply means to load the database with dummy data. And now to seed our database, we need to create records for our models. And to be exact, random records. At this point, you might have this question in your mind. How exactly are we going to do that? And Laravel has already got an answer for us, and it's something called factory. In short, a factory is a class that is responsible to generate a model record for us that is typically filled with fake data. Let's dive into the code right away to see how factory works. Laravel places all the model factories in the database folder and the factories folder. We already got some files in there. The comment factory and the post factory are generated by the artisan make command in the previous video, while the user factory is provided by Laravel out of the box. Let's take a look at what's happening inside the user factory. A factory is essentially a class. To get our model factory working, we just need to override a few properties and methods from the base factory class. The model property tells Laravel which model does this factory belong to. In our case here, the user factory belongs to the user model. So we just need to pass in the class name for our user model. Next, we have the definition method, which is the main method to tell Laravel how do we want to generate a model record. The definition method should return an array, and the array should be a mapping of the model's fields against the value. And now you might be wondering, what is this thing called Faker doing here? Well, Faker is a wonderful library that helps us to generate fake data, and it is installed by Laravel out of the box. And Laravel has loaded an instance of Faker to this Faker class property on all factories, so that we can use Faker to generate fake data anywhere in a factory. If you want to learn more about what kind of data that Faker can generate, feel free to visit its official documentation. The link is in the description. So here for the user's name field, we're using Faker to generate a random name. And for the email, again, we're using Faker to generate a unique save email. We call the unique method just to make sure we won't collide with other users' email. And the save email method is to make sure the email generated is not an actual email that someone else is using. Because when we're testing our app in the future, we might be sending test emails to this fake user record, and we don't actually want these emails to reach someone else out in the internet. The now function is just a helper function provided by Laravel that returns a Carbon instance which represents the time now. And Carbon is another wonderful library used by Laravel to replace the native datetime API from PHP. The Carbon datetime instance has a lot of wonderful helper functions that really ease up the experience working with datetime in PHP. If you want to learn more about it, again, the link is in the description. And the password fields here is just a hash that translates to the string password. And for the remember token, Laravel is using the random string helper function here to generate the random string with 10 characters. And now that's it. That's the basic of a factory. Once we created a definition method, we can start using the factory. But before we do that, we need to load a trait called hasFactory in our model. So if we go to our user model class, you can see that it's already using the hasFactory trait. If we don't load the hasFactory trait in a model, we won't be able to use the factory that we created for the model. And now let's try out the user factory. We mentioned about seed before, and just a quick recap, seeding is basically populating the database with data. And in Laravel, there are classes called seeders that will execute the seeding logic for us. The seeders are located inside the database directory and the seeders folder. And here we see 3 files. Comment seeders and post seeders are generated by the artisan make command, and the database seeder is the main file to trigger all the seedings logic in our app. And the seeder class only contains one method, the run method, and that's where we put in the main seeding logics. Laravel by default has placed a line of commented code here that calls the user factory and create 10 random user records. However, I like to put a seedings logic into their own files. Otherwise, our database seeder class will be cluttered with 1,000 lines of code. Let's create a user seeder class. I'll copy and paste the post seeder class and rename it to user seeder. And in the run method, I'll just cut the commented line in the database seeder class and paste it back to the user seeder. And again, all this line is doing is to call the static factory method from the hasFactory trait inside the user model and create 10 records of fake user. The create method will actually create a fake user in the database, or what we call persist the data into the database, and return us a collection of users. If you don't want the data to be created inside a database, we can call the make method instead of the create method. The make method is very useful when we just want to create some fake user for testing purposes, but for now we'll leave it as create. Anyway, to run this seeder, we'll go back to the database seeder and call the user seeder class. Once that's done, to trigger the seeder, we need to go to our terminal and run php artisan db seed. This artisan command will call the run method on the database seeder class. Once that's completed, we now go to our database and verify the records are actually created inside our database. And they actually are. Our users table are now populated with 10 fake users. So now our factory is working. However, there's one issue though. Every time we execute the seeders, it's going to keep adding more and more records to our database. And sooner or later, our database will be flooded with fake data. And that's certainly something that we don't want to have. So what should we do then? It's actually pretty simple. We just need to truncate our table before we run the seeders. Let's go back to user seeder, and before we call the correct method on factory, we will truncate the users table. And to do that, we can use the database facade and load the users table and call the truncate method on it. And that's it. Let's call the dbseed artisan command again. Whoops, we got an error. It is just telling us that we've got a foreign key constraint on our users table and we couldn't truncate it. To resolve this, we'll need to disable foreign key checks on MySQL. So before we truncate the table, we're going to run a SQL statement which basically disables foreign key checks. And after we've created our users, we'll enable the foreign keys check again. Let's try the artisan command again. So back to the terminal, php artisan dbseed, and run it for multiple times. And now back to MySQL workbench. We're now seeing only 10 records, and that means we're no longer flooding our database, even though we kept seeding our table. Great, let's move on. Now we're gonna need to disable the foreign key checks, truncate the table, and enable the foreign key checks again for all seeders. And obviously, copying and pasting is not the way to go. So let's create a trait for that. If you have never heard of trait before, it is essentially a set of functions and properties that can be reused or shared by multiple classes. So let's go ahead and create a folder in the seeders directory, and I'll call it traits. Then I'll create a new file in here, and I'll call it truncate table. The syntax of a trait is very similar to a class, except that we're using the trait keyword rather than a class keyword. And in our truncate table trait, we'll define a new method called truncate, which will basically truncate the table argument that we pass into this function. So I'll copy the code from before and modify it in here. And now our trait is completed. Let's go back to user seeder and refactor our code here to use our trait method. First, we'll load our truncate table trait. And now to truncate the users table, we simply need to call the truncate method and pass in the name of our users table. Let's test our code. We'll run php artisan dbseed again to make sure everything is working. And there's no errors. And that's it. Next, let's also create a trait for enabling and disabling foreign keys check. Again, I'll create a new file and call it disable foreign keys. And in that, we'll create two new protected methods, one for disabling foreign keys and the other one's for enabling foreign keys, and copy and paste the code from before. Now that's done, let's go back to our user seeder and we'll load our disable foreign keys trait. And again, refactor our code in a run method to use our newly created trait methods. Let's test our code, run php artisan dbseed again, and there's still no errors. That means everything is working as expected. That's great! And now it's time for us to create the seeders and factory for posts and comments. Let's start with post. We'll go to post factory, and in the definition method, we'll make the title field a random word by using the word property from Faker. For the body field, we'll put in an empty array as its default value. We also want to go to our post model and cast the body field as an array. The reason of doing this is because we're storing the body field as JSON data type in MySQL. By casting the body to an array, Laravel will automatically convert the body between JSON and array. So we don't need to manually call the JSON encode and JSON decode PHP functions. And now our post factory is done. Let's go to post seeder, and we'll do pretty much the same thing as the user seeders. To load the trait, call the disable foreign key helper function, truncate the table, call the factory create method, and enable the foreign keys. Once that's done, we'll go back to database seeder and call the post seeder. Let's test our code, run php artisan dbseed, and go to our database to see if our records are actually created. And we see 3 records in our post tables. So far, so good. And now let's go back to our code. We'll do the same for comment factory and comment seeder. In comment factory, for the definition method, again for the body, we'll put in an empty array as the default value. Now our comment table has 2 foreign keys, the user ID and the post ID. Populating these fields are a little bit more trickier than the other fields. We'll discuss more about them in the next video where we talked about models and relationship. For now, we'll hardcode the ID to be 1 for both of them. Once we're done, let's complete our comment seeder. I'll copy and paste the code from post seeder and modify it to fit the comment model. And last but not least, we'll call the comment seeder in our database seeder. Let's test our code again. Oops, we got an error, and I think it's because we forgot to cast our comment body to be array. Let's do that. We'll go to the comment model and add a cast property. And cast body to be array. Let's try again. And this time it works without an error. That's great. And now I want to show you one last thing before we end the lesson. We can override the default value of a field from the records generated by a factory. I'll show you what I mean. Currently, all of our posts has a random title generated by Faker. Let's say, for example, I want to pass in my own title when I generate a post using the factory function. So back in post seeder, just before I call the create method, we can actually call the state method to override the default value of a certain field. In our case here, I'm going to set title to be untitled. And now all of the posts created by this factory will have a title called untitled. Let's test this. And let's run php artisan dbseed again. Go to our database, view the post table, and now we see all the posts has a title of untitled. Isn't that neat? We can also take this to the next level by delegating the state change to a function. Let's do that. So back inside post factory, I'll create a new method called untitled. And in the method body, we'll simply call the state method from the current factory instance with a similar structure as before. And now back inside post seeder, we can refactor the code by just calling our untitled function before we call the correct method. Let's run a seeder. And it works without any error. And that's how we can override a default value from the factory by calling the state method. If you don't want to call the state method, you can also pass the state array inside the correct method, and the result will be the same. Alright, key takeaway for this lesson. Seeding is referred to populating a database with dummy data, so that we can easily test our application with this fake data. Factory classes are used to generate fake models, so we don't need to create them from scratch. We put the main seeding logic in classes called seeders. And to trigger the seeders, we can run a php artisan command dbseed. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! In the previous lesson, we talked about how our models are related to each other and showed the relationship in an entity relationship diagram, ERD for short. We've got the relationship clearly defined in an ERD, but we haven't really talked about how do we define them in Laravel. In other words, how do we define the one-to-many and many-to-many relationship between our models in Laravel? Let's start with the one-to-many relationship between post and comments. When we define a relationship, it is important to identify which model is the parent and which one is the child. In this context, a post has many comments, and typically the model on the many side is the child, and the child usually has the foreign key. So in our case here, comments will be the child and posts will be the parent. So let's go to our post model file. So to define the relationship between post and comment, we'll simply create a new method in post and name it comments. We'll make it plural because comments is on the many side. And in this method body, we'll call the hasMany method, and the first argument is the related model, which in our case here is comment. And the second argument is the foreign key in the comment table, which will be post ID. The third argument is the local key, which is the referencing field in the post model for the relationship. In most cases, including ours, it's just the primary ID field in our model, so we can just leave it out. The hasMany method will return a relation object, which represents the relationship between two models. The relation object is used by Laravel internally to perform database query, so we can retrieve database record easily. Now take a moment to look at this code. The this keyword simply represents the post model. It's saying that the post model has many comments. It reads a lot like English, right? Okay, let's test our relationship now. Let's open a terminal and go to PHP Artisan Tinker. We will load post with ID number 1 using the find method on our post model. So this code here will grab us an instance of the post model with ID 1. And to retrieve all the comments that's related to this post, all we need to do is to read a magic property that has the same name as our relationship method, which in our case here is just simply comments. And now if we hit enter, we get a collection of comments that's related to this post. Isn't that neat? And if you're wondering what is this voodoo magic and how does it work, I will show it to you now. The magic trick lies inside the base model class. So if we go inside the base model class and look for the getMagic method, we can see that Laravel is overriding the default behavior of the getMagic method. If you're not familiar with the getMagic method in PHP, it is just a way for us to customize the logic when we're trying to retrieve a property from a class instance. So here we can see that Laravel has defined a custom method called getAttribute. Let's take a look inside. On the first glance, it looks pretty scary. But if we take our time and look at the documentation provided here, it is actually not too bad. So basically what this method is doing, it is trying to check whether the key that we're trying to read from this class is an actual attribute inside the model, or if it has a get mutator. We'll talk more about mutator in the second half of this video, so let's leave it for now. If none of this exists, then Laravel will call this getRelationValue method to run a SQL query that retrieves our data records. And that's it. That's the voodoo magic behind the scene. It is Laravel overriding the getMagic method and return us a collection of comments when we try to read the comments magic property. By the way, if you're not familiar with collections, it is basically an enhanced version of array. Think of it as array on superpowers that has a lot of helper methods to simplify our life. Okay, now we're done with post. Let's define the inverse on the comments model. Let's go to comment. This time we'll create a new method called post. Notice we're using a singular noun here because post is on the one side in the one-to-many relationship. In the function body, we'll call the belongs to method, which is the opposite of hasMany. And the first argument, again, is the related model, which in our case here is post. The second argument is the foreign key, which is post ID. And now let's go back to Tinker and test our code here. I'll restart Tinker to load the latest changes in our code. As we can see from the previous output, comments with ID 1, 2, and 3 are our children of post number 1. So now if we try to find comment number 1 and load the post property, we are seeing post number 1. And that's how we can get the parent of a model. In our case here, we got an instance of the comment model, and we're simply reading the post property to fetch the post relation. And that's how we define one-to-many relationship in Laravel. Okay, let's move on. Back in our database diagram, we still have yet to address the relationship between users and post, and also users and comments. Between users and comments, it is a one-to-many relationship, and it is pretty similar to what we have done between posts and comments. I'll leave that as an exercise to you. But between users and posts, we have a many-to-many relationship. This is slightly more complicated than one-to-many. Let's see how we can implement this. Let's start with the post model. So inside the post model, we need to link it to users. As always, we'll define a new method called users. It should be a plural because the post can be written by a lot of users. Inside the method body, this time we'll call the belongs to many method. The first argument will be the related model, which is our user model. The second argument is our pivot table name, which is post user. The third argument is the foreign key in the pivot table for post, and the fourth argument is the related pivot key, which is user ID. And that's it. Let's go to our user table and we'll do the same. In a many-to-many relationship, we call the belongs to many method on both sides. Alright, now that's all done. Let's test our code. Currently, our post user pivot table is all empty because we haven't seeded any data into it. Now that we have defined the relationship, we can start populating the pivot table with some relations. And Laravel makes it very easy for us to create pivot records. Let's go back to Tinker. What we're gonna do here is to assign user ID 1 to post ID 1. So in the console, I'll call the find method on our user model and pass in ID 1. Once I got the user, I can easily assign a post to it by simply calling the relation method, which in our case here will be post, and call the attach method on the relation object returned by the post methods. The attach method accepts an ID or an array of ID that we want to assign to the user. I'll assign post1 to user1 for now. So if we go back to Workbench and rerun our query, we now see a new record in our post user table that says user1 has post ID 1. And now if we go back to Tinker, and let's say user1 is also involved in post 2 and 3, we can attach post 2 and 3 in one go using an array. Whoops, I entered 1 and 2 instead of 2 and 3. Let's try that again. And now let's go back to Workbench, rerun the query, and there are 3 records now. So user1 is now related to post 1, 2, and 3. So far, so good. But what if we want to delete an entry from the pivot table? To do that, we can call the detach method on the relation object. So let's say user1 wants to withdraw from post1. We'll go back to our terminal and call the detach method on the relation and pass in post ID 1 as the argument. And now if we go back and rerun our query, post ID 1 is no longer associated to user1. Laravel also provides a method called toggle to attach or detach a relationship depending if it has already existed or not. For example, right now, user1 does not have post1. If we go back to Tinker and call the toggle method, pass in post ID 1, and go back to Workbench, rerun the query, we now see post1 has been toggled on. If we go back to Tinker and rerun the toggle method, and now post1 is toggled off, so the record disappeared in the post user pivot table. Laravel also provides a convenient method called sync that detach all the current relations and reattach what the user passed into the function. I'll show you what I mean. So right now user1 is associated to post 2 and 3. And back inside Tinker, suppose I want a user to forget about everything else and only associate post 1 and 2 to it. To do that, I can call the sync method and pass in an array of post ID 1 and 2. And now if we go back to Workbench and rerun our query, we now see user1 has only got post 1 and 2. The sync method has detached post 3 from before and attached post 1. If you don't want to detach any relation while syncing, we can use a sync without detaching method, and Laravel will not detach any record. So for example, I can call the sync without detaching method and pass in post ID 3, rerun the query, and here we still see post 1 and 2 in the pivot table. So far, so good. And now let's move on. Let's talk about mutator. Mutators are essentially functions that allow us to transform our model attributes. There are 2 types of mutator. One is called accessor, which is used to read and transform values, and the other one is also known as mutator, which is used to transform values before we store them inside the database. If you're confused after listening to all this, don't worry. Let's go through this step by step with examples. We'll talk about accessor first. Now in our post model, we know that we have a title attribute. Now let's say for some reason, we want to grab the title in all uppercase. There are a few ways to achieve this, and one way is to create a new table column and store the uppercase version of the title in this new column. Although it works, this method is going to consume a lot of database storage space. This is because we already got the data. In our case here, it's the post title, and we're simply storing the transformation of the source data. For a simple transformation, like transforming text data to uppercase, this method is very inefficient. So do not do this at home. So a better way to achieve this is to create accessor functions. Let's create an accessor that transforms the post title into uppercase. An accessor is just a model method with special naming convention. The method name always starts with a get and ends with an attribute. So in our case here, for our uppercase title accessor, I'll call it getTitleUppercaseAttribute. In the function body is where we put in the transformation logic, which will simply transform the title attribute into uppercase by calling the PHP string function string to upper. And that's it. That's our accessor for uppercase title. If we name any modal function in this way, starting with a get and ends with attribute, Laravel will take the function as an accessor. And now to use the accessor, we can simply treat the name that we put in between get and attribute as one of the model's attribute. In our case here, it will be title uppercase. I'll show you what I mean. Let's go back to Tinker. Grab a model and read title uppercase in snake case. Hit enter and we get our title in uppercase. And that is it. Accessor is very useful to transform our raw model attribute into something more useful. Okay, let's talk about mutator now. Mutator is a function that's triggered just before when an attribute is set. Let's define a mutator for the title attribute. And just like accessor, mutators also have a strict naming convention. It starts with the word set and ends with attribute again. In our case here, I'll define a mutator for title. So I'll call it setTitleAttribute. The mutator will accept an argument, which is the value that the user provided as a title of the post. So in this example, we'll convert the user provided value into lowercase before we set it to the attribute of this model. Let's test our code. We'll go back to Tinker, grab post number 1 again, and set the title to Heya, all in capital case. This step should trigger our mutator. Heya will be passed as the value argument in our mutator, and our mutator will convert Heya into lowercase. So if we dump post again, the title attribute is in lowercase. And that means our mutator is working. Great! I think it is a good place to stop here. There are a lot more about models to go through, but the most essential one that you need to know are the mutators, accessors, how to define a relationship, and casting, which is a class property that casts an attribute to a data type. If you want to learn more about the other casting types, the link is in the description. When working with a model, you'll spend most of your time playing around with these features. So make sure you digest them well before you move on. Key takeaway for this lesson: we use the has many and belongs to method to define one-to-many relationship. Belongs to many is used to define many-to-many relationship. We use the attach, detach, toggle, and sync to associate many-to-many relations. Accessors and mutators transform values when we retrieve or set model attributes. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! In the previous lesson, we have defined our model relationship, but in our seeders, we haven't really implemented the logic to seed the relationship between models. For example, we created a lot of posts and comments, but for all the comments record that we created, currently we're hardcoding the post ID to be 1. So all the comments that are generated by the factory are associated to post 1. Ideally, the records should be more realistic, and we should randomize the post ID on each comment. So let's start writing some code and see how we can achieve this. So here in our comment factory, we can put down the logic inside the definition method. To get a random post ID, right now I can think of 2 ways of doing this. The first way is we would find out how many model records are there in our database. In other words, find out how many posts are there in our database and generate a random ID between 1 and the total model count. If there's no record in the database, then we should create a new record and grab the ID of the newly generated record. The second solution is to fetch all the model records and randomly get one of the records from the results. Once we got a record, we simply need to grab the ID. Now, I don't really recommend the second method because it involves of getting all the model records currently inside the database and stored inside our computer's memory. So the issue is, what if we've got 1 million records inside our database? Storing these records is going to consume a huge chunk of our computer's memory. This is normally not an issue when we're seeding the data because we're not going to seed 1 million records. But we do need to take this issue into consideration when we write our logic. In contrast, the first method is only going to store the model count in the memory, which is basically a number, which is very lightweight. However, this method does have its own issue, and the issue is we are generating the ID based on a random number between 1 and the model count. We are assuming the ID of the model starts from 1 until the model count, and there's no gap at all in between. This won't be an issue unless we're deleting some records in one of the seeders, which is very unlikely to happen. I'm gonna go with method 1 because it is lighter. So the first step, we want to get a model count. To do that, Laravel provides us a very nice and easy way to query the model count by using one of the Eloquent methods. So we just need to type in our model post and a query static method and then the count method. That's it. That's pretty simple, right? So once we got a count, the next thing we want to do is to check if count is 0. If count is 0, we'll create a new record by calling the factory function and the create method. The create method will return us the newly created model instance, and we just need to read the ID attribute from it, and that will be our post ID. If count is not 0, however, we'll simply generate a random number by using the PHP ran function. The starting range is 1 and the ending range is the count. And after this, we have successfully grabbed the post ID, and we just need to pass our post ID variable in the array down here. And that's it. Let's test our code. We'll go to our terminal and run php artisan db seed. Once that's done, we'll go to Workbench and view our comments table. The post ID column is no longer hard-coded, but filled with random post IDs. So far, so good. However, there's still one more issue with this implementation. Currently, this implementation is only suited for our post model. It's not very flexible, especially if we want to apply it to other models. Let's refactor this code so that we can easily get a random ID on other models as well. I'll create a new class and call it factory helper, and create a public static method, and I'll call it getRandomModelID. That accepts a string argument model, which will be the full class name of the model. And for the method body, we'll simply copy the code from before and paste it in here. And now let's add some PHP documentation to our function to stay organized. I'll simply say this function will get a random ID from the database. And also specify our model argument as the hasFactory trait for better auto-completion in our IDE. And next, we just need to change the post model into our model argument. And we're done. Let's go back to our factory and refactor our code to call our factory helper function. Let's test our code. We'll go back to terminal and run db seed again. Seems like it's working. We'll go to Workbench, view our comments table, and our records looks fine, just like before. So our code is working. And now let's fix our user ID as well, so it's not hard-coded to user 1. And also do a little bit of cleanup on our code. Now Laravel does offer us a factory helper function to generate relation records for us. I'll show you how it works. Let's go to our post seeder, and here we know that this seeder file is creating 3 posts. And if we want each post to have, say, 3 comments, what we can do is to call the has method and pass in the comment factory object. So we just need to call the factory function on our comment model and pass in 3 to tell it to generate 3 records. And the second argument of the has method is the relationship on the post model that we want to apply this factory on. In our case here, will be comments. This string has to be the same as the relationship method name in post. So after we added this line, Laravel will create 3 comments for each post generated by this factory. And now let's go to our main database seeder and comment out the comment seeder to stop it from truncating our comment table. And now let's go back to our terminal and run db seed again, and go to Workbench, view the comment table. And we now see a lot more records than before, because now our post seeder is generating 3 comments for each post created. In contrast, if you want to generate posts from the comment seeder, we can use the for method. For example, let's go into comment seeder. We can call the for method and pass in a post factory and the relationship name in the comment model. In this case, all of the 3 comments created by this factory will have a post ID set to the post created in here. Personally, I don't really like to use these helper methods in my seeders. The reason is because they create side effects. What I mean by that is, when I call a post seeder, I would only expect it to seed my post table. If you're using the has method, however, it will also create records in the comments table, and that's quite unexpected. And if you left it uncontrolled, it'll create a huge mess. So I tend to avoid using the has and for method when building my seeders. So let's go back to our post seeders and comment out the helper functions. And now we have talked about how to seed one-to-many relations between posts and comments. But what about many-to-many between users and posts? The answer is simple. We can simply loop through the post that we have created and attach users to each post in the pivot table. We'll go back to post seeders and store all the posts that we have created as a variable. The post variable we get here is a collection, so we can call all the collection methods on this object. If you want to learn more about the collection methods, the link is in the description. Here I want to loop through all the posts. To do that, I can call the each method. The each method accepts a callback, which is a function that runs on each iteration. And a callback function accepts an argument, which is the iterated element in the collection. And I'll type in it as our post model for better code auto-completion. In the callback body, what we want to do here is to assign a user to the post. We can do that by just calling the sync method on the user's relation and pass in an array of user ID. For now, I just want one user per post. So in the array, I'll just call the getRandomModel ID again from our factory helper to get a random user ID. And that is pretty much it. Let's go to our terminal, run our seeder again, and go to Workbench and view the post user table. And now you can see that each post is assigned to a random user ID. And that is pretty much it. We have now learned to seed relationship for our models in our database. Seeders are very important and powerful to quickly create a near realistic dataset to test our application. Key takeaway for this lesson: Laravel offers us factory helper functions like has and for to quickly generate relation records for our models. We can use the sync method to generate many-to-many relation records in our seeders. That's it for now, and I'll see you again in the next video. Hey there, Sam! Let's learn to build the API routes in our app. Laravel lets us to define all of our app routes inside the routes folder. As you can see, there are already 4 files in it: API, channels, console, and web. The API file is where we put in our API routes. Channels is where we put in our WebSocket channels, which is something that we'll eventually touch on in this series. If you're not familiar with WebSockets, it is essentially the technology that powers real-time communication. For example, real-time messaging or real-time notification. The console file is where we define simple artisan commands. And lastly, web is where we can put in routes that leads to a web page. So here you can see that when we send a GET request to the root page, Laravel will run this function, which returns the welcome view. The view function is a helper function provided by Laravel that references the view folder inside the resources folder. It simply loads the welcome blade file and sends it back as a response of the HTTP request. And this welcome file is the default Laravel landing page that we see on a fresh installation of Laravel. If you haven't heard of Blade before, it is a native templating engine provided by Laravel for us to do cool stuff in HTML. For example, easily injecting PHP code inside our HTML or writing an if statement to conditionally render part of our web page. Anyway, Laravel Blade is another major component in the framework, and it deserves its own video series. For now, let's go back to writing our routes. We define our HTTP routes primarily in API and web.php. As we mentioned earlier, we put routes that returns a view as web routes, and any other operation that returns JSON response, we'll put them inside api.php. The main difference between these two types of routes is the middleware that the request has to go through before the request hits the router. So if we go to our HTTP kernel, in the middleware group's protected property, the middleware in the web group are applied to all requests that we define as web routes. And the same happens to the API group. So all API routes will have these two middleware applied to them. Okay, now let's go back to api.php and we'll go through the basic of defining a route. When we're designing the API for an app, there are 2 popular choices or architecture in the modern world. One is called the REST architecture, and 2 is GraphQL. I wouldn't recommend GraphQL for a simple app that we're building because it's very complicated to set up and get it to work properly. However, I have attached a few resources in the description if you're interested about GraphQL. For now, let's explore more about the REST architecture. By definition, REST is a set of principles and architectural constraints that aims to help us to build robust API. In a nutshell, a RESTful API would follow these 6 constraints: uniform interface, client-server, stateless, cacheable, layered system, and code on demand. If this sounds like wumbo jumbo to you, don't worry. I'll show you my way of implementing a RESTful API. We know that HTTP requests have 4 common flavors: get, post, patch or put, and delete. Get request is for reading data, post is for creating, patch and put is for updating, and delete is for delete. Together, they are normally known as CRUD operation, which is the acronym of create, read, update, and delete. Now with these 4 operations, we can pretty much do anything with the data on our app. And for every model, we should define routes for each of these operations. And here's a standard convention on how to define these routes. Let's use the user model as an example. Let's start with get. Get means reading data or getting data from the database. Normally for an API, we have two variants for getting a resource. Getting a list of resources versus getting a specific resource. When we're defining the route to get a list of resources, it should be slash and the name of resource in plural form, which in our case here will be users. If we're getting a specific user, it will be slash users slash and a target user ID. It's simple, right? And now for post, it will be a post request to slash users. To update a user, it will be a patch request to slash users slash the target user ID. And to delete a user, again, will be slash user and slash the target user ID. So notice that we're just alternating between slash users and slash users slash ID. By using this convention, we can write a very consistent and predictable API. For other models, we just need to change user into the other names. Okay, now let's define these routes in Laravel. Back inside api.php, we'll define the routes that we just discussed for users. So for the get route, we can use a route facade and call the get method. The first argument is the API URI, and the second argument is the function to be triggered when this API endpoint is being hit. In other words, the second argument is the controller of this route. Laravel will automatically prefix the word API before all the routes that are defined in this API PHP file. So to test this route, I'm just going to return a JSON response with some dummy body. And now let's start our server. I'll go to my terminal and type in php artisan serve. And then in the browser, I'll go to API/users and we see our dummy JSON response. So far, so good. Now back in our code, if you look at the sample routes that Laravel has provided us by default, you can see that it has a request argument in the controller. Now Laravel allows us to inject any kind of dependency into the controller. As we mentioned before, this is powered by the auto dependency resolution feature provided by Laravel. When we type in any class in the controller's argument, Laravel will attempt to resolve the dependency from the service container. So here in the sample code, what Laravel is doing is simply resolving the request class from the service container. And the request object here represents the incoming HTTP request. We can obtain all sort of information from it, and it is needed by most of the API endpoints. Let's take a look at what's inside it. I'll inject it inside our user's controller and dump the object inside the function body. And back in the browser, we can see the object is showing, and it contains all sort of information about the request. We've got headers, cookies, the query parameter, the request method, and all different kinds of useful information. And if you ever need a request, you just need to inject it inside the controller. Isn't that neat? Okay, now let's go ahead and create a second endpoint, which is to get a specific user. And again, we're going to call the get method from the route facade. And the URI will be /users/curly braces ID. Here, the curly braces syntax is how we define a dynamic URL parameter. So this ID placeholder here would represent whatever the user has put in right after the word users. So if the URI looks something like /users/abc, then the router will still match this request. Now in the controller, it will now accept an ID argument, which would represent the ID parameter that we put inside the URI. A very important point to note here is that the argument name must be exactly the same as what we put in inside the curly braces. Otherwise, Laravel wouldn't be able to pass and load the URL parameter for us. Now in the function body, just for demonstration, I'll simply put the ID parameter in it. And let's go back to our browser to test our code. If I put in 1 after users, I get a JSON response where the data key is 1. If I change it to 2, I get 2. And if I put in some random string ABCDE, I get ABCDE as well. Now can you see how everything is connected inside this function? Let's go through this one more time. We put in ABCDE as the URL parameter for which the router would take it as our ID placeholder here. Then Laravel will parse it and load it to our controller as the ID argument. And in the function body, we're simply returning the ID as part of the JSON, which is what we see inside our browser. So here the ID placeholder represents a user ID, and Laravel makes it very simple for us to resolve the model instance. All we need to do is to type hint or inject the dependency in the function argument. So it will look something like this. And now the ID argument would represent the user model record. And now back inside our browser, we'll change ABCDE to user1, and we get a user details. And now you might be wondering, this seems a little bit magical. how does this work? The answer to this lies inside the middleware called substitute binding provided by Laravel out of the box. So if we go back to our HTTP kernel class, inside the API middleware group, we can see a middleware called substitute bindings. And if we look inside it, go to the handle method, we can see some interesting code here. So this middleware is essentially calling two methods on the router: substitute bindings and substitute implicit bindings. And this is exactly how Laravel binds the user ID that we supply in the URL parameter into an actual model instance. There are actually two types of bindings: an explicit binding, which is taken care by the substitute binding method, and implicit binding, taken care by the substitute implicit binding method. And if we read the inline function documentation here, it says this function will substitute the implicit Eloquent model binding. In other words, this function will read our URL and try to inject the relevant model record into our controller, which is what we have seen just now when we bind our user model in the controller. It is considered as an implicit binding because this binding is taken care by Laravel automatically. There's only one caveat for implicit binding, however. That is, as we mentioned before, the name of the placeholder and the name of the argument must match. So if I change my ID argument into some other different name and go back to our browser, hit refresh, and we can no longer see our data. And now if I change my placeholder to have the same name as my argument, hit refresh again, and our data is back. And that is implicit route binding in Laravel. Now let's talk about explicit binding. In contrast to implicit binding, explicit route binding allows us to customize what gets resolved from the binding. To do that, we need to go to route service provider, which is living inside the providers folder in the app directory. And now scroll down to the boot method, and as you can see here, this is where Laravel configure the router. It's loading the API PHP file, applying the API prefix to all API routes, and apply the API group middleware. And the same happens with the web routes. Anyway, to define the explicit route binding, we will code the bind method from the route facade. The first argument is the placeholder name in our route. So if I put in user here, we are telling Laravel that we want to explicitly bind the user placeholder to our custom logic. And the second argument will be a callback function that accepts a value argument which represents whatever the user has applied to our user's placeholder. So if we look at our route just now in our browser, the value argument would be 1 in this case, because that's what we use for the user's placeholder. And here in the function body, whatever we return in this callback function will become whatever we resolve in the controller. So let's try to return some random data here. And back to our route, I'll remove the type hint, otherwise PHP will throw us an error. And now go back to the browser, hit refresh, and we see 1, 2, 3, 4, 5, which is what would return in the explicit binding. I rarely use explicit binding when building an API server, but the tool is there if you ever need it. Alright, let's continue building our routes. The next one will be a post request to create a user, so we'll call the post method from the route facade, and the rest is the same as before. We'll also define the patch request and the delete request. We will implement the actual logic for each route in a future video. For now, we'll just send back a dummy response for each of them. Once we've done that, let's test our endpoints here. I'll use Postman to test these API endpoints, but you're free to use any other HTTP clients. So to test our post endpoint, I'll change the method to post and specify the URL to be localhost 8000 API/users. Click on send and it works. We'll do the same for patch and delete. And they're all working, which is great. It's a good place to stop here. However, there's much more to learn about routes, and we'll continue in the next video. Key takeaway for this lesson: API routes are typically referred to routes that returns JSON, and web routes are routes that returns HTML pages. We define API routes in the API PHP file, and for the web routes, we put it inside web.php. Laravel uses the substitute bindings middleware to automatically load model instance into our controller, and that makes our life much more easier. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! Let's talk about controllers in a deeper level. As we mentioned already, controllers are the functions that run when a HTTP request hits a route that we define in our app. So here in these two routes, the closures here are the controllers for these routes. We also mentioned that we can inject dependencies into our controllers. So here in the users route, we're injecting the request instance into the controller by simply type hinting the class name inside the controller's argument. We can inject as many class instances as we want. For example, let's also inject the request class inside the second route here. And now we can access this request object anywhere in the function body. I'll simply dump it just for demonstration. And now if we go to Postman and send a request to our API endpoint, we can see that our server is responding us with the request dump and also the original JSON response at the end here. Now there's one thing I want to point out here. The order of the injection does not matter. What I mean by that is we can inject the request class after our user model and our code will still work. So let's go back to Postman and we'll send our API request again and we see the same response as before. If you come from a different programming background, this behavior might seem a little bit counterintuitive to you. Laravel is using its auto binding resolution feature here, so just be aware of that. Now let's move on. So as we build our app, we'll need a lot more routes than what we have here. Currently, we're defining our controllers as closures, which are attached directly beside our routes definition. As our code base grows, this will eventually become quite messy and increase the difficulty of maintaining our code. Now, the question is there a better way to organize our code? And the answer is, of course, a big yes. Laravel allows us to define our controllers in their own dedicated class. And the controllers lives inside app HTTP controllers. And there are already 3 files in it. The post and command controllers, which are generated by the artisan make command in the previous video. And also the controllers base class provided by Laravel out of the box. Now if we look inside post controller, we can see that it's a class extending the base controller class and it's got a numbers of methods in it. So we've got the index method, which is used to display a list of our resource. In the case of our user model, we use this method to display an array of our users in the API response. The store method is used for resource creation. The show method is used to display a specific resource. For example, to get the information of user 1. Update is to update a specific resource, and destroy is to delete a resource. Okay, now let's create a controller for our users. I'll copy and paste post controller and rename it to user controller. And now we'll go back to our API routes file and refactor our code. I'll cut the content of our user listing routes and paste it back inside the index method of our user controller. My IDE is complaining because we need to specify JSON response as the return type in the PHP documentation. And then back inside the route definition, instead of attaching a closure, we'll get to invoke the index method in our user controller class. So let's go back to Postman to test our code. I'll visit the listing routes. And it's working. Great! Let's refactor the other routes as well. The next route belongs to the show method. Again, we'll do the same thing. Copy and paste the code in the closure into the controller. And in the show method, we can see that Laravel has already injected the dependency in the controller's argument. Let's change it to user instead of post. I'll select all and change them in one go. I'll do the same for the variable name, otherwise the implicit binding will not work. And finally, update the return type in the PHP doc. Alright, once that's done, we'll go back to the API routes file and refactor the closure to use the show method in the user controller. And next, we're going to repeat the same steps for the store method, update method, and the destroy method. Once we're done, let's test our code again. So go back to Postman and test if each route is working. We'll start with the get routes, the post routes, patch, and delete. Okay, seems like they're all working, which is great. Now if we take a second look at our API routes file, isn't that much cleaner than before? Now if you want to take this to the next level, Laravel provides us an easier way to define our routes under these conventions by using a simple helper method called resource, where we can call it from the route facade. So 5 of these routes are based on a user model. The first argument in the resource method accepts the username, so I'll put in users. And the second argument is the controller for our resources. So I'll just pass in our controller class name here. And that is pretty much it. So this single line of code will replace the 5 lines that we defined below here. So we can safely comment out those lines. Now to verify if we have defined this route successfully in Laravel, we can go to our terminal and type in php artisan route list. This command will list all the routes in our app. So as you can see here, we've got the API endpoint for our users all set up and configured by the route resource helper method. However, there's one issue. If you look closely, the resource method has added 2 extra endpoints, a create route and edit route. The create route is included to show the form to create a new user, and the edit route is to show the form to edit a particular user. We don't actually need these 2 endpoints when we create an API server, because we don't need to worry about the user interface at all in the context of an API server. So to resolve this issue, Laravel actually provides us another variant of the resource method for API server, and it is called API resource. And now let's go back to our terminal again, run php artisan route list again, and the create and edit endpoints are now gone. Personally, I don't like defining my API routes using the resource helper method. The reason is because it seems a bit magical to me. It is not obvious enough for me to know what routes are being defined under this method. Sure, it is nice and convenient, but the convenience comes with the expense of maintainability and flexibility because we're locked into the convention and we can't easily tweak the route definition. In contrast, these 5 lines of code takes a longer time to write. However, as the maintainer of the code, I can tell right away what they are doing without digging into the documentation. So these routes provides more clarity and flexibility in the long run. In the next lesson, we'll talk about the best practices to organize our routes so we can build a robust, maintainable API server that can last for a long time. I'll see you there. Key takeaway for this lesson: controller is a function that runs when a HTTP request hits a route. We can delegate our routes controller into a dedicated Laravel controller class. There are 5 main methods in a controller class. By convention, the index method displays a list of resources. The store method creates a new resource. The show method displays a specific resource. The update method updates a specific resource, and destroy deletes a specific resource. The resource route helper method enables us to easily define API routes. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! Let's take a moment and look at our routes. Currently, we only have built our user routes, but they are already occupying these many lines of code. Imagine we're building a giant app, and there are hundreds of resources in our app. Now, listing every one of them in this api.php file is definitely not the way to go, because we'll end up having 1,000 lines of code and things will become very messy. So what can we do then? One way of solving this is to create dedicated route files for each individual resource. So I'm going to go ahead and create a new folder called API and create a users.php file in it. That will copy all of the user routes and paste it inside this user.php file. And import the routes facades here just to stop our IDE from complaining. And now we'll go back to api.php and load our user routes using the require keyword and supply the path to our user routes. And that's it. And now to check if our code is working, we'll go to our terminal and type in php artisan route list. And as you can see here, all of our user routes are registered as before. So by organizing our routes in this way, we can keep our API file very clean and maintainable. Now the next thing I want to talk about is something called the route group. So let's go back to our user's route. And here sometimes we just want to add the same middleware, route name or route prefix to a group of routes. For a single route, it is simple enough. To add a middleware, we just need to call the middleware helper function from the route facade. Just for demonstration, I'll add the auth middleware to the get user index route. And now if we go back to our terminal again and run php artisan route list, we can see that our index endpoint has an additional middleware, the auth middleware that we just added. That is simple enough, but in order to apply this auth middleware to all of our routes here, copying and pasting this method to every one of them is just too tedious. So a better way to do this is to define a route group. Let's do that. So to apply the auth middleware to all of the routes here, we'll first call the middleware helper function, and after that we'll call the group method. The group method accepts a callback function, and inside the function is where we define all of our routes. Any routes that we put inside this callback function will be grouped together. And now let's go back to our terminal again and run route list. And here we see that all of the routes now have the Auth middleware attached to them. Route group is an amazing feature that can really help us to organize our routes. We can also use it to easily add a prefix to every member in a group. To do that, we just need to call the prefix method. And here, if I pass in heya inside a function argument, this will prepend the word heya before all the user routes here. So if we go back to our terminal and run route list again, you can see Laravel has added heya to all of the users' routes. We can also add route name prefix to our group. Route names are routes layers, so that we can easily refer to a particular route in Laravel, even if the route's URL has been changed at a certain point in the future. Referring to a route using its name can ensure a consistent behavior of our application in the long run. The reason is because the route's URL is more likely to change than the route's name. So I'll always encourage people to give their routes a name. And to give a particular route a name, all we need to do is to call the name method on the route's definition. And the convention that I use is the resource name and the method name, separated by a dot. So now if we go back to our terminal and run route list again, we can see that our index method has now got a name, users index. And now back to our code, we can add a name prefix to our group. All we need to do is to call the name method before the group helper method and pass in the name prefix that we want to add to each route. So go back to our terminal again, run route list, and now all of our routes have a user.prefix added to them. Having this, that means in the name argument for each route, we just need to pass in the method name. So for the index route, I can safely remove the user's prefix. And for the rest of the routes here, I'll use a bit of cursor magic. And boom, it's done. Let's go back to our terminal to verify it. Beautiful. And now I also want to point out that instead of calling the name method, you can also call the as method, which is doing the same thing as the name method. So go back to our terminal again, run our command, and we get the same result. Alright, next, we also got a method called namespace. We use this helper method to help Laravel to find the controller class. For example, here, our user controller class is living inside the app HTTP controller's namespace. So we'll call the namespace method and pass in our controller's namespace. Once we specify the namespace, we can just invoke the methods in our controller class using a string. For example, I'll duplicate our index route, and in the second argument, I can now invoke the index method in our user controller class in a different way. That is, I'll supply the class name directly, followed by an @ symbol and the method name, which is index. And now if we go back to our terminal, rerun the command, and everything is working as before. Personally, I don't really like this approach. The reason is because it's a bit magical. I will much prefer the previous syntax because I can tell right away what it is doing, and it has a much better support on the auto-completion of our IDE. Anyway, it's a personal preference. It is up to you on which one you like better. We can also put this routes attribute in an array. Here's the alternate syntax for what we have already got here. We will call the group method directly from the route facade, and for the first argument, we'll pass in an array. And the array is basically a mapping of the route attributes and their values. So we'll just write down what we've got before in the array. The second argument will be a callback function, and that's where we put in our routes. And just for demonstration, we'll copy and paste all the routes from before and comment out our previous code. Now, one thing we need to be aware is that for the array syntax, if we want to give our routes a name prefix, we can't use the name key. We gotta use the as key. Otherwise, it wouldn't work. So let's change it to as, and we'll go back to our terminal, run a command, and everything works just like before. So far, so good. Again, here's the question. Which syntax should I use? The array syntax or the method syntax? And again, my answer is up to you. It's a personal preference, and both of them would work just fine. I prefer the method syntax, so I'm just going to comment out the array syntax and bring back our previous code. And now I want to point out one more thing before we move on. If we want to attach multiple middleware at the same time, what we can do is to pass an array into the middleware method. So for example, if I want to add the redirect if authenticated middleware, I can just put in the full class name here. And now let's go to our terminal again, we can see that every route here has now got the new middleware. Alright, time to put everything together. Let's talk about a real-world scenario on how route group can really help us to organize our routes. So in large applications, we often find ourselves the need of creating multiple versions of API endpoints. For example, let's say we have two versions, version 1 and version 2. The endpoints in version 1 might be using an older technology stack, but it is fully tested and production ready. And we've got a lot of clients who use it for many years without any issues. And now in the recent years, the company has decided to upgrade the whole system and to use a newer technology stack. So the company introduced a new set of API endpoints and they call it version 2. Now the endpoints in version 2 have different syntax and convention compared to version 1. New clients are encouraged to use the version 2 API endpoints, but maybe not for the existing clients that are using version 1. Not until they have migrated their code base to version 2. So that means the company needs to provide two sets of API endpoints, for the old clients and for the new clients. So now, knowing this scenario, let's learn how we can solve this using route group. Back to our code. To tackle this issue, I'll create a new folder called version 1 in our API folder. Then I'll move my user's route file into the v1 folder. So that means all the routes in the user file belongs to our version 1 endpoint now. And now if we go back to api.php, we'll refactor the required path. And now we'll create a new group that has a prefix of version 1. That means if the client wants to call version 1 endpoints, they just need to supply v1 in the route URL. So if we go back to our terminal, run route list, we can see that all of the routes has a v1 prefix, and that means they belongs to the version 1 endpoints. By having this structure, it's very easy for us to add a new set of endpoints. We just need to create a new folder called version 2 in our API folder here, and proceed to define new routes in that folder. And after that, just reference them in our api.php file with the correct prefix. We haven't defined the routes for comments and posts yet. I'll leave that as an exercise for you. The solution will be in the repository for this project. The link is in the description. Okay, now, two more things before we end the lesson. Let's go back to our users route. And here, since we added the Auth middleware to our users group here, every route will have the Auth middleware attached to it. Sometimes we want to exclude a particular route from the group middleware. For example, I want to exclude the Auth middleware from the index route. What we can do is to call the method without middleware on the route definition. And the method accepts the middleware name that we want to exclude in its argument. I'll pass in auth in this case. And now if we go back to our terminal, list our routes again, and here you can see that the index method no longer has the auth middleware. Looking great. The second thing I want to talk about is we can apply constraint to the URL parameter. I'll show you what I mean. At the moment, the user parameter in our show route can be anything. It can be a number or string. We can tell Laravel to only match a certain character for this endpoint by calling the where method. So in our case here, the user parameter is supposed to be a number. So let's call the where method and implement the constraint. The first argument is the name of the parameter. In our case, it will be user. And the second argument is a regular expression to tell Laravel how do we want to match the parameter. In our case here, we want user to be a number. So I just want to restrict it to numeric value, which can be done by putting in the 0 to 9 character set, followed by a plus character to match any numbers of character. So now in theory, Laravel will only trigger the controller of this route if we provide a numeric value as the user parameter. Let's test our route. I'll comment out the auth middleware because we haven't done any authentication logic yet. And we'll go to Postman and try to find user number 1. It's working, that's great. And now if we change the number 1 to some random string, and we see an error. It says that the get method is not supported for this route. This is because Laravel is no longer matching string for our show route, and that means our constraint is working. If you're not familiar with regular expression, Laravel has a few helper methods for us to quickly define constraints for the URL parameter. So here, as you can see in the autocomplete, we have where alpha numeric, and where number. Alpha means alphabet, so Laravel will only match alphabetical character for the parameter. Alphanumeric means both alphabets and numbers is for numbers. In our case here, we're going to choose where number. In the argument, we just need to supply our parameter name, which is user. And that's it. Key takeaway for this lesson. Route group can help us to effectively organize our API routes. We can either use the array syntax or the method syntax to define a route group. We can add URL prefix, route name prefix, namespace, or middleware to a route group. The where method is useful to add matching constraint to a URL parameter. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! We learned about defining our routes in the previous lesson. However, we'll quickly run into an issue if our app grows larger and larger. At the moment, we're loading our resource routes using the PHP require keyword. For each route file, we have to manually load the file using the require keyword line by line, which is not that pretty or convenient. Imagine if we got 100 different resources, then we'll need to call require for 100 times, and this file will be a mess. It would be nice if we can automatically load all the route files. Let's try to do that. So what we need to do here is to iterate through the v1 folder recursively and require the file in each iteration. To do this, we'll need something called the recursive directory iterator. An iterator is basically an object that will iterate through something. You can think of iterator as loops in object-oriented programming. PHP offers several types of iterators, as you can see here in the autocomplete dropdown. What we're after is the directory iterator because we're going to loop through a folder. In the constructor, we just need to pass in our folder name, which in our case here will be the v1 folder. And now the directory iterator instance is a representation of our v1 folder. And PHP provided us a lot of helper function in this object to easily help us to get file and folders information from our specified folder, which we'll see how to use some of them later on. But our job here is not done yet. To use this iterator correctly, we'll need to wrap it in another PHP class called recursive iterator. It is a confusing class, but if we wrap an iterator in this class, we're going to have access to a few more helper methods that can really simplify our life. To make sure the autocomplete works correctly, we also need to type in our it variable here to have the type of recursive directory iterator and recursive iterator. If we don't do this step, most IDE will not pick up the methods in our iterator object and hence slow us down. Okay, now it's time to go over all the content in our iterator. We'll need a loop that will keep running from item 1 in the iterator until the last item. Initially, the iterator will have its position pointed at item 1 in the content. So what we can do here is to call a while loop that will keep running as long as the iterator has yet to reach the last item. So for the while condition, we can simply call the valid helper method from the iterator. The valid method will return true as long as the position of the iterator is pointing at an actual content. And at the end of the loop, we'll simply call the next method, which will move the position of the iterator to the next item. And this while loop here is the basic barebone on how to loop through an iterator. Now inside the loop, what we need to do here is to check that the iterator is currently pointing at a file. Let's write an if statement to do the check. In the directory, we have files and folders and also the dot directories. The dot directories are the single dot and double dot. Single dot means current directory and double dots means parent directory. We're going to skip the dot directories, so we'll put the not symbol before the is.dot method. And we're looking for a file here, so we also need to check the iterator is pointing at a file. We can call the isFile method for that. Next, we also need to make sure the file is readable, so we'll call the isReadable method. And lastly, we want to make sure the file is a PHP file, so we'll get the current item and get the extension and make sure it is PHP. And now we're done with our check. The next thing to do would be getting the file path and require it. So inside the if statement, we can just type in require and call the key method, which will basically return the file path since we're using a recursive directory iterator. You can also call the current method, which will return us a SPL file info object, and then call the getPathName method to get the full path of the file. I'm going to go with the key method because it is simpler. And now in theory, our code here should automatically load all the files in a v1 folder. Let's try it out. I'll comment out the manual require down here and go to our terminal and run route list. And as you can see here, all the routes are loaded successfully. Now we're polluting our API file quite a bit here. Let's put all this code into a new helper class. I'll create a new helper folder in our app directory and create another folder again called routes. And this is where we can put in all the helper class for our routes. I'm going to go ahead and create a new class here called route helper. And in the class, we'll simply create a new static method. I'll just name it include route files, which accepts a string argument folder. For the method body, we'll copy and paste our code that we have written so far. And back inside API.php, we'll simply call our newly created helper method and pass in the path to our v1 folder. And back inside our helper method, we will refactor the path in the directory iterator to the folder argument. And that is it. Let's test our code. Let's go back to our terminal and run a route list command again. And our routes are still there. Great! Now for your convenience, if you don't feel like writing all this code, I've created a PHP package doing just this. The link is in the description if you're interested. Alright, key takeaway for this lesson. Iterator is an object that allows us to iterate through a series of items. The directory iterator can help us to automatically load our routes in a folder. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. We're going to implement the logic for our controllers in this lesson. Let's start with the post controller. First of all, we've got the index method. As mentioned in our previous lesson, the index method is used to display a listing of the resource. In our case here, we want to send back an array of posts in the HTTP response. Now here, we want to get an array of posts from our database. And Laravel makes this very easy with the Eloquent ORM. To query our post table, we can simply call the query method from our post model and call the get method. The query method here tells Eloquent that we want to start running a query. It is needed for most database operations. And the get method will retrieve the result of the query. So once we're done, we can simply return a JSON by creating a new instance of JSON response. And pass our post inside the body. And also update the return type of this function to be JSON response. Let's test our code. We're going to go to Postman and send a GET request to our index method of post. And we see all of the posts in our response. Now we can also put in conditions in our query by calling the where method. So let's say I only want to get post with ID 1. What I can do here is to call the where method, and I'll specify the column to be ID and the operator is equal, and the value will be 1. If we want a second condition, we can keep chaining the where method as many times as we want. For now, let's test our code. So back in Postman, let's click on send again, and this time we're only seeing the post with ID 1. Great! If we want to look for a particular model by ID, we can also use the find method, which will greatly simplify our code. But for now, we'll leave out all the conditional queries and simply return all the posts. Okay, let's move on. For the store method, we'll create a new post. To do that, again, we'll call the query method on post and call the create method. The create method accepts an array of attributes, and the attributes are essentially the fields in our post model. And we only have two fields, the title and the body. And we'll grab their values from the request. Once we're done, we'll simply return a JSON response with the created model inside the body. Let's test our code. We'll go to Postman again and change our method to post and put in the request body. Change the content type header to application JSON. And we'll click on send. However, we're seeing an error. It says there is a mass assignment exception and we need to add title to the viewable property. So what we did here, when we call the create method, is something called mass assignment, which means assigning multiple model fields at the same time. And by default, for security reasons, Laravel will not allow us to mass assign any fields in the model. The reason is, some people might do this, putting all the request body into the create method. This code here is pretty dangerous in nature because we are relying on a user to pass in the correct field inside the request. If the user happens to know some of the forbidden fields in our database, for example, if our post table has a column called promoted, where the user has to pay in order to get their post promoted. And by default, we don't want the user to be in charge to set the value for this column. So if we simply pass in the whole request body inside the create method, the malicious user might have set promoted to true without paying anything. And that is certainly something that we don't want to happen. So to prevent that, Laravel needs us to whitelist the fields in our model when we want to do a mass assignment. So let's go to our post model. To whitelist the fields, we'll need to set a protected property called viewable, which is just an array consisting of the model fields that we will allow for mass assignment. In our case here, it will simply be title and body. And now our mask assignment should work. And I also recommend you to always be explicit when it comes to supplying the attribute for the correct method. This is to ensure that we know exactly what is inserted into our database, to stop the users from putting in unintended fields. So a word of advice here from me is to never trust the user input. Alright, let's test our code again. We'll go to Postman and send our post request, and it's now working without any error. Beautiful. Let's move on. The show method is easy. Since our post model is already resolved by Laravel, we can just pass it to our JSON response. Let's test it in Postman. And we see post ID 1 in our response. Next, let's implement the update logic for our post. To do that, we can call the update method on our model record, which is already resolved by Laravel. And similar to the create method, the update method also accepts an array of attributes, and is also considered as mask assignment. So Laravel will only update fields that's defined in a viewable array. Now, update is a little bit trickier than create. The reason is we only want to update the fields supplied by the user. For example, if the user only updates the post title, we only want to update the title here, but not the body. In other words, we want to retain the original value for the post body. To achieve this, we can use a null coalesce operator, also known as a double question mark operator. So let's fill out the update attribute array. The title will be request title if it is supplied by the user. Otherwise, we'll use the original post title. Can you see how this works? We'll use the value on the left-hand side if it is not null. Otherwise, we'll use a value on the right-hand side. Isn't that neat? Let's do the same for the body field as well. Now, there are some people argue that instead of explicitly define this array, we can simply call the request only method. The only method will only get the specified fields from the request body. So it pretty much works the same way as our code here. And it is much cleaner as well. And now the question is, which one should we use? And my answer is, it is up to your personal preference. Explicitly defining the attribute array offers more room for customization. So if you want to supply a custom default value for a certain field, it will be easier to do it with our explicit array. I prefer the explicit array, so I'm just going to comment out the line with the request only method. The update method will return us a boolean, true if the update is successful, or false if the update has failed. So we'll provide an if statement here to handle failure, which I'll just return a JSON response with error code 400. If the operation is successful, we'll return the updated model. Let's test our code. We'll go back to Postman, change the method to patch, and I'm changing the title to Hey Ya here. Click on send, and in the response body, we see title has been changed from untitled to Hey Ya. Great! Let's implement the destroy method now. To delete a post, all we need to do is to call the force delete method on the post. The force delete method will return us a boolean. Again, similar to before, we need to handle the fail case. If the delete operation is not successful, we'll return a new JSON response with a status 400. If it is successful, we'll return success. Let's try this out again in Postman. I'll delete post ID 4, and we get a success response. That means post ID 4 has been deleted. And now if I try to get post ID 4, I will expect to get an error. And we do get a not found error. And that's pretty much it. That covers the basic implementation of our controllers method. Here's an exercise for you. Try to complete a comment controller and a user controller. I'll share my solution in the project repository, so feel free to check it out once you're done. Okay, now I want to show you a few more things before we end the lesson. If we go to our user model, you'll notice that there's a property called hidden. This hidden property is basically an array of fields that we want to hide when we convert our model into an array. For example, we have password and remember token here, and these two fields is quite sensitive for our user, and we don't really want Laravel to include them in the HTTP response. The hidden property is very useful for passwords and secrets. Let's try it out in our post model. So if we try to hide the title field, go back to Postman, send a request, and we're no longer seeing our title in the JSON response. We can also append assessor when we convert our model into an array. Our post model has a title uppercase assessor down here. which basically converts the title into uppercase. Now, if we want to always include this accessor in our JSON response, we can add it to the appends attribute. The append attribute will be an array of additional fields that we want to add to our JSON response. In our case here, we just need to add title uppercase in it. Let's go back to Postman, and now we see title uppercase as part of the JSON body. We talked about viewable just now, which is a way to whitelist fields that we can mass assign to our model. That's an opposite of viewable, and it is called the guarded property, which will basically tell Laravel to not mass assign the fields that we put inside this property. So if I put in title, we can no longer insert title in mass assignment. Typically, we only define either viewable or guarded, and they do not coexist. I prefer viewable rather than guarded, because I think that viewable is much more clearer. Again, it's up to you on which one to use. Alright, key takeaway for this lesson. Eloquent is Laravel's official ORM. It provides us an easy API to work with database operations. We use the query method to start a database query, the get method to retrieve records, the find method to find a model by ID, the create method to insert records, update to update, and delete to delete. By default, Laravel protects the model fields from mass assignment. To enable mass assignment, we'll need to define the viewable property in the model. The hidden model will hide model fields when we convert the model into an array. On the other hand, append will add extra fields to the array. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! Suppose we are running multiple database operations, and these operations are dependent on each other. For example, operation number 1 would create a new user, and operation number 2 would create a new post that has the new user ID as its foreign key. And operation number 3 would create a new command that will use the new post in operation number 2 as its foreign key. Now, on the best scenario, everything will go smoothly, and these 3 resources will be created without any issue. However, shit does happen in real life. There's a chance that operation number 2 and operation number 3 would go wrong, and we'll be leaving the new user created in operation number 1 alone in a database. And that is certainly not ideal, because the purpose of the new user created is to have a new post and a new command attached to it. If the new post and the new command are not created, we should also clear out the new user record. And now here's the question. Is there a feature that will take care of this for us? And the answer is yes. And it is called database transaction. So if we put all these 3 operations under a database transaction, the operation in this transaction will only be applied when every one of them passes. If any of the operations in the transaction failed, then the transaction will try to roll back all the changes that have been made so far, and hence go back to the point before the transaction has started. So that means if operation number 3 failed, the transaction will remove the post created in operation number 2 and also the user created in operation number 1. Now, let's go to our code and see how we can use transaction in Laravel. So here we're in our post controller, and let's say whenever we create a new post, we also want to associate the newly created post with some existing users. That is pretty straightforward. We just need to call the sync method from the user relation. And inside the sync method, we'll need to pass in an array of user IDs. And let's just say in the request body, that's an array called user IDs. Now, there are 2 database operations here. One is to create a new record in the post table, and the other one will be inserting records into the pivot table between post and users. Since there are 2 database operations here, there's a chance that one of them will fail. So we do want to wrap them inside a transaction. Laravel makes it extremely simple for us to start a transaction. All we need to do is to call the DB facade and the transaction method. The transaction method accepts a callback function, and this is where we define all of the operations involved in this transaction. Let's refactor our code to fix the error. Now, whatever we return in a callback function will be the result of the transaction. I'll return the created post in a callback function so that we can reference it in a JSON response. Okay, let's test our code. We'll go to Postman and send a post request to create a post. We'll define our request body and set a title field, body field, and a user IDs field. Click on send, and we get a response back. Seems like our code is working. Let's verify if our pivot table got populated. We'll go to Workbench and view the post user table. And as you can see, we have post ID 5 linked to user 1 and 2. Great! And that's basically it. That's how we can define a transaction in Laravel. Key takeaway for this lesson: Database transaction groups multiple database operations together and only applies the operations when all of them passed. It will roll back any changes if one of the operations failed. We use a transaction method in a DB facade to trigger a transaction. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. Currently, we're returning custom JSON response for each controller method. It is not very consistent, and as our app grows larger and larger, it will go out of control very quickly. It will become very hard to maintain, especially when we want to refactor our code or add a new field to every one of our JSON response. For example, a meta field that consists of the metadata of the response. And now the question is there a better way to do this rather than using a custom JSON response? And the answer is, of course, yes. And it is something called resource class. Let's create a resource class for our post model. To do that, we'll go to our terminal and type in php artisan make resource and provide our resource class name after it. I'll call it post resource. And now, in our HTTP folder, we notice that Laravel has created a new folder called resources, and inside it we have our post resource file. Let's open it, and it turns out to be just a simple PHP class that extends a JSON resource base class. There's only one method in this class, the toArray method. Whatever we return in this method will become whatever is inside the JSON response received by the client. So in our case here, we are writing a resource class for post. So we'll return an array with the post fields in it. The resource class has access to all the model attributes. So to get the ID of the model, we can just use this keyword and get the ID magic property. And we'll do the same for the title and the body attributes. And if you're wondering, how does this class magically retrieve our model attributes? Here's the answer. We'll need to dive into the JSON resource base class and the delegates to resource trait, and scroll down until we see the get magic method. So as you can see here, this method overrides the default behavior of PHP and attempts to grab the property specified by the user from the resource property. And if you want to know what is this resource property, we'll need to go back to the JSON resource class, scroll down, and we can see that the resource property is set within the constructor. So that means at the time when we instantiate the resource class, we'll need to pass in our model record in order for it to work. Let's try this out. We'll go back to our post controller, and in a show method, instead of returning the custom JSON response, I'll make it return our post resource and pass in our post model in the constructor, and also fix our documentation so our IDE will stop complaining. Let's test our code. We'll go to Postman and try to view post number 1. And it works. We're missing the created add and updated add fields, so let's add them inside the resource class as well. Let's try again. And it works. Now let's go back to our post controller. In our index method, we're returning an array of posts. That means we can no longer return just an instance of the post resource. Instead, we need to return a collection of the post resource. To do that, we need to call the collection method from our post resource class and pass in our post collections in it. We'll fix the documentation again to stop our IDE from complaining. Okay, let's test our code. We'll go to Postman and send a GET request to the index method. And as you can see in the response, we have all of our posts. So far, so good. Next, we'll just refactor the remaining of our controller to use our post resource. Okay, that's it. We still need to create a resource class for comments and users. I'll leave it as an exercise for you. Again, the solution will be in the repository of this project. The link is in the description. Resource class can be very handy when we want to change the details in our JSON response. All we need to do is to go to our model resource and change the return statement of the toArray method. Without the resource class, we probably need to go through a million lines of code and refactor the controller method one by one. So try to make good use of the resource class and you'll thank yourself in the long run. Key takeaway for this lesson: resource class helps us to manage our API JSON response in one place. It makes our API response to be more consistent and maintainable in the long run. We can use the PHP artisan make resource command to generate the resource boilerplate. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. Currently, the way we implement our index method in the post controller is not that great. The reason is, if we've got a million records of posts in our database, we're going to fetch all of the posts and send them back to the HTTP client in one go. And that's certainly not something that we want to happen, because it's not only slow and it's going to cost us a lot of server bandwidth by transferring a huge amount of data over the network. So what can we do about this then? The answer is something called pagination. Pagination, as the name implies, means that we display the results on a page-by-page basis. For example, I'm pretty sure you have seen this kind of things before on some other websites at the bottom of a page. When you click on page 1, you'll see the first 50 results, page 2, the next 50, so on and so forth. And this is what we know as pagination. And now, let's look at how we can implement this in Laravel. Laravel makes it very easy for us to implement pagination in our JSON response. So instead of calling the get method, we'll need to call the paginate method. And we can pass in the page size as its argument. I'll put in 20 for now. And that's it. Let's test our code. We'll go to Postman and send a GET request to the index method. In the response body, we still see our data. However, if we scroll down, this time we'll see an additional field called meta added inside the body. And the meta field captures everything about the pagination. We can see our current page, the item index that the current page starts from, the last page, links, path, and other information. Let's load our database with a lot more data for us to understand this in more details. I'll go to our post header and get a factory to generate 200 records. And comment out the untitled state for a more randomized data set. Now let's go to our terminal and run php artisan db seed to trigger the seeders. Once that's done, we'll go back to Postman and send our request again. And now in the response body, we still have our data, but it is limited to only 20 records. And in the meta fields, the current page key tells us that we're currently on page number 1. The from and to tell us that we're viewing record 1 until record 20. Last page tells us that there are 10 pages in total. Links is a helper attribute for us to easily generate the pagination UI at our front end. So each item has a URL, label, and active attribute. Path is the URL of the endpoint. Per page is the page size of the pagination. And total is the total numbers of records. Now, we're currently viewing page number 1. If we want to view page number 2, we simply need to supply the page query parameter in our URL. So I'll just put in a question mark, page equals to 2. Click on the send button. And as you can see, now our records ends at ID 40. And in the meta field, it says that we're currently in page number 2, viewing from record 21 until 40. And that's pretty much it. Isn't that easy? Now, sometimes we do want to let the client to supply their own page size. Currently, we're hardcoding it to be 20, and that's certainly not flexible. So what we can do is to go to our index method and get a page size query parameter from the request. I'll inject the request class, grab the page size. If it is not supplied, we'll default it to 20 and pass the page size variable into the paginate method. And now if we go back to Postman, I'll supply a new query parameter to set page size equals to 5. And now in the response, we can see that it's only showing 5 results per page, which is great. If you're wondering how does Laravel do all of this magic behind the scene, here's a quick rundown on what's going on. Let's take a look inside the paginate method. On the first glance, it looks pretty scary, but it's actually quite simple. So on the first line here, Laravel is trying to resolve the current page number, which is applied through the page query parameter. If you want to customize the parameter name, you can pass it into the third argument of the paginate method. By default, it is page. And the second line here, it is getting the page size. If we did not supply any page size in the argument, Laravel will then try to resolve it from the default value in the model. And if we look inside this getPerPage function, we will find out that the default value is 15. Once we got the page size, Laravel will try to retrieve the results for the pagination. The first thing it will do is to get a total count. If the total count is not 0, it will try to call the forPage method, which will do something called chunking. In other words, splitting the results evenly into groups according to the page size. If the total count is 0, however, Laravel will simply set the results to an empty collection. And once we get the results, we'll simply create a new Paginator instance, which will later be passed on into our resource collection. The Paginator is the one that is responsible for the other fields other than the data. In other words, the links field and the meta fields inside the JSON response. And that is pretty much it. Pagination is a huge part in our API design. Without pagination, we probably need to send all of our database records to the client, which is very bad in practice. Try to implement the pagination logic for the command controller and the user controller. That will be the exercise for you in this lesson. And as always, the solution will be in the repository of this project. Key takeaway for this lesson: pagination is the notion of displaying our query results by page. Otherwise, we'll have to send everything to the client. We call the paginate method on our query to create a paginator. We can then pass the paginator to our resource collection for a paginated JSON response. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! So far we have been creating or updating our model's record directly in our controller. This is generally okay when we are writing a small app. However, as our app grows larger and larger, we might want to create our model or update our model in multiple places other than the controller. In that situation, we only got two choices. One is to copy this block of code. Two is to create a generic function to create our model. Copying and pasting code in programming is a big no-no. So let's go with option 2. To implement option 2, I want to introduce you a software pattern called the repository pattern. A software pattern is a way to write code or a code design paradigm so that the code in our software will be more maintainable in the long run. And to simplify, a repository is a class that handles operations related to our model. So if we're going to create a repository for our post model, the post repository will contain methods that creates or update our post. Let's give it a shot. I'll create a new folder in our app directory and I'll call it repositories. And then I'll create a new PHP class called post repository. Within our post repository, there are three main methods that we want to implement: the create method, update method, and delete method. And now you might be wondering, hey Sam, why don't we have any read method that gets data from our database? And my answer is, you can put in some read methods in our repository if you want. However, for me personally, Eloquent has already provided a lot of helper methods to get our model records. And whenever we want to query something, the query condition is always different. So it just makes more sense for me to write Eloquent's query directly rather than putting a logic inside the repository. Anyway, let's get started on writing our repository. To implement our create method, we'll simply copy and paste our code from our post controller. And we'll get our create method to accept an argument called attributes. So instead of request, we'll refactor it into getting the data from the attribute array. Now Laravel has a helper function called dataGet that lets us to easily get a value from an array by the key. The first argument is our target array, which will be attribute in our case. The second argument is the key, and the third argument is the default value. So for title, I'll give it a default value of untitled. And I'll refactor the rest of the code to use the dataGet helper function. Once that's done, we'll go back to our controller and refactor our store method to use the post repository. So I'll inject an instance of the post repository in the argument and call the create method from the repository. And in the create argument, we'll call the only method on the request to filter out the request body that we want, which in our case here will be title, body, and user IDs. And that is pretty much it. Let's test our code. We'll go to Postman and send a post request to the post endpoint. Set up the request body. Click on the send button. And we get a response. That means our code is working as before. Great! Let's go ahead and implement the update method and the delete method as well. Again, for the update method, I'll copy and paste the code from our controller and do a little bit of refactoring. First, to grab the attribute values, sync the user ID relationships, and wrap our logic within a transaction. Throw an exception when our model is not updated. And finally, return the updated post. And back in our controller, we'll refactor the code to use the post repository. And we'll do the same for the destroy method. Okay, now let's test our code. Again, we'll go to Postman and try to patch the post that we just created with a different title. Click on the send button, and we get a response with the updated title. Great! Let's try to delete our post. I'll switch the method to delete, click on the send button again, and we get success in our body. Beautiful. Okay, now let's go back to our repository and do a bit of maintenance work. First of all, we're gonna have a lot of repository in our app. Ideally, one repository per model. So it makes sense for us to create a base repository class so that all of our repositories will extend from it. Let's create a new class. I'll call it base repository. And it'll be an abstract class. Next, we'll define our methods as abstract methods to force the child classes to implement them. Now we'll go back to our post repository and make it extend from our base repository class, and refactor our type hint to stop PHP from throwing us an error. And that's it. That's our post repository. We still need to create our post repository and users repository. I'll leave that as an exercise to you. Now, some people might argue that creating a repository unnecessarily increases the complexity of our code. Their argument is valid, and I won't say they are wrong. In my opinion, I like the fact that we can manage our model operation in one place, and that really is the problem that the repository pattern is trying to solve. In the end, it is your personal preference to decide what tools to use. Key takeaway for this lesson: repository is a class that takes care of model operations. It manages model operations in one place, and hence improve the maintainability of our app. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. So we have been throwing custom exceptions in our repository to handle an error. There's actually a better way to do this. Laravel provides us a handy system to handle exceptions. Now, if you look at the app folder, you'll notice that there's a folder called exceptions. And inside it, there's a file called handler.php. The handler class is the core of how Laravel handles exceptions. And inside the class, you'll notice that there's a few properties that configures how the handler works. We'll come back to this in just a few minutes. Now, let's go back to our post controller and look at how we can use Laravel's exception handler. First thing first, let's investigate how would Laravel behave if we throw a normal PHP exception. So in the index method, I'll throw a random exception, and we'll go to Postman and send a GET request to a post index endpoint. And now, in the response, we get our exception. It is not that pretty, unfortunately. It would be great if we can get a proper JSON formatted string as the error response. To achieve that, we'll need to create a Laravel exception class. And Laravel makes it very easy for us to create one. We just need to head to our terminal and type in PHP Artisan make exception, followed by the exception name. I'll call it general JSON exception. And now if we go to our exception folder, you'll notice that Laravel has created a new file for us, and it is our general JSON exception class. In a typical exception class, we have two methods, the report method and the render method. The report method is responsible for any reporting logic. So when an exception is thrown, we might want to send an email to the admin or notify our monitoring service provider. On the other hand, the render method is responsible for sending back the HTTP response. So whatever we return in a render method will become whatever we receive in the HTTP client. So in our case here, we want to return a JSON response, which contains the error message. And since the exception class extends from the base PHP exception, we can call the native PHP getMessage method to get the error message. And for the second argument of the JSON response constructor, we need to supply the error code. And again, we can get it from the code property of the exception class. And also, if you need anything from the request, you can get it from the request argument. Alright, let's test our code. We'll go back to our controller. And now throw the general JSON exception rather than the normal exception. And also supply an error code of 422. And now let's go back to Postman. Click on the send button again. And this time, we see our error message in a beautifully formatted JSON response. And also with the error code that we defined. Okay, now let's talk about the report method. As I mentioned before, the report method is responsible to report the exception. We can put in anything we want here. For example, logging the error in a file or sending an email to the system admin. The report method will run before the render method. So if I dump a string in the report method, and we'll go back to Postman, click on the send button again, and we see our string ABC displayed before the JSON string. Okay, now, since our exception class is a child of the base exception class, we can override the properties and methods from the base exception class. For example, I can override the code property and set it to error code 422. So now, whenever we throw an instance of our general JSON exception, by default, it will send back a 422 error code. Okay, let's talk about the base handler. The first property that we see here is the don't-report property. We put in an array of exception classes here to tell Laravel to not run their report method. For example, currently, our general JSON exception has a report method that simply dumps a string ABC. So if I put a general JSON exception class inside the don't-report array, the report method will not run. Let's test it in Postman. Click on the send button again, and we're no longer seeing our ABC string in the response. The don't-flush property contains an array of user input fields that we don't want to flush to the user. Flushing means to display a message to the user on a user interface. It could be a success message or a validation error message. Either way, flushing is not that relevant to us because we're building an API server, and we don't have any user interface to display the error. Next, we have the register method. The register method is the place where we define the handling logic when an exception is thrown. This is an alternative to the exception class that we just created. Typically, we call two types of methods here, the reportable method and the renderable method. Both methods accept a callback function as their argument, and the callback function will be the handler of the exception, and we will type in the exception type that we want to handle in the callback argument. I'll show you what I mean. I'll simply dump a string here and comment out our general JSON exception in the don't-report array and type in our exception in the callback function, and we'll go back to Postman, send another request. And we're not seeing the string dump in the response because we defined a report method in a general JSON exception class. The report method in our dedicated exception class will overwrite any reportable callbacks. So let's go to the general JSON exception class and comment out the report method. Let's try again in Postman. And now we see our string 123456. And the same applies to renderable. We can type in an exception in the callback function and write the handling logic inside the callback body. I prefer to put my exception handling logic to their own dedicated exception class because I think it makes more sense and is easier to maintain. Creating well-defined exception classes can make sure that our API return consistent responses and the errors are handled and reported correctly. It is a huge part in an API server, so having a good design means that we can go for a long way. Now that we have defined our JSON exception, we can start refactoring our code to throw our custom exception. We'll go to our controller and remove the exception in our index method. And next we'll go to our post repository and amend our code to throw some error when the database operations has failed. So in the create method, we'll throw our custom JSON exception when we failed to create our post. Laravel also provides us a helper function to conditionally throw an exception. So we can replace our if statement here with the throw if function. The first argument is the condition to throw the exception, and the second argument is the exception class. And the third argument and onwards are the parameters to be passed on to the exceptions constructor. Isn't that neat? Next, we'll do the same for the other methods, so that they're all using the general JSON exception class. And that is pretty much it. Now before we end the lesson, I want to introduce you a few helper functions related to exceptions. Let's go back to post controller. Sometimes we just want to quickly send back an error response. We can quickly do that by calling the abort function and passing the error code. So if we go back to Postman and send a request, we see the 404 not found error page. We can also call the report helper function to manually trigger the report method in an exception class. So if I call the report function before the abort function and pass in a new instance of our general JSON exception class, go back to Postman, send another request, and we see the string dump in the report method just before the not found page. And that's it. These two helper functions could be very handy when we want to handle a simple one-off exception. Again, handling exception appropriately is extremely important when we want to build some serious app. We'll need to make sure that every error response has a consistent format with helpful error messages. As an exercise for this lesson, I want you to try and build your own exception classes and put them in the other repositories, like in a user repository and a comment repository. There's no right or wrong way to do it as long as you keep the format and message consistent. And make sure that you maintain a clear folder structure. Again, the source code for this lesson is in the description. Feel free to check it out if you're stuck. Key takeaway for this lesson: creating custom exception classes in our app can ensure consistent API responses for error handling, so that our API client can always expect the same format of error response. The report method in our exception class is responsible for reporting or logging the exception. The render method is responsible to send the error back to the HTTP client. The abort helper function is a quick way to send back an error response. It is very handy when we just want to send a one-off error message back to the client. The report helper function calls the report method in a specified exception class. Again, this is useful in situations where we just want to send a one-off exception report. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. In a web app, it would be nice if we can carry out certain operations after an operation has been completed. For example, when a new user has registered for an account, we might want to send a new user a welcome email. To implement this, it is tempting to put the logic inside the store method of our user controller right after we created a user. While this might work, it is far from ideal, because we might end up flooding our controller's method with 100 lines of code to implement the mailing logic. So what can we do then? At this point, we can either create a service class where we put all the mailing logic in it and call the service class method in our controller. Or we can choose another way, which is to use the event and event listeners. Here's how it works. When a task in our app is completed, we can get it to fire an event. For example, an event called user created. This event will then be broadcasted throughout the whole app. And if we have defined an event listener for this particular event, then the code within the listener will be triggered and carry out its responsibility. For example, sending out a welcome email to the user. An event listener is just a function that listens to a particular event. Alright, let's take a look at an example and we'll see how we can implement events and event listeners for our app. Let's go to our user repository. In our repository, we have three methods: the create method, update method, and delete method. What we're going to do now is to create an event for each of these methods. So to create an event, we can use PHP Artisan to do that. We'll go to our terminal and type in PHP Artisan make event, followed by the event name. I'll call it user created. And now you'll notice that Laravel has created a new folder called events in our app folder. And there's our event class created in it. Let's take a look at our class, and you'll notice that there's quite a few things going on here. First of all, by default, the event class is using a few traits out of the box. Events in Laravel are meant to work with queues and Websockets, and these traits provide the corresponding functionalities for the event class to work with queues and Websockets. We'll discuss more about queues and WebSockets later in this course. You don't need to worry about them too much for now. The next thing to take note here is the constructor. Typically, when we create a new event, we'll pass along our model, which in our case here will be user. So I'll just make the class to accept a user model and set a user model as a class property. The last item here is the broadcast on method. This is related to WebSocket, and we don't need to worry about it for now. Just a quick explanation, this method will tell Laravel to publish this event on a specified WebSocket channel. And by default, as we see here, Laravel will publish this event on a private channel called channel name. Okay, now we have created our event class. Let's learn to fire this event in our app. Let's go to the user repository. We want to dispatch our event right after our user is created. To do that, we can simply call the event helper function and pass in a new instance of our event class, where we'll pass in our newly created user inside the constructor. And that's it. Now let's also create an event listener for our user created event. We'll go to our terminal and run a php artisan make listener command. We want to send an email, so I'll name our listener send welcome email. Hit enter, and now back to our app folder, you'll see that there's a new folder called listener being created, and our listener class is in there. Let's take a look inside our listener class. It is a simple class with only one method, the handle method. The handle method is where we define the logic on what we want Laravel to do when the event is dispatched. In our case here, we do want to send a welcome email to the user, so in the handle method, I'll simply dump a string to say email sent. And now, just for demonstration, we'll go to the index method of the user controller and dispatch a user created event there. Because I don't really want to create a new user, just to test our event listener. Again, we'll call the event helper function and create a new instance of our user created event and pass in a dummy user model by using our model factory. Okay, now we've created our event. Let's link our event to our listener. To do that, we need to go to our event service provider. And in the listen property, we need to provide a mapping of our event class to its event listener. Once that's done, let's test our code. We'll go to Postman and send a request to the index method of our user controller. And as you can see in the response, we see our string dump from our event listener. That means our listener is running perfectly. Great! And now we still need to create two other events for our user model, the user updated event and the user deleted event. We also need to think about the other models as well. If we put all of our model events in one single folder, it'll be very hard to maintain in the long run. So it is a good idea to separate our model events into their respective folder. So I'll create a new folder called models in our event directory and go ahead and create another folder called users in it. And drop our user created event into our user folder and refactor the namespace. Once that's done, we'll go ahead and create the updated event and deleted event for our user. And dispatch the event in the corresponding repository methods. Okay, now we're done. We might want to also create an event listener for each event and link them inside the listen property of our event service provider. Sooner or later, this array will become very big and very hard to maintain. So what can we do then? Laravel has a solution for us to better organize our event and listeners mapping. It is something called the subscriber. Let's learn to create a subscriber for our user event. Unfortunately, Artisan does not have any make subscriber command, so we need to create a class from scratch. I'll go ahead and create a new folder called subscribers in our app folder and create the model directory in it, and finally our user subscriber class. Now within the subscriber class, we need to define a subscribe method. This is where we define the mapping between our user event and their listeners. The subscribe method accepts an instance of the dispatcher, so we can type in it for better IDE support. And now inside the function body, we can simply call the listen method from our dispatcher to map our event to our event listeners. The first argument is the class name of our event, and the second argument is the class name of our event listener. And now to register our subscriber, we need to go back to the event service provider and put it inside the subscribe property. And now, just for demonstration, I'll comment out our mapping in our listen property and go back to our user controller, refactor our namespace import, and go back to Postman, send a request again, and we still see our string dump. Using subscribers only makes sense if we've got a lot of events. For small application, using just the listen property will be enough. We still need to create the events for our post model and our comments model. I'll leave that as an exercise for you. Again, the solution will be provided in the project repository. In the next video, we'll learn about how to actually send an email to the user inside the event listener. I'll see you there. Key takeaway for this lesson: event listeners are classes or functions that gets executed when an event is dispatched. We define our event to event listeners mapping in the event service provider. Event subscriber is a class that allows us to group our event to event listeners mapping in one place. We register our subscribers in a subscribe property from the event service provider. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. Our goal is to send a welcome email whenever a new user is created. Laravel has classes to take care of email sending. To create a mail class, we can use the PHP artisan command make mail and supply the class name after it, and I'll call it welcome mail. And now in our app folder, you'll notice that there's a new folder called mail, and our welcome mail class is created inside it. In summary, the purpose of a mail class is to define the email itself. So we put in things like the email template, the email title, what kind of data should the email accept inside the email class. And now if we look inside the file, it is just a class that extends the base mailable class. And there's only one method in it, the build method. And build method is exactly the place where we define how should we create the email. So things that I mentioned just now, like the email title and so on, should be put in here. By default, the build method is returning the result of the view method. The view method is a helper function to return a view template from the view folder. And the view folder is located inside resources, views. And Laravel is using the dot notation to access files inside the views folder. Let's create a new folder inside the views folder, and I'll call it mail. From now on, we'll put everything related to mail inside this mail folder. And now let's create a welcome email template in our app. By default, Laravel uses the Blade templating engine, so all the template files will need to end it with .blade.php. I'll go ahead and create a welcome mail Blade file. And inside the template, I'll simply put in a h1 in it, just for demonstration. And now, back to the welcome mail class. To refer to our newly created Blade file, all we need to do is to type in mail.welcomemail. So the dot notation is a simple way for us to provide a reference to a file relative to the views folder. Let's see if our mail class is rendered correctly. To test this, we'll create a dummy web route. So we'll go to our web.php route file and add a get route. I'll call it playground, just because it's a playground for experiment. We only want to enable this route under local development environment. So I'll wrap it within an if statement to make sure our app environment is local. And for the controller function of our route, we'll simply return a new instance of our welcome mail and call the render function on it. The render function will simply build and return the HTML representation of our email. Let's give this a go. We'll go to our browser and visit our playground route. And it works. We see a big fat welcome in our browser. Alright, so far so good. Laravel also provides us a way to write our email using Markdown, which is a nice and convenient way to quickly write an email template. So we'll go to our welcome mail Blade file, and to write our email template in Markdown, we'll start by using Laravel Blade's components directive, which is an @ symbol followed by the word component. And the component directive takes in an argument that specifies what components do we want, which in our case here will be mail message. I'll show you a list of all the available components later. But for now, let's see how does this look like when it is rendered in the browser. The component directive provides us a layout to our mail template. We're going to use Markdown from now on, so I'll replace our h1 with its corresponding Markdown syntax, which is just a hash key followed by the welcome text, and also provide a simple email signature at the end of the email. And now let's go back to our mail class, and in order for Laravel to be able to pass Markdown template, we need to call the Markdown method instead of the view method. And now let's go back to our browser, hit refresh, and boom, we see a different world. Isn't that neat? This layout is provided by the mail message component as we put inside our mail template. However, there's one issue here. The email layout is using Laravel's logo and Laravel's company name in the footer. Let's try to change them. We can change the company name in the footer quite easily by changing our app name in the .env file. So if we go to our .env file and change the app name key from Laravel to LivePost and refresh our browser, we can now see the email template is now white labeled to our own brand. Isn't that easy? If you want a deeper customization to change the styling, the color, and the layout structure of our email template, we can go to our terminal and run php artisan vendor publish and select the mail tag. This command will publish all the default assets from Laravel so we can customize them in however way we want. And now you notice that there's a new folder called vendor appeared in our views folder. And inside it, we can see different types of mail components, which are all fully customizable to fit our application's need. And now I want to show you all the mail components that are available to us. Let's go back to our Blade file and I'll paste in examples of all the components. So we've got a button component, panel, table, and subcopy. We can pass in a redirect URL to the button in an option array in the second argument. And just for demonstration, I'll put in google.com as the redirect URL. And now let's go back to the browser to take a look at these components. We will refresh the page and boom. However, there's some issue with the table. It is not rendered properly. It turns out that Laravel Blade does not like indentation that much when we write our Blade file in Markdown syntax. So let's try to unindent our code so that Laravel can pass our Markdown syntax properly. We'll go back to our browser, hit refresh, and yay! The table is now rendered properly. And if we click on the button, it'll bring us to Google. Great! Now, it would be nice if we can address our user by their name, rather than a generic welcome text. To do that, we're going to go back to our email class and make the constructor to accept a user model so that we can pass it to our view. Let's make the user into a class property, and to pass data into our view, we simply need to pass a second argument to the markdown function. The second argument will be an array of information that we want to pass to the view. In our case here, we want to pass the username to the view, so we can simply grab it from the user property. And now back inside our Blade template, we can use the double curly braces followed by the array key as a variable to access the data passed to this view. And now back inside our route, we now need to pass in a user when we instantiate our mail class. So I'll call the user factory to generate a user on the fly. Once we're done, we'll go back to our browser, and now if I hit refresh, we see the username after the welcome text. And every time I refresh, we see a new name, because there's a new user generated by the factory. Great! And that's how we can pass data to a view. And now, let's learn how we can actually send out an email using Laravel. To do that, we'll need a fake SMTP server for testing purposes. I highly recommend Mailtrap.io. It is free for personal use. Once you sign up for an account and log in to the dashboard, you should be able to see this page, where you can get the API key to send test emails. To get Mailtrap.io to work with Laravel, in the integration dropdown, we'll select Laravel and simply copy and paste the settings here to our .env file. And while we're on here, let's also set the from address to some dummy email account. Once we're done, at this point, we should be able to send out emails from our Laravel app. And now let's try to send out an email. We'll go back to our playground route, and to send an email, we can use the mail facade and call the to method to specify the recipient. I'll store a dummy user as a variable and pass it to the to method. And then we'll call the send method and pass in an instance of our welcome email class to get Laravel to send out the email. We're not quite done yet because we haven't set the subject of our email. Let's go back to our email class, and in a build method, we'll call the subject method in it to define the subject of this email, which I'll just simply write down, welcome to LivePost. Okay, let's test our code. We'll go back to the browser, visit the playground route again, wait for it to finish processing. Once that's done, we'll go to Mailtrap.io, and boom, we see a new email arrive in our inbox. And that means our code is working fine. Now, there's one last thing I want to fix before we end the lesson. Currently in our email template, we're hard coding our app name in the email signature. This is not a good thing to do. Let's fix this. we did put our app name in the .env file, and Laravel stored this value in one of the config file, and we can get our config value by using the config helper function, and the key to it is app.name. Again, the config function accepts dot notation, which is a reference to a value in Laravel's configuration files. You can find these configuration files in the config folder of our project root. And if we look inside the app file, we can see that there's a property called name that is referencing the app name key in the .env file. So our config helper function here is simply referencing that value. Anyway, let's send our email in our user created event listener so that every time when a user is created, we'll send out this welcome email. So we'll go to our send welcome email event listener, and in the handle method, I'll call the mail facade to send out the welcome email. We need to pass a user model in the to method of the mail facade. The event parameter in the handle method will be an instance of the user created event. We do have the user model in the user created event. In other words, we can make this property public, and back to our event listener, we can simply pass our user to the to method and also to the constructor of the welcome mail class. And that is pretty much it. That's how we can send out an email in Laravel. Key takeaway for this lesson: the Laravel mail class offers us an easy way to define and send out application emails. Mailtrap.io is a fake SMTP testing service that allows us to test email in our local environment, so we can safely send out email without the fear of reaching an actual email account. Laravel allows us to write our email template in Markdown syntax, which is nice and convenient. We can use the mail facade to send out emails. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. Writing software is hard. Maintaining and making sure that our software is working is even harder. And that's exactly the reason on why we always want to test our code before shipping it. When it comes to testing, there are generally a few ways to achieve this. And there are manual testing, unit testing, feature testing, and end-to-end testing, or E2E for short. Manual testing is the one that we're most familiar with. That involves the developer to physically go through the code and check if they're working. On the other hand, the other three in this list are considered as automated testing, and that's where the developer will write a script to test the functions or features in an app. As long as the test cases in this script has passed, we'll know that our app is working. The main benefit of automated testing is that we can quickly test our code with minimal human input, and it will really shine if we are building a large app. So the idea is, every time if we add a new feature or functions to our code, we would run the automated testing script. And as long as the script passes, we can be sure that the newly added code is not breaking our code. And this is very, very useful because we no longer need to go back and manually redo the test for all the functions and features that we have written before. Now let's talk more about the differences between unit testing, feature testing, and end-to-end testing. Unit testing, as its name suggests, is testing done on the smallest possible unit in an app. And the smallest possible unit in an app is normally a function. In other words, you can think of an app is made out of a lot of small functions that work together to deliver a feature. So the idea of unit testing is to write a test for all the functions in our app. If all the tests passed, that means all the building block of our app is working, so our app as a whole should work, right? Well, not really. That is not necessarily true. Here's a few examples on what could go wrong when we solely rely on unit testing. They are sad but true. Unit test is meant to be fast to execute, but not necessarily reliable. In contrast, feature testing is the notion of testing a feature in an app. Feature testing is a higher level approach compared to unit testing. It focuses more on the feature rather than making sure that each function in our app is working. And that makes it a more reliable test compared to unit testing. For example, suppose we are testing for the post creation feature in our app. In the case of unit testing, we would test for something like, can we insert a title for the post? Or can we insert a body for the post? Does it accept a string, a number, or an array? Are we expecting an exception when we give it a different data type? And other smaller functions that build up the post-creation logic. Now for feature testing, we'll be looking at different things. We will only care about if an operation will actually create a record in our database. So if we were to run the post-creation logic, in feature testing, we'll go ahead and fetch the newly created record in our database and verify it and see if the title and the body were inserted correctly. End-to-end testing is the highest up in the food chain. is on an even higher level than feature testing. In a nutshell, end-to-end testing would actually mock the user interaction and test our app as it mimics an actual user. For example, if we were to test our post creation logic, an end-to-end testing will be a script that actually tries to visit the web page in our app that creates a post. The program will attempt to submit the form on behalf of the user and validate the result to see if it's actually working. And similar to feature testing, end-to-end testing doesn't care about the individual functions in our app. Instead, it'll put a lot of emphasis on the output of the app, which in our example that we just discussed, it'll test if the form that we used to create the post is working correctly. End-to-end testing is highly reliable but very hard to implement. Now, in terms of reliability, manual testing has questionable reliability because it really depends on how well the tester understands how the program works, and also under the assumption that the tester did not overlook a certain feature in the app. Unit testing is not that reliable compared to the other method. And it is because even though you can make sure that every single function in our app is working perfectly, there is simply no guarantee that they'll work well together as a group. In comparison, feature testing is much more reliable because it ensures that a feature is doing what it's supposed to be doing. End-to-end testing has the highest reliability among them all because it is directly mocking the end user's behavior. In terms of speed, manual testing is very, very, very slow. And the reason is, as we discussed earlier, every time we introduce a new feature, we need to go back and retest all the features that we have done so far in order to make sure the new feature does not break our code. Unit testing is fast because it is testing small functions in our app and they are very lightweight. Feature testing is slower than unit testing because they usually involve database operations or a group of functions running together. End-to-end testing is the slowest among all because mimicking a user is very time-consuming and delicate. End-to-end testing is more relevant in front-end development, and it won't be our focus in building an API server. In the upcoming videos, we'll dive deeper into writing unit tests and feature tests in Laravel. I'll see you there. Key takeaway for this lesson: unit testing is the notion of testing the smallest units or building blocks in our app. In other words, functions. If the basic building blocks are working, then the app should work, although this is not necessarily true. Feature testing focuses on the feature and the outcome rather than the individual functions in our app. It is more reliable than unit testing, but slower. End-to-end testing mocks the end user's behavior and has the highest reliability among all. However, end-to-end testing is very hard to implement and very slow. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! The test folder in our Laravel project contains everything about testing. Laravel uses PHPUnit as its main testing library out of the box. The first thing that we want to look at is the PHPUnit XML file. This is where we set out the configuration for our PHPUnit test. Now, if you haven't worked with PHPUnit before, this file might look a little bit scary to you. Let's quickly go through the key points here. First of all, we see the test suite group here. A test suite means that a group of tests that are supposed to run together. So here we can see that Laravel is grouping the unit test in the unit directory as a test suite, and also all the feature tests. The suffix attribute is telling PHPUnit that we only want to scan files that ends with test.php. Other files will not be included in the test suite. Coverage is the code coverage configuration, and by setting up this configuration, we can tell PHPUnit to generate a nice code coverage report for us. The server elements here are the environmental variables that we would pass to the testing environment. By default, Laravel uses the default database connection as defined in a database configuration file, which in our case will be our MySQL database connection. You are free to set up your own database connection by uncommenting these two lines out and supply your own value. Okay, now once we configure the PHPUnit XML file, the next thing I want to talk about is the structure of the test folder. You'll notice that there are already two files created in it, the create application file and the test case file. In a nutshell, the test case file is an abstract class that set up our test. The test case class is meant to be extended by every single test in our app. The test case class bootstraps and provides us a lot of helper functions for us to write our test code. Now you notice that the test case class is using a create application trait. Let's look at what's inside it. It is a simple trait that contains exactly one method that returns an app instance. This is a very important function because it provides us a mock app instance to the testing environment, and it is used internally by the base test case class. You're free to modify this trait if you want to provide more features to the app instance, or customize how the app instance was instantiated. Anyway, let's see how we can create our first test in Laravel. The easiest way to get started is to use the php artisan command. We'll go to our terminal and type in php artisan make test and supply the help flag to read the documentation. And in here, we notice that if we pass an additional unit flag to it, we'll create a unit test. By default, if we use the command as it is, Laravel will create a feature test. Let's try it out. I want to test our post repository functions. So I'll type out php artisan make test --unit, and the name of the test will be post repository test. And now if we go back to our folder, you'll notice that Laravel has created a new file in a unit directory. And if we look inside it, it is a simple class with one method in it, which is a test example on how we can write our unit test. Alright, let's start writing our test for the post repository. When writing a test, it is important for us to be aware of what we're testing. In our post repository, we have three methods: the create method, update method, and delete method. So we're going to write a test for each of them. As a convention, we use snake case to name the method for our test functions, and we always prefix them with the word test. That way, PHP unit can automatically recognize the test function and execute the test later on. So I'll create three methods in our test class: test create, test update, and test delete. And now, here's the question. How do we get started on writing tests? Here are the general steps that I usually take when writing a test. The first step is to define our goal. In other words, what's the purpose of this function? And what do we want to test? In our case here, we want to make sure that a post can be created by using the create method in a post repository. The second step is to replicate the environment or apply any restriction if available. What this means is to recreate the condition on where we would code the create method in our post repository. In our example here, there's not much to do to replicate the environment or apply restrictions actually, but if we look at some other cases, for example, an e-commerce app, like testing the shopping cart, the environment will be much more complicated to replicate. To test the checkout function in an e-commerce app, we first need to log in a user and get a user to add a bunch of items to their shopping cart. And that's exactly what I meant by replicating the environment. The third step is to define a source of truth. The source of truth is another word for the result expected. So here, if we're going to create a post, we will expect a post created in a database to have a title and body to be exactly the same as what we have passed on to the create method of our post repository. Once we have defined a source of truth, we'll compare the result. And comparing the result means to run a function that we're testing and compare the result returned against the source of truth. Okay, let's get started on writing the test code for our post repository. So step 1, our goal is to test if the create method in our post repository will indeed create a record in the database. For step 2, the only requirement for the environment is to have access to an instance of the repository. So I'll go ahead and create an instance of the repository from the service container. To do that, we need to have access to an app instance. And by default, unit test is extending the test case class provided by PHP unit. It is not using the base test case class provided by Laravel. So we're losing out on a lot of goodies. So let's refactor our code to extend our test class from the test case provided by Laravel. The reason why Laravel has opted to use the test case provided by PHP unit is because unit testing is meant to be lightweight. The test case class provided by Laravel is an enhanced version of the PHP unit test case and therefore much heavier than the original. However, don't let this rule restrict you from doing what you're doing. The more important point here is to write our test properly. So once we loaded the test case provided by Laravel, we have access to the app instance from the this keyword. So to create an instance of the post repository, all we need to do is to call the make function from it. For the source of truth, I'll define a payload for the post that we're going to create. And now everything is ready, and we'll call the create method from our repository and compare the results. Now the result variable should be an instance of the created post model. We need to make sure it has exactly the same title as our payload. To do that, we can call one of the assert methods. The one we're looking for is called assert same, which will compare two values using the triple equal sign. The first argument is what is expected, which in our case here will be the title property in our payload array. And the second argument is what we actually get, which will be the title attribute that we read from the created model. The third argument optionally accepts an error message that will get Phpunit to display for us in case this assertion has failed. It's a good idea to always include this message, as it provides more context on why did the assertion fail. Okay, now let's try to run our test. We need to run a Phpunit binary, which is located inside the vendor folder and the bin folder. We'll hit enter and our tests are executed successfully. We get two risky tests because we haven't implemented the test update and test delete methods. I'll show it to you how would it look like if our test has failed. So I'll go back to our test correct method and change the expected argument to something else. We'll run Phpunit again. And this time we see an error with our custom error message. As you can see here, the custom error message really helps out on telling us why did our test fail. By providing a context, if we put down a very descriptive error message, it can really help us to debug our code. Alright, back to our test class, let's continue to write a test for the update method and the delete method. Again, we're going to follow the 4-step process. First thing first, define a goal. For the update method, we want to make sure that we can update a post using the update method. Step 2, replicate the environment. In this case, we want an instance of repository and also having an existing post in our database. So I'll use the post factory to create a dummy post. The third step is to define a source of truth in which I'll create a payload to update our dummy post. I'll change the title to ABC123. Step 4 will execute our code and compare the result. So I'll call the update method on our post repository and the assert same method again to compare the payload title against the updated post title. Let's run our test once again. Whoops, we get an error, and seems like the error is because our post factory is returning a collection rather than a model instance. To resolve this, I'll simply grab the first element from the result of the create method and run Phpunit again. And bam! This time our test is passing. Great! Lastly, let's finish off our delete test method before we end the lesson. Again, the same thing here. We'll define a goal, which is to test the delete method in our repository and see if it is working. For the environment, we need an instance of our repository and also a dummy record in our database. Again, we'll use the factory function to create a record. We don't have any source of truth, so we can just skip to step 4, which is to compare the result. I'll call the force delete method on our repository and we'll verify if our record is indeed deleted by finding the record in our database. We shouldn't find any record at this point, so the expected result is null. Let's run Phpunit. Whoops, I made a mistake. The result returned by our repository is a boolean and we shouldn't read the ID property from it. So I'll just change it to dummy instead. Let's try again and we see all of our tests passed. Beautiful. We still need to write tests for our user repository and comment repository. I'll leave that as an exercise for you. Again, I'll share my solution in the project Git repository. So feel free to check it out if you're stuck. Now, I do want to talk about one last thing before we end the lesson. The tests that we have written so far are considered as tests on a happy path. What I mean by that is, these tests only test for the behavior when we use this function correctly. You see, everything can go wrong in a live production environment. For example, there might be a situation where the user will try to delete a post that has already been deleted. If that's the case, how do we handle that scenario? Will there be an exception? Will that exception being handled correctly? Would it break our code? To answer these questions, it is very important for us to also test these abnormal behaviors, which is also known as a sad path in testing. Typically, we will have more sad path than happy path. The more sad path that you can capture, the less likely that your code will break in production. However, it's important to note that it's impossible to handle 100% of the edge cases. The important thing is to find a good balance between finding the edge cases and the likelihood of these events from happening. Okay, let's quickly write a sad path when we try to delete a post that doesn't exist in a database. I'll create a new test function, which will test if an exception will be thrown when we try to delete a post that does not exist. The environment will be similar to our happy path test delete, so I'll just copy and paste from there and change factory create to factory make because we don't want the record to exist inside our database. And now, if we try to delete our dummy record, we will expect an error. Because based on what is written in our post repository, when a repository failed to delete a model, it will throw a general JSON exception. And to handle this behavior, back in our test function, we should call the expect exception helper method to tell PHP unit that there should be an exception. And now let's run PHP unit again, and we get green. Beautiful. And that is pretty much it. Try and see how many edge cases that you can come up with and write a test for each of them. We'll continue and talk more about testing in the next video. I'll see you there. Key takeaway for this lesson: Laravel uses PHP unit as its official testing library. Laravel provides a test case class, which is basically an enhanced version of the test case provided by PHP unit. Laravel's test case loads a lot of helper methods for us to use in a Laravel app. We should write tests on both happy path and sad path for our functions. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. Let's test our API routes in this lesson. As we mentioned before in a previous lesson, feature testing are tests written against features in our app. In other words, we are testing if a group of functions are working correctly together, and we emphasize more on the outcome rather than the individual functions. Testing our API endpoints can be considered as feature testing, because an API endpoint normally involves multiple functions working together. Alright, let's go ahead and create a new folder in our feature testing directory. I'll call it API, and we'll put all the tests that's related to API in this folder. And we'll also create a V1 folder for our version 1 API endpoints, as we mentioned in the previous lesson. And again, if you think that your project doesn't need this V1 folder, you can just get rid of it. And now we'll start with our post API endpoint. So I'll create a new folder called post, and we'll create a test class in it. We'll go to our terminal and type in PHP Artisan make test. And I'll call our test class post API test. And I'll put a newly generated file inside our post folder and refactor the namespace according to our folder structure so that our IDE will stop complaining. And now our post resource has 5 endpoints for us to test: the index, show, create, update, and delete endpoint. And we're going to write a test for each of them. Let's start with the index endpoint. I'll call the test function test index. And inside the function body, we're going to follow our testing rules again. First of all, we need to set up the environment. In our case here, we need some pre-existing data in our database before we can test this endpoint. So our first task here is to load some data in the database. Once we load the data, we need to make a HTTP request to call the index endpoint and assert the status on the HTTP response to make sure that it's returning a 200 status code. And we also want to verify the records returned from the HTTP response to see if they're matching our database records. Alright, let's load some data in our database. We can call our post factory to create some dummy records in our database. I'll just create 10 dummy records for now. Next, we'll need to make a HTTP request to our app, and Laravel makes it extremely easy for us to do that. We can call the JSON helper function to send a HTTP request with the appropriate request headers. The first argument is the request method. In our case, it will be a get method. And the second argument is the URL for our API endpoint, which in our case here will be API/v1/post. And our JSON helper function here will return us the HTTP response. And to assert the status, we can simply call a helper method called assert status on the response object. This will perform a test assertion to make sure that the response has a status code similar to what we provided in the argument, which in our case here, we want it to be 200. Other than status code assertion, Laravel also provides us a lot of other assertion helper method, as you can see in the autocomplete drop-down here. Okay, the last part of the test is to check whether the records returned inside the response match with our database records. To do that, first of all, let's look at what's inside the response body. Again, Laravel provides us a nice and convenient helper method for us to read the response body. We just need to call the JSON method on the response object and dump the result. Let's test our code. We'll go to our terminal and run PHP unit. Now, we created a few unit tests in the previous video, and by default, PHP unit will scan our test directory and run all the tests in it. And sometimes, instead of running all the tests, we just want to run a specific test to save time and resources. PHP unit allows us to run a specific test by supplying a flag called filter. In our case here, we only want to run post API test, so I'll supply -- filter equals to post API test. Hit enter, and our test is running. Now here we can see our dump result from our response, and the main data lives inside the data key in the response. So we'll go back to our code and we'll create a variable called data that reads from the data key in a JSON response. Now the JSON helper function allows us to access key inside the response body using the dot notation. The dot notation is a special syntax that allows us to access data inside an array. So here we specify data as the argument of the JSON helper method. We are essentially accessing the data key in the response body. So now if we dump our data variable, go back to the terminal and run our test again, we're now only seeing the data payload in a response without the metadata. We can use the dot notation to access specific elements in the array. For example, if I want to access the element with index 19 here, I can simply put a dot right after a data key and put in 19. And that means we're accessing the number 19 element in the data key. And now go back to our terminal and run the test again, and we see the last element. Now, if we want to read the ID key in this element, I simply need to add an extra .id in the dot notation. Let's try again. And we see 20. Now, you might be wondering, we only created 10 records in the factory function. Why did our API endpoint return us 20 records? The reason is because every time we run a test, it will not start from scratch, and PHPUnit will not reset our database. So in order for us to clear the database before we start running the test, we can load the refresh database trait in our test class. So this trait will magically reset all the data before each test function runs. Let's try again. We'll go to our terminal and run our test. And this time, we're only seeing 9 indices in the response body. The downside of using the refresh database trait is that it could massively slow down our testing. So use it sparingly. A way to get around with this speed limitation is to use the in-memory SQLite as our database connection. To use the in-memory SQLite connection, we'll need to go to our PHPUnit configuration file and uncomment our database connection environmental variable to instruct Laravel so that it will use the in-memory SQLite rather than our MySQL instance. And now let's go back to our test class and go to our terminal again, run a test, and bam! Look at how fast it is. Isn't that neat? One thing to note here is that if you're using the in-memory SQLite connection, we always want to load the refresh database trait. Behind the scene, the trait will trigger the migration script and reset our database. If we don't use the trait, Laravel will throw us an error because the tables are not created in SQLite. Anyway, for now, we need to test if every post returned from the HTTP response is the same as the post that we created using the factory function. So what we can do here is to loop through the data and check if the ID of each record exists inside the post collection from the factory. So first of all, I want to map the post into an array of IDs to simplify our test. I'm using the arrow function here because we only need a simple one-liner function. And now, to verify the records, I'll convert the data variable into a Laravel collection because collection has a nicer API compared to native PHP arrays. And I'll call the collection helper method each to loop through each item in the data variable. And for each item, we want to check if the ID of the post exists in our post IDs array. To do that, we can use the in-array PHP array helper function. The in-array helper function will return true if the needle is found in the haystack. The needle in our case here is the ID key in the post data item, and the haystack is our post IDs variable up there. So to perform the test, we need to make sure that the result of this in-array function is true. We can simply call the assert_true function for that. Okay, let's try to run our test. Whoops, we got an error. And the reason is the in-array function can only accept an array as its argument, not a collection. Our post IDs variable is a collection, so we need to convert it into an array. And that is quite easy. We just need to call the toArray helper method on it. Let's try again, and we see green in our result. Great! Our tests are passing. Alright, let's move on. The next endpoint that we want to test will be the show endpoint. Again, first thing first, we want to replicate the environment. In this case, we want to make sure that there's an existing dummy post in our database. So I'll use the factory function to create a dummy post. Step 2, we want to send a GET request to the show endpoint. Step 3, assert the status and get the data in the response body. And lastly, we want to make sure that the ID field in the response result is the same as our dummy ID. Let's go to our terminal and run our test, and we get green again. That means our show endpoint is working. The next endpoint that we want to test is the create endpoint. First of all, we want to generate some dummy payload to include in the post request. The best way to do this is to use the make method on the post factory. This method will return us a post model instance without creating it inside the database. So the idea here is that we want to convert this dummy model into an array so we can attach it inside the post request body. And now let's try to send a post request. Again, we'll call the JSON method. The first argument will be the post method. Second argument will be our create API endpoint. And the third argument is the body of our post request, which in our case here will convert dummy into an array. Next, we'll do the same as before. We'll assert a status. This time the status will be 201 because we have created a new resource. And we'll get the data from the response body. Once we got the data, we want to test if the post created has the same attribute as our dummy post. So to compare the API response against the dummy model, we'll need to loop through our result, and for each key in it, we will test if it is the same as our dummy model. But before we do that, we first need to standardize our result to make sure it has the same key as our dummy model. So to do that, we'll convert result into a collection and call the only method to only include the keys that we specified. And the keys will be the keys of the attribute of our dummy post. So now, once we got our standardized result, we will loop through it and make sure each value exists inside our dummy model. So in each iteration, we'll call the assert same method, and for the expected value, we'll get the value from our dummy model, and the actual value will be the one inside our result. Okay, let's test our code. We get green again. Beautiful. Now if we go to our post controller, and inside the post repository, as we define in the create method, every time we create a new post, we will emit a post created event. Let's also test this behavior. Laravel makes it easy for us to test if an event is dispatched. To test this, we first need to call the fake method from the event Facade. Calling this method will actually stop Laravel from dispatching any event whatsoever in the app. Laravel will instead capture this event and enable us to perform assertion on them. I'll show you what I mean. So after we have sent our API request, the post created event, in theory, should have been captured by Laravel at this point in time. So we can simply call another helper method from the event Facade, which is called assert dispatched, and will pass in the event class name in it. This assertion function will only work if we have already called the fake method beforehand. Alright, let's run our test, and we get green again. Okay, let's move on. Let's write our test function for the update endpoint. For the update test, first of all, we want an existing data in our database. So we're going to use the factory correct method to correct the dummy record. Our objective here is to update this dummy record. And to do so, we'll need some dummy field as our update payload. The easiest way to do this is to correct another dummy record by using the factory make method. And now to update our dummy post, we need to know what fields can we update. One way of doing this is to call the getViewable method from a post instance. The getViewable method will return us a viewable array as we define in our model. I'm converting it into a collection because collection is much more easier to work with compared to array. So the getViewable array will essentially return the viewable property as we define in our post model. And now we want to try and update our dummy record with these viewables. So let's look through our viewables, and for each of them, we will send a patch request that updates our dummy record. So we'll call the JSON method again. Method name will be patch, URI will be /API/v1/post, and our dummy record post ID. For the request body, we will specify which field that we want to update. So the field name will be our toUpdate variable, which is one of our viewables. And the value of it, we'll get it from dummy2. Dummy2 has different values, and we want to test if dummy1 has the same value as dummy2 after the patch request. So after the patch request is made, we want to assert the status to be 200 and also get the data key from the response. Once we got the result, we can perform the assertion right away. So I'll call the assert same method. The expected will be the dummy2 value, and the actual value, we will get it from dummy1. Now since we have updated dummy1, we need to call the refresh method on our variable to get the latest model, because our variable here is still referring to the model before the update. Okay, let's run our test, and we get green again. Great! The update method will also emit a post-updated event. Let's also quickly test if our event is dispatched correctly or not. Again, we'll call the fake method on the event facade, and right after we send a patch request, we'll call the assert dispatch method and pass in our post-updated event class. Run our test again. All green. And now we just need to write one more test and we're done. Let's test the delete endpoint. And the idea here is that we'll first correct the dummy record and send a delete request to delete this dummy model. And as usual, we want to test if the status code is 200. Now, after this, the database shouldn't have this record anymore. So if we try to query for this dummy record by using the find or fail method, we would expect an exception. So just before the query, we would call the expect exception method, and the exception that we would expect to throw would be model not found exception. Let's run our test. And it's working. Now the delete endpoint will also dispatch a post-deleted event. Let's quickly test that as well. So I'll call the event fake method and also event assert dispatched and pass in post deleted. Let's run our test again. And it's all green. Getting green testing result is one of the most rewarding experience when it comes to writing tests. As long as you're writing good tests, you can rest assured that your app should work most of the time. There are still a lot of tests can be added to our test suite, especially set path testing, to handle edge cases and catch potential bugs. Try to think of some other test scenario where you can improve the reliability of our test, and let me know your ideas in the comments below. Now we still need to write our test for our users endpoint and comments endpoint. I'll leave that as an exercise for you. Again, the solution will be posted in the project repository. We'll learn more about testing as we continue in this series, and I'll share a few more tips in the upcoming videos. I'll see you there. Key takeaway for this lesson: providing the filter flag to PHPUnit allows us to run a specific test. Calling the fake method from the event facade stops event from dispatching in our app, and it also allows us to capture and assert event dispatching. Laravel provides us a handy JSON method to test our API endpoints. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. So far, our current workflow of writing a test is to write our code and manually triggering PHPUnit in our terminal. And this process can be quite tedious, especially when we got a million tests to write. Every time we finish writing a test, we have to go back to the terminal and rerun the test. It would be great if we got a way to automatically trigger PHPUnit as soon as our code changes, without us manually go to our terminal and rerun PHPUnit. So the question is there a way to do this? And the answer is hell yes. Otherwise, I wouldn't be making this video. So that's actually a PHP package called PHPUnit Watcher. And as the name suggests, it will watch changes in our code and run PHPUnit whenever our code changes. I'll show you how it works. First of all, let's install it. We'll go to the package repository and look for the installation instruction. The link is in the description if you want to take a look at it yourself. We'll copy the installation command and paste it in our terminal to install the package. Notice the --dev flag here. We're installing this package as a dev dependency because we only need it for development purposes, not for production. Alright, now that's done, let's see how we can use this package. Based on the documentation, we simply need to type in PHPUnit Watcher watch in our terminal. Let's try this out. The PHPUnit Watcher binary is living inside the vendor folder, the bin directory. This binary file should be automatically added by the package once the installation is completed. If you don't see this binary, that means you have an issue with the installation and you should reinstall the package. Okay, now once we located the binary, we can simply type in the watch command right after it. And bam! PHPUnit Watcher is now running. And it is watching our source code. But somehow I've got lots of errors here. Let's pretend they're not there. We'll come back to it later. For now, I just want to show you that PHPUnit will be rerun by PHPUnit Watcher whenever our source code changes. So I'll type in T to filter out our test, and I'll type in our example test here just for demonstration. And now I'll go back to our code and add another line of some stupid assertion, go back to our terminal, and PHPUnit has now been re-triggered. So we can see there are 5 assertions, 4 of the assertions are from our example test here, which is part of the unit test, and the other one assertion is from the example test counterpart in the feature testing folder. Great! So that's how PHP Unit Watcher would work, and save us time by rerunning PHP Unit automatically. And now it's time to fix the error in our test. Let's rerun PHP Unit Watcher. We've got 10 errors. Let's see what does the last error says. The error was thrown in the user repository, and it says that we're missing the users table. Let's go to our user repository test. Seems like the error exists because we did not use the refresh database trait. If the refresh database trait is not loaded, that means Laravel will not perform the migration and therefore our user table will not be created. So let's load our refresh database trait and go back to our terminal, and PHP Unit is already triggering. Boom, we're down to 7 errors instead of 10. The next error is in the post repository, and I suspect it's the same issue. Let's go to our post repository test and load the refresh database trait. Back in our terminal, we're down to 4 errors. The next one is in the comment repository, and we will do the same. And back to our terminal, we get green now. Beautiful. And that's a quick summary on PHP Unit Watcher. I hope my little error fixing demonstration here can help you to see the value of PHP Unit Watcher. It's really convenient and time saving. And trust me, it will save you a lot of hours and makes you a happier developer. PHP Unit Watcher provides you a lot of ways to configure it. Feel free to have a look at the documentation and see how you can customize it. And let me know your tips and tricks down in the comment section below. Okay, key takeaways for this lesson. PHP Unit Watcher is a wonderful package that automatically rerun our tests whenever there's a change in our source code. It is a great tool that will save us lots of time and make us happier in the long run. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. Now if you look at the composer.json file, there's an interesting field here called scripts. In a nutshell, composer scripts are helper command shorthands that allow us to execute long commands by using composer. We can run any command that we want. As you can see here, Laravel has already provided us a few scripts out of the box. I'll show you how it works. Let's create a dummy script. I'll call it playground, and the value will be an array of command. Now just for demonstration, I'll simply type in an ls command, which will just list all the directories in my current folder. And now if we go to our terminal to run our playground script, I'll simply type in composer run script and our script name, which is playground. Hit enter, and we see our ls command got executed, and we see a list of files and directories. Now if we want to run another command right after our ls command, we just need to pass in a second element to our array. For example, let's say I want to echo some silly things right after the ls command, something like echo hey ya ya ya, and back to our terminal, run composer run script again, and now we see our echo run right after the ls command. So composer will execute the scripts that we provided in the array one by one. So can you see the benefits of using the scripts? We can put in long and complex command inside the script and label them with an easy to remember shorthand so we can easily execute them next time. If you are a JavaScript developer, this works exactly like npm scripts. Okay, now let me show you a few quick scenarios on why this could benefit us in our project. Every time we want to run PHP Unit, we first need to awkwardly locate the binary of PHP Unit and then run it. Now instead of doing that, what we can do is to wrap this command into a composer script. I'll call the script name test. And since we're only executing one command, we don't need an array this time. We'll just simply run the binary of PHP Unit. Let's go back to our terminal and type in composer run script test. And it works. So the next time when we want to run our test, we don't need to locate the binary of our PHP Unit anymore. Now here's another issue though. Sometimes we want to pass arguments to the underlying command in our script. For example, I would like to pass a filter flag to PHP Unit. If I do that as it is now, it will not work. To resolve this, we need to pass in an additional double dash right after our script. After the additional double dash, we can pass in any arguments to the underlying command as usual. Let's hit enter, and the filter flag is now working. Another example, let's also create a helper script to run PHP Unit Watcher. I'll call the script name test:watch, and the value is simply a path to the binary. And now let's go back to our terminal and run our script. Oops, I made a mistake. I forgot to add the watch option. Let's try again. And it's now working. Beautiful. So you can pretty much write anything you like for Composer script. In some of my past projects, I have added a script called deploy, which is a nice and simple way to deploy my app to the production server. The actual deployment script is very complicated, and I don't want to run the whole thing every time I want to deploy my app. So I just simply create a Composer script that will trigger the whole deployment process for me. Alright, that's it. If you want to learn more about Composer script, feel free to visit the documentation. Again, the link is in the description. Key takeaway for this lesson: Composer scripts are handy shorthands that allow us to define and run complex commands. If we want to pass arguments to our scripts, we need to supply an additional double dash after the script name. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. In programming, there's a development style called test-driven development. TDD for short. In simple terms, it means to write our test before we write our code. So the idea of TDD is that it forces us to think about how our app will behave before we even start coding. Once we define all the expectation and behavior in our test, then we'll start writing our code and make our test pass. If all of our tests passed, that means our code satisfies our expected behavior, and therefore the code should work. TDD has a long history now, and it is a good way to write code as it has enormously reduced the numbers of bugs in large enterprise apps. So there are a lot of big companies out there really put a heavy emphasis on TDD. I'll show you a quick example on how TDD would look like in practice. Now suppose in our app we need to perform a few arithmetic operations such as adding, multiplying, and subtracting numbers. Let's create an arithmetic helper class for that. I'll create a new folder called math in the helper directory. And in there, I'll create a new class called arithmetic helper. So in the class, we'll add a few math functions such as add and minus. And from here on is where the TDD fun begins. We should stop writing our code at this point and start writing our test. So let's create a test for the arithmetic helper. I'll go to the unit test directory and create a new test class. And because I'm lazy, I'll simply copy and paste the example test class and rename it to arithmetic helper test. Once we're done, let's start testing our add function. We need to think about what sort of behavior will the add function have. Again, there are two types of testing, the happy path testing and the sad path testing. So for the happy path testing, I'll start with the most obvious behavior, which is to test if we can add numbers together. Now when I'm writing tests for TDD, I like to first write down all my test cases before I start writing the test code. Some people prefer to write the test code directly after they define the test case, but that's not me, because I know my brain is limited and I can be forgetful. I would much prefer to write down all the test cases at once, so I don't need to think about what test to write later on. The test cases that I listed here also serve like a to-do list for us to complete this test class. Alright, let's keep going. For the second happy path test, we would test if the add function would take in multiple arguments. Now for the set path, I will test if the add function can only take in numeric arguments. So if we try to feed it non-numeric arguments, such as array or string, it would throw us an error. And our add function should also accept at least one argument. If the user did not pass in any argument to it, it should throw us an error. Alright, I think that's enough. Let's start writing our test code. First thing first, we'll run our PHP unit watcher. So PHP unit will run our code while we're writing our test. So let's go to our terminal and we'll run the composer script that we defined in the previous lesson. We just need to run the arithmetic helper test, so I'll pass in a filter argument. Okay, it's now up and running. We'll go back to our test and start writing our test code. So for the first test, we'll first set up the environment to run our code, which is to set up two numbers. And we'll define our source of truth, that is, the sum of both numbers that we just defined. Then we'll run our add function and pass in num1 and num2. And finally, we'll assert the result. It won't work at the moment. As you can see here in the terminal, our test is failing because we haven't implemented the logic in our add function. So let's start doing that. The typical TDD approach would be writing the minimal code so that our test can pass. So let's go to our add function. Even though that I know the add function needs to take in an arbitrary numbers of arguments, but in order for us to pass the first test, I'll just make it to take in 2 arguments for now. And the add function will simply return num1 plus num2. And back to our terminal, we can see that our test is now passing. And now we move on to the next test. This time we want to test if our add function can take in multiple arguments. And logically, we know that our code at the moment will not be able to handle this, because we have only written the bare minimum to let the first test pass. But that's the principle of TDD, and we have to see through it. For now, let's write the code for the second test. I'll copy the setup from our first test and add a new number. And now going back to our terminal, as expected, our test has failed. So let's go to our add function and refactor our code. To make our function takes in an arbitrary numbers of argument, we can use a splat operator, which is a triple dot. So the triple dot operator will pack all the arguments into an array. What we need to do in the function body here is to loop through this array, and for each loop, we'll add a number to the sum and return the sum at the end of the function. So this code here should do the trick. We'll go back to our terminal, and we're not seeing any errors, which is great. And again, that is the development style of TDD. We're trying to pass one test at a time and constantly refactoring our code. Personally, I'm not a big fan of the typical TDD approach. That is, to write code just to pass one test at a time. To me, it is not very productive since we need to constantly refactor our code. What I do instead is to look at all the tests and implement the code in one go. So for the rest of the two tests, we need to put in validation that checks for numeric arguments and also a minimum of one argument. Let's write our test code. So if we try to pass in data type other than number to our add function, we would expect an error. We need to code the expect exception method to run this test. We would expect an invalid argument exception. We have multiple data types to test here. We have strings, array, null, boolean, and function. Let's move these guys into their own test case, because ideally, one unit test should only test for one thing. Now that we have finished writing our test code, let's go back to our terminal, and we see failures, as expected. So let's go to our add function, and we'll add a check to check for the type of the number inside the for loop. If the number is not a float or an integer, then we'll throw the invalid argument exception. Once we're done, go back to our terminal, and our tests are now passing. Great. And while we're in here, let's also implement the check to see there's a minimum of one argument. If there's not, we'll throw another invalid argument exception. Let's go back to our test. For our last test, again we'll expect the invalid argument exception, and we'll simply call our add function without passing in any arguments. And go back to our terminal, and we now see green. Great! And that is a quick introduction to TDD. Although our example here is quite trivial, but it demonstrates the process of TDD, and I hope that it gives you a better idea on how TDD looks like. We still have the minus method to test on. I'll leave that as an exercise for you. Again, just a personal opinion before we end the lesson. The standard process of TDD can be time-consuming, and sometimes they can be quite distracting. I tend to define the test function first, then I write my code logic, and then the test code. It works great for me, but it might not be suitable for you. So feel free to find your own way to write tests. Key takeaway for this lesson: test-driven development, or TDD for short, is the idea of writing tests first and write the code later. In standard TDD, we would write a bare minimum code to pass our test and refactor our code as we progress to the more advanced tests. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! So in the previous video, we learned about testing, and there are generally three types of tests: unit testing, feature testing, and end-to-end testing. However, here's a question for you. How much testing is considered as enough? As a developer, it's very easy for us to fall into the trap where we want to test every single thing in our app, or test all kinds of user behavior in an attempt to catch potential bugs before our code is shipped to the production. Now, there's actually a term in testing which is known as code coverage, and it simply refers to the percentage of the functions in our app that have been tested. 100% means that every single function is fully tested, and 0% means nothing is tested. Realistically speaking, for most projects, aiming for 100% code coverage is very, very difficult. The reason is because developers are very expensive. 100% code coverage means that the development team has to spend a lot of time writing tests, and the company has to pay for that. You see, a lot of business people think differently than developers. To developers, testing can really help to reduce bugs and be able to ship a robust app, and also reduce a lot of maintenance work in the long run. However, to a business person, writing tests is not productive, since we're not introducing a new feature to the app. In other words, writing tests does not bring any economic value to them. Think about this. Have you ever heard a salesperson tells you, our product has 100% code coverage and we have written a lot of unit tests to make sure that our software is working correctly? Very unlikely, right? If your answer is yes, leave a comment below and tell us the story. I would like to hear more about that. In contrast, you're more likely to hear about the app features rather than unit testing in a sales pitch. To a customer who is paying for the product, a bug-free app is a given. That's why hearing about the 100% code coverage does not bring any value to the table. And that's the reason why you'll hear a lot of stories about stakeholders and developers fighting against each other. A lot of projects has very limited budget and simply do not have the time to write any test. I strongly discourage shipping code without writing any test, because it is like walking on a street naked. As a general rule of thumb, a good project would have 60 to 80% of code coverage. Again, this number is just a rough estimate. It really depends on what type of projects you have. On a mission-critical project, for example, a finance app that processes thousands of transactions per day, or a healthcare app that runs in a busy hospital, where a simple bug could cost a patient's life. In this kind of app, we need to make sure that our code does not fail in production. And that means 100% code coverage is a very reasonable request. On the other hand, if you're just building a simple static website, writing tests becomes optional. So my advice here, to answer my original question, how much test is enough for a project, I would say you need to find a good balance and think about the budget of the app. The more tests that you can write, the better it is. Writing a little bit of test is better than writing none. And now, given that we have limited budget, which type of test should we focus on? End-to-end testing, feature testing, or unit testing? Now, before we answer this question, I want you to spend a few moments to take a look at these few examples. These are the perfect example of someone who only focuses on unit testing. Don't get me wrong, unit testing is important, but making sure that our feature would work correctly is equally important. In the previous lesson, we talked about the reliability and the difficulty of implementing these three types of tests, with end-to-end testing being the most reliable, but the most difficult to write. Unit testing is the easiest and the quickest, but not very reliable. What I want to point out here is that if your project has a budget issue, I would prefer writing end-to-end testing and feature testing over unit testing, focusing on testing interface rather than the implementation details. And that's exactly the point of feature testing. Don't sweat the details, but to look at the overall picture. If everything works on a high level, we can assume that the internal implementation is working correctly. And one last question before we end this video. How much time should we spend on writing tests? If you remember from the last video, we did a demo on testing some mathematical functions. The add function that we're testing is only about 15 lines of code, but the test for it is a massive 70 lines of code, which is around 4 to 5 times. To answer this question, again, my advice is to find a good balance on spending time writing tests. The standard TDD approach is time-consuming by nature, although it'll save you a lot of maintenance time in the long run. If the project has limited budget, then I would say to only use TDD on features, rather than every single unit of functions. And just for your reference, on average, I spend about 30 to 50% of the project time writing tests. And again, depending on the nature of the project, this number can change. Okay, that's enough of me talking. Again, the purpose of this video is just to share my opinion on the topic of testing in the real world. Let me know what you think in the comments below. I'll be happy to hear about them. That's it for now, and I'll see you again in the next video. Hey there, Sam! A golden rule in web development to keep in mind is that we should never, ever trust the user input, because terrible things can happen to your website. Malicious user can perform attacks like SQL injection or cross-site scripting with ease. With that being said, validating user input is one of the most important things in building a web app, and Laravel makes it very easy for us to perform validation on the incoming user input. So here in our post controller, currently in the store method, we are expecting the request to contain these three fields. title, body, and user IDs. Now title and body must be a string, and user IDs must be an array. But at the moment, we don't have any mechanism to validate this data type. Let's learn how to do this in Laravel. There's actually a few ways to validate requests in Laravel. The first way, which is the easiest way, is to create a request class. We'll go to our terminal and type in PHP artisan make request, followed by the request name. We're creating a request for the store method, so our code post store request. And now back to our code. If we navigate to our app folder, HTTP, and request, you'll notice that our newly created request class is living in here. Let's open it, and it's a simple class with two methods, authorize and rules. The authorize method is a way for us to define the logic to determine whether the current request has a correct authorization to perform this request. This method will return a boolean. If it returns false, that means the current user is not authorized to perform this action, and the request will fail. And if this function returns true, that means the current user has the authorization to perform the current operation. This is very useful when our app contains API endpoints that's only available to a certain user group. For example, we might have a few endpoints that we only want the admin to use. So if a normal user attempts to call this endpoint, we should put down the logic so that the authorize function here will return false, and will only return true if the current logged-in user is an admin. The rules method is where we define all the validation logic. The method returns an array, which is basically a mapping of fields against validation rules. And Laravel has provided us a lot of built-in validation rules. So if we go to the documentation, we can see a whole lot of rules here, each with different purpose. The link is in the description if you want to check them out. But for now, we've got three fields in the store request: title, body, and user IDs. Title and body should be a string, so I'll map them to the string rule. User IDs is an array, so I'll map it to be an array. We also want these three fields to be mandatory, so we should also assign the required rules to each of them. To apply multiple rules to a field, there are two ways to do it. One is to use the pipe operator, followed by the second rule. So our title field here is now required and also must be a string. The other way to apply multiple rules is to use an array, where each element in the array is a rule. And now the rules for body and title are exactly the same, just using a different syntax. And just a question for you, which syntax should we use? And again, it's entirely up to you, it's a personal preference. I prefer to use the array syntax because it makes more sense to me. So I'll use the array syntax for the user's ID field as well. And that's pretty much the basic of request class. Now to apply this request class to our store method in a controller, we simply need to inject it in a store method argument. And that's it. Now our incoming request to the store method is validated by the post store request class. Let's test our code. We'll go to Postman and send a post request to our store endpoint with a simple JSON body. And we got a 403 error saying that our action is unauthorized. And the reason is because back in our request class, in the authorize method, we returned false, which gave us the earlier error. Let's change it to true, go back to Postman and try again. And we're not receiving a JSON response. The reason is because we need to send an additional header in our request, which is accept, and the value is application JSON. If we don't do this, Laravel will not be aware that we want a JSON response and therefore send us back the default homepage. Let's try again, and we get a JSON response. Now, although we get a JSON response, we got an error with status code 422, which means the request did not pass the validation. And if we look at the response, it says that the body field is required and also the user ID field is required, because we did not include those two fields in our request body. And that means our request class is working fine. Now the title field must be a string. Let's see if this validation is working. We'll go to the request body and change the title field into a number. Click on send, and we get an error saying that the title must be a string. How cool is that? Now we can also customize the error message by defining a method called messages in our request class. We need to return an array in this method, which uses the dot notation to specify the field and rule pair. For example, let's say I want to customize the error message for the body required rule. In the array key, I simply need to specify body.required, and the value will be the customized error message. Let's go back to Postman. I'll send another request, and in the response, we now see our customized error message for the body field. Just another example, let's customize the error message for the string rule for title as well. So in the array, I'll add a new entry, the field is title, and the rule is string, and for the error message, I'll just yell at the user. Now let's go back to Postman, send another request, and now we see our customized error message. So far, so good. Let's move on. Now sometimes we do want to have our custom validation rule other than what Laravel has already provided us. To create our own rules, there are two ways to do this. One is to use a closure in the rules array. The second option is to create a rule class. Let's go through these two options in more details. Let's use the user IDs fields as an example. So with the closure option, we simply need to define an anonymous function in the rules array. And the function takes in three arguments: attribute, value, and fail. Attribute is the field name, which in our case here will be user IDs. Value is the value that the user has applied, and fail is a callback function to call when the validation has failed. So here, let's say we want to validate if each element in the user ID fields is an integer. One way of doing this is to loop through the array that the users applied and making sure that every one of them is an integer. So I'll convert value into a collection and call the every method to loop through the array. The every method will make sure that each element in the array fulfills the condition that was applied in the callback function, which in our case here will simply check if each element is an integer. If the condition is satisfied for each element, then the result of the every method will be true, otherwise false. And here we want to fail the validation if one of the element is not an integer. So if the result of the every method is not true, then we'll call the fail callback function. The fail callback function accepts a string argument, which will be the error message that we send back in the JSON response. Alright, that's our custom validation rule based on a closure. Let's try it out in Postman. So in our request body, I'll add a new field, user IDs, which is an array, and to trigger our custom rule, I'll put in a string element. Let's send the request. And in a JSON body, we see our custom error message. And now, let's try an array with integer elements. And we no longer see the user ID fields giving us an error. Great, that means our rule is working. Okay, now, let's see how we can refactor our rule closure into its own dedicated class. To do that, we need to create a new rule class. Let's go to our terminal and type in PHP Artisan make rule, followed by the rule name. I'll call it integer array. And you'll notice that the command will create a new folder called rules in our app folder, and the rule class lives in it. Let's open our newly created integer array class, and it is a simple class that implements the rule interface. It has two main methods in it, passes and message. And you'll notice that they have a very similar signature compared to its closure counterpart. In the passes method, we'll put down the logic to validate the user input, for which we'll simply copy and paste from our closure. And the message method will return the string that we include in the error message. Again, we'll copy and paste from the closure. Now in this method, we don't have access to the attribute. However, Laravel allows us to use a placeholder, :attribute inside the string to refer to the attribute name. And that should do the job. All we need to do now is to go back to the request class and create a new instance of our integer array rule in the user ID's validation array. Let's try it out. We'll go back to Postman and change the elements inside the user's ID array back into string. Let's send the request again, and now we see user ID's error is back in the response. And that is it. That's how I can easily validate a request in Laravel by using the request class and validation rules. We'll learn more about validation in the next video, not only just for requests, but for generic purposes. I'll see you there. Key takeaway for this lesson: we can define request class to easily validate incoming HTTP requests. We inject request class in controller methods to get Laravel to perform validation on the incoming request. We can create custom validation rule either by closure or a dedicated rule class. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! Using a request class can easily help us to validate incoming requests. But sometimes we need something that's more customizable. And Laravel has an answer to this, and it is called the Validator. Let's try to replace our post store request with a validator, and you'll see how it works. Alright, first thing first, we'll need to create a validator instance, and to do that, we can call in the validator facade. and we'll call the make method to make an instance of the validator. The first argument is the data that we want to validate, which in our case here will be the request body. And we can retrieve the request body by using the request only method, which is similar to what we have passed in to the correct method for our repository. And now notice that we're kind of repeating ourselves here. So it might be a good idea to create a variable called payload, which will be our request body, and pass on payload to the make method and the repository correct method. Now the second argument accepted by the make method is an array of rules. The syntax of this rules array is similar to what we have used in our request class. Let's copy and paste it to here. The third argument is a way for us to customize the error message. Again, we can simply copy and paste it from our request class. The fourth argument is a way for us to customize the attribute name for the attribute placeholder. By the attribute placeholder, I mean the colon attribute placeholder that we put in the error string in a validation rule, just like our integer array custom rule here. Okay, now back to our controller. In the fourth argument of the make function, we can customize what to show in the attribute placeholder. So I'll map user IDs to user ID, and that's what we're going to see later in the error message. And that's pretty much how we can set up a validator. Now to get our validator to validate our request, we simply need to call the validate method on it. The validate method will validate the user input based on the rules that we supplied, which is similar to what we have done in the request class. If the validation failed, then Laravel will send out an error response back to the client. Okay, now let's test our code. First of all, let's remove our request class injection and replace it with the base request class. And now to test our code, let's go to Postman and send a request to the post store endpoint. And in the response body, we see our customized error message, which means we're using our custom validator instance rather than the request class. And you can also see that we're using our custom attribute name for the user ID's error message. Great! And that's how we can use the validator to validate data. Now, although the validator provides more flexibility than the request class, but it can really pollute our controller method a lot. Setting a validator up can take up a lot of lines of code. So which one should we use? It's really up to you. It's a personal preference and you can pick whichever suits you the best. I tend to use the request class as far as I can, because it is nice and clean and it's easier to manage. Okay, now let's move on. The validator instance provides us a lot of helper functions to work with the validation. It is very flexible and powerful. Let's take a look at a few of those helper functions. First of all, we got the errors method. The errors method will return us all of the validation error as an instance of the messageBag class. The messageBag class provides us a nice interface for us to work with the data in it. As you can see in the autocomplete drop-down here. You can easily convert the data into JSON or an array by calling the right method. That is, whenever you need the error message in a different format. Let's dump the error and go to Postman and see what it looks like. And in the response, we see the message bag contains the error message of the validation. Great! The errors method also has an alias called messages, so it's up to you which one to use. So if we go to Postman, hit the send button again, and we still get the same dump response. The fails method determines whether the validation has failed or not, and it returns a boolean. Let's go back to Postman to test it out, and we see true in the response because our validation has failed. The passes method is the inverse of fails, and back in Postman, we see false. The attributes function will retrieve the payload that we pass into the validator, and it has an alias called getData. And back in Postman, we see two identical dumps in the response. The failed method will get all the failed validation rules, but it only works after the data is validated. Functions like fails and errors will trigger the validation behind the scenes. So if we comment out the errors method and messages method, we would expect to see an empty array. Let's go to Postman, send another request, and we did see an empty array in the response. Now if we uncomment the messages method, back in Postman, we now see an array of the validation rules. We can call the addRules method to dynamically add rules to our validator. For example, if I want to add a new rule to a hypothetical field called Heya, I can simply pass an array to the addRules method and set the rule just like before. This is great for conditional validation, but I do not encourage this in general because it is hard to maintain and debug. We can also add an after validation hook to the validator by using the after method. So the function that we pass into the after method will be triggered whenever the data is validated. The function accepts the validator instance as its argument, and I'm going to simply dump a random string just for demonstration. And now back in Postman, we'll send a request again, and we see hey yeah in the response, which was triggered by the messages method code here. Okay, last thing before we end the lesson, the validator instance also allows us to call each validation rule as a function. For example, I can call the validate string method to test whether a value is a string or not. The first argument is the attribute name, which we can set it to anything we want. And the second argument is the value that we want to test. So here we are testing whether the number 1 to 3 is a string or not. And we expect this function to be false. Let's go to Postman, and we see false in the response. To see a list of all the available validate methods, feel free to check out the Laravel API documentation. The link is in the description if you're interested. Now you might be wondering, why there's no autocomplete for the validate string method, even though it is a valid method? And the reason is because the make method from the validate facade is type hinted to return us the validator contract, which does not cover the full method list in an actual validator instance. Now to solve this issue, you can install a package called IDE Helper, which will provide all the auto-completion support for your IDE. Again, the link is in the description if you want to check it out. Alright, I think it's a good point to stop here. Again, Validator is a flexible alternative to the request class. It is up to your personal preference on which one to use. We need to validate the other endpoints as well. I'll leave that as an exercise for you. Key takeaway for this lesson: Validator is an alternative way to validate input data other than using the request class. Validator has the benefit of providing us a lot of helper functions to work with validation. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. As we mentioned in the previous video, Laravel makes heavy use of facades and magic methods, and that makes the autocompletion in our IDE quite limited. For example, for a validator instance, we know that we can call the validate string method, but it is not showing up in the autocomplete dropdown. How do we fix this? Well, do not despair, we have a solution. And the answer is to install the IDE Helper package. We'll go to the package repository and go ahead and click on the installation instruction, go to our terminal, and paste it in our project. Once the installation is completed, we'll need to run a command to get this package to work. So if we go down to the documentation, under the usage section, the package offers us a few PHP artisan commands. The IDE Helper generate command is the main way for us to generate the PHP documentation to improve our IDE auto-completion. We also got models to improve the auto-completion for our model, and meta for PHP Storm users. Let's try out the main generate command. I'll go to my terminal, paste and run a command. Once we're done, we'll go back to our code, and now you'll notice that our IDE is now recognizing there's a method called validate string on the validator instance. It is no longer giving us a warning. And if I toggle the auto-completion list, we can see a lot more items are showing up in the autocomplete dropdown, including all the validate helper methods. Isn't that neat? All of this magic is possible because the IDE Helper package has generated a file called IDE Helper in our project root directory. Now if we take a look inside, it is basically a list of pseudo-class or symbols, mainly there just for our IDE to pick up and provide us auto-completion. This file will change every time we add a new dependency or remove a dependency, because it is really dependent on the classes or packages that are available in our project. And also, we should really add this file to our git ignore list, because we only need this helper file for local development. Now, as I mentioned just now, we should regenerate the IDE helper file every time we make changes to the dependencies. But manually triggering the generate command is far from ideal, because I'm too lazy to do that. Is there a better solution? Yes. We can add the generate IDE helper command to one of our composer hooks. Now if we go to our composer JSON, under the scripts section, there's a field called post autoload dump. This is a special script that will automatically triggered by composer every time we run the dump autoload command. I'll go ahead and add in the IDE helper generate command so that every time we run dump autoload, we will also generate the IDE helper. And since I'm using PHP Storm, I'll also add in the meta command. Okay, great. Let's try this one out now. I'll delete the IDE helper file and go to our terminal and run composer dump autoload. Now back to our code, we can see that the IDE helper file has reappeared. Isn't that neat? And now you've got the IDE helper on your side, you should be invincible. Key takeaway for this lesson: Laravel uses a lot of facades and magic methods that are not IDE friendly. That means our IDE may not be able to pick up all the API that a particular facade is offering. However, this problem can be solved by using the IDE helper package. It solves this issue by generating an IDE helper file to aid the auto-completion. That's it for this lesson, and I'll see you again in the next video. Hey there, it's Sam. Configuration plays a big part in a web app. Things like your database connection details, API keys, and etc. are all things that we might want to change at some point in time. So that means we might want to put all this configuration in one place rather than scatter them across our whole app. The benefit of putting everything in one place is that we can easily manage them in the future rather than scanning through thousands of lines of code and change those values individually. Laravel provides us a robust way to manage our configuration. It stores all the configurations inside the config folder in our project root. If we look inside the folder, we can see all sorts of configuration organized in separate files. And each file is really a simple PHP file that returns an array. And within the array is a series of key and value pairs, which represents the configuration. And we can put in any values that we want for this configuration. And it is extremely easy for us to read a value from this configuration array. For example, currently we are inside a database configuration file. Let's try to read the value of the driver key under the MySQL connections here. Just for demonstration, I'm going to go to the terminal and run php artisan tinker. To read a certain configuration value, Laravel provides us a very convenient helper function called config, and we can use the dot notation to access a certain value of the configuration. So here, our target is the driver key under MySQL connection, and it's living inside the database file. So I'm going to run a config function and type in database.connections.mysql.driver. Hit enter, and we see MySQL. Isn't that neat? Let's try another one. Let's go to File Systems, and this time I'll try to read the driver for the local disk. Again, back inside Tinker, I'll call the config function and pass in File Systems disk local driver. And we see the string local, which is what we expected. So to break it down, the first element inside the dot notation will always be the config file name, followed by the keys inside the array. And now you might have already noticed Laravel is calling this env function in a lot of places. In short, this env function is a way for us to access environmental variable. And as you can see here inside the public disk configuration, the env function is accessing the app URL environmental variable. And that is supplied from our .env file in our project root. Again, it is a nice and simple helper function to read the environmental variables. Let's go back to Tinker, and I'll try to read the app URL environmental variable. And the result is the same as our .env file. Let's try another one, app name, and I get live post. And that is pretty much it. We put in sensitive information in our .env file, and then git ignore this file so that it won't be tracked by Git, so that we don't push this file to our remote repository, which is often shared with other people. The .env file differs from developers to developers, because we don't really want to share our API keys or credentials with other people. And now let's try to create our own config file and see if we can read values from it. I'll create a new config file called livepost, and inside the file, we need to return an array. I'll insert one dummy configuration key here, and I'll call it heya, and the value of it is hey. And now let's go back to Tinker and see if this works. We'll restart Tinker to load the changes. And now run a config function livepost.heya. And we get hey. I'm showing a trivial example here, but in the real world, you might want to create your own configuration file for things like the API key for a payment gateway, or the admin email address, where you'll receive all the error report generated by our app in case if something go wrong. Alright, key takeaway for this lesson. Config is a handy helper function to access configuration values from the config folder. We use the dot notation to access the configuration. env is a helper function to access environmental variables. And we normally have our environmental variables inside the .env file. That's it for now, and I'll see you again in the next video. Hey there, Sam. When building an API server, having a good API documentation is always something important to do, not only just for reference for your future self, but also your fellow teammates, especially the front-end developers. But at the same time, it is a pain in the ass to write API documentation. As a lazy developer, I don't really want to build an API documentation site from scratch. That would be too much work for me. So, is there a better way to do this? Well, the answer is hell yes. Otherwise, this video wouldn't exist. There's a wonderful package called Scribe that will do much of the heavy lifting for us. And now, let's go to its GitHub repository and learn how we can install the package. Let's go to its documentation. I'll copy the installation command and paste it in our terminal. Once it is done, we'll also publish the config file of this package. And now let's take a look at the config file for a bit. There are quite a few options in the config file that we can customize. Each one of them is commented, and they should be quite straightforward. Now there's one particular key that we should be a bit more careful, which is the type configuration. There are two possible values, static and Laravel. If we set it to static, Scribe will simply generate a static HTML page. We use this option when we don't need to apply any extra middleware or routing logic to view the generated documentation. If we set it to Laravel, we'll be able to apply middleware and other logic to the documentation site. For example, restrict access to the documentation site so that only authorized user can view the generated API documentation. For now, we'll just leave it as static. The next thing that you want to be careful of is the match option under the routes configuration. The match option allows us to define which API endpoints that we want to generate the documentation. By default, any routes that has a prefix of API will be included inside the generated documentation. Okay, now let's give it a test run. We'll go to our terminal and run php artisan scribe generate. Once that's done, if we go to our public folder, you'll notice that Scribe has created a new folder called docs for us, and inside it contains the source code of the generated documentation. Let's visit the generated HTML page. We'll run our server and visit the documentation site. And we see a beautiful web page with a lot of goodies in it. We can see a quick navigation menu, the main documentation site, and also sample code and sample response. Isn't that neat? Everything that you can see here are customizable. At the moment, our main documentation looks a bit empty. Let's learn how we can add some stuff to it. Currently, all of our API routes falls under the same group called endpoints in the quick navigation menu. It will be better if we can group our resources into their own separate group. Let's go back to our code and see how we can achieve that. Scribe can pick out special directive that we put inside PHP docs. So if we want to group the routes inside our user controller, what we can do is to insert PHP docs on our user controller class and use the add group directive followed by the group name and its description. Once we're done, let's regenerate our API documentation and check out the changes. And now back in the browser, you can see that our users endpoint are now living under the user management group instead of endpoints. Alright, let's move on. Let's see how we can add a little bit of description on our get user request here. The first line in the doc block will be the title of the request documentation, and the second line with a line break in between will be the description. And now we know that in this endpoint, we're trying to read an optional request query called page size, which will specify it inside the doc block so that it will be included inside the API documentation. We can do this by using the query param directive, followed by the parameter name and the data type, which in this case will be integer. After the data type, we will put in the description for the query parameter, and we're free to put in anything that we want. Since we're using Laravel Paginator, Laravel will also use a page query parameter behind the scene, which will specify which page do we want to view. Let's also put that down. Okay, now we will regenerate our API documentation and see how our query parameter documentation will look like. Let's go back to our browser, hit refresh, and there you go. We've got a nice list of all the query parameters that we specified in a PHP doc block. Now you'll notice that by default, each of the query parameter is optional. If our endpoint has a mandatory query parameter, we'll need to specify it inside our PHP docs. Just put in the required keyword right after the data type. Let's regenerate the documentation. And now back inside our browser, the page size query parameter no longer has the optional tag on it. Beautiful. Now let's move on. I'll go ahead and remove the required tag on the page size query parameter because it is not a mandatory field. We can specify an example value to be used in a sample code by using the example keyword right after the description. So for the page size query parameter, I would like to give it an example value of 20. Let's regenerate the documentation and go back to our browser. And as you can see in the sample code, Scribe is using our provided example value for the page size query parameter. We didn't specify any value for the page parameter, so Scribe will randomly assign a random value to it. We didn't see any data in the response because we don't have enough data in our database to account for 9 pages of data. So we should really give an example value for the page query parameter. By default, Scribe will interact with our database in order to generate a response to show in the API documentation. This not only applies to the GET request, but also the POST, patch, and delete request. Behind the scenes, Scribe will try to wrap all database operations within a transaction and roll back the transaction once it is done with the response, so that there won't be any persistent changes in our database. Although this is safe for most of the time, there's still a chance that something will go wrong and the changes are persisted in our database. How do we solve this? Well, there are two solutions. One is to get Scribe to use a different database when it is generating the API documentation. To do that, we can create a new .env file and call it .env.docs. And this .env file will point us to a different database that Scribe will use. And to get Scribe to use this .env file, we'll need to specify it at the time when we run the PHP artisan command by supplying the --env flag, followed by the postfix of our .env file, which in our case here will be docs. Now this method will work fine. However, we'll need to create a separate database instance just for Scribe to interact with. The second method, which I think is a better way, is to use another Scribe directive to specify which response that we are returning in this endpoint. We're returning back a resource collection, and the directive is called API resource collection. So when Scribe sees this directive, it will not interact with our database, but instead, it will attempt to generate a response by looking inside our resource class and use our model factory to generate the fields. Right after the directive, we'll need to specify the namespace to our resource class. And on a new line, we also need to specify the model that we want Scribe to load inside our resource class, which in our case here will be our user model. Alright, let's test it out. We'll go back to our terminal, and just to prove that this is working, we will clear the database and regenerate the API documentation. And now back inside our browser, we can see that we still got a response inside the API documentation, even though our database is now empty. Beautiful. Now let's move on to the show request. The show request has a URL parameter, which is the ID of the user that we want to get specifically. By default, Scribe can automatically pick it up. However, if we want to customize the description, we can use the directive URL param to override the default documentation. Let's regenerate the documentation. Whoops, I made a mistake. The URL parameter name should be ID, not user. Let's try that again. And it works. Now currently the response is a mess. Let's fix this. This time the endpoint is showing a specific user. It's no longer a resource collection. So we'll be using the API resource directive. And similar as before, we'll pass in the namespace for our user resource class. And we also need to specify the resource model. Let's give it a go. And the response is now showing correctly. Great, let's move on to the store endpoint. Now the store endpoint is a post request. That means we're going to deal with request body. And to specify the request body, we'll use a directive called body param in a doc block. Our user store request contains two fields, name and email. Let's specify them inside our doc block. The directive that we need is called body param, and the structure of it is pretty much the same as query param. So after the directive, we'll put down the field name, the data type, the required keyword, description, and example. The store endpoint will return the created user, so we'll also need to specify the API resource directive, which I'll simply copy and paste from the show endpoint. Let's try it out. We'll regenerate our API documentation, go back to the browser, and the response is showing correctly. And we'll do the same for the update endpoint. And also the delete endpoint. For the delete endpoint, we are returning a custom JSON response here. So we can no longer use the API resource directive. Instead, we need to use the response directive, where we can manually define the structure of the API response. We can also specify the HTTP response code right after the directive. Alright, let's test our code, regenerate our API documentation, and back in the browser, we can see our update endpoint and delete endpoint are showing with the correct response. And that is pretty much it. This is a quick overview on how to work with the Scribe library and how it can help us to easily generate API documentation. The library has a lot of other features that we can't cover all of them in one single video. I highly recommend you to check out their documentation. The link is in the description. We still need to write the documentation for our comment and post resource. I'll leave that as an exercise for you. Again, the solution will be in the project repository. And also one more thing before we end the lesson. Scribe will also generate Postman collection for our convenience. If you want to see all your endpoints in Postman, simply import the collection.json file that it generates inside the docs folder. Alright, key takeaway for this lesson. Scribe is an amazing package that helps us to generate API documentation in a beautiful web page. We use the add directive in PHP docs to provide details about our API endpoints. That's it for now, and I'll see you again in the next video. Hey there, Sam. In the first few episodes of this series, we briefly talked about the Throttle middleware. But what is it anyway? In short, Throttle means to strangle someone in web development. Nah, actually, I'm just kidding. What it actually means is to limit the number of requests that are allowed in a certain period of time. For example, most web servers will only allow 60 API requests from the same user per minute. The reason is because if we allow unlimited requests to come into our web server, we'll get some malicious user who would send in 1 million requests per minute in an attempt to bring down our web server. The idea is to overwhelm our app with API requests so that our app will crash, or just to hijack our app so that it won't serve the other users. This is known as denial of service attack, or DOS for short. Luckily for us, Laravel has a built-in middleware called Throttle that will give us a basic protection against this attack, and it is extremely easy to set this up. What we need to do is to go to our HTTP kernel class and load the Throttle middleware inside the API middleware group, which is already set for us out of the box. The Throttle middleware is really a mapping to the Throttle request middleware class, as defined in the routes middleware array down here. Now by default, we're passing in an argument called API to our Throttle middleware class. This API argument is a predefined configuration that is provided by Laravel. It is a named Throttle configuration that is defined inside our routes service provider. Now inside the route service provider, there's a method called configure rate limiting. And inside the method is where we can define our own rate limiter. And as you can see here, Laravel has already defined an entry called API, and this is exactly what we used in the Throttle middleware just now. So as you can see in the code here, the API rate limiter is really limiting a maximum of 60 requests per minute. We can define our own rate limiter with a different name here by using the rate limiter facade. The for method is how we can add a rate limiter to Laravel, and the first argument is the name of a limiter. And the second argument is a callback function that allows us to define the logic of the rate limiter. The callback function accepts the incoming request as its argument, and it should return an instance of the limit class, which basically defines the configuration of our rate limiter. The per minute method defines how many requests we can allow per minute, and calling the by method will let us set a key to differentiate the request so that we can identify the source of the incoming request. If the user is logged in, we'll use the ID of the user, otherwise we'll use the IP address of the sender as the key. Now if you don't want to use a named rate limiter, we can also pass in the parameters manually. So let's go back to our kernel. To tell Laravel that we only want 60 requests per minute, what we need to do is to pass in the argument 60 and 1 to the Throttle middleware. How do I know these two numbers? The answer is in the source code. Let's dive into the Throttle request middleware. And as you can see in the handle method, the arguments that it is expecting is max attempt and decay minutes. Max attempt stands for the maximum request that is allowed, and decay minutes means the duration for the rate limiting to reset. And as you can see here, Laravel has an if statement here to check if max attempt is a string or not. If it is a string, then we will handle the request by using the named limiter. Otherwise, we'll proceed by the normal means. Behind the scene, Laravel is caching the incoming request by its key. As we discussed just now, the caching key of the request could be the ID of the user or the IP address of the user. And by default, Laravel will store the cache in files, as defined in our .env file. If you want Laravel to work faster and get more juice out of it, you can change the cache driver to Redis. Just that if you did change it to Redis, there is a better Throttle middleware built just for Redis. Let's go back to our HTTP kernel class, and we should replace the default Throttle request middleware with Throttle request with Redis. That being said, you don't need to touch this if you're not using Redis. Alright, that's about everything you need to know about the Throttle middleware. Before we end the lesson, I would like to do a quick demo to see what will happen if we reach the rate limit. So I'll modify our Throttle middleware so we can only take in 2 requests per minute. And now let's go to Postman. We'll try to send getRequest to the index method of our user resources. Click on send. We get a normal response. One more time, still okay. The third time, we get an error with a status code of 429, which means too many requests. And we also get an error message saying that we have too many attempts, since our app only allows 2 attempts per minute. Alright, that's it. Key takeaway for this lesson. In programming, Throttle means to limit the number of operations in a given period of time. The Throttle middleware in Laravel helps to mitigate denial of service attack or DOS attack from malicious users. We can define named rate limiter in the route service provider. And by default, Laravel has already defined a rate limiter called API for our application's API routes. We can pass in the rate limiting config directly to the Throttle middleware if we prefer not to use the named rate limiter. That's it for now, and I'll see you again in the next video. Hey there, Sam! Authentication is something super important in a typical web app, but it is also something that we all dreaded to write. Luckily for us, Laravel has an official package called Fortify that takes care of everything about authentication for us, so we don't need to start from scratch. Alright, let's install it. We'll go to the documentation and copy the installation instruction. We'll install it using Composer. Then we'll publish the config file. And finally, run a migration to create the relevant tables. Once we do that, we should go to our apt config file and load the Fortify service provider class into the provider's array. The Fortify service provider will register all the relevant Fortify actions for us. As you can see here inside the boot method, we've got create user, update password, and reset password. And each of these actions are customizable. And these action classes are living inside the action folder in our app directory, which was created by Fortify when we published the configuration of the package. These action classes will contain a logic to tell Fortify what to do on the corresponding authentication operations. Other than binding the authentication logic, the Fortify service provider has also defined 2 rate limiters for us, the login rate limiter where it will block the user after 5 failed attempts in a minute. You are free to customize the duration of the limiter. For example, if you're building a financial app, then it might make sense to improve the security by making the interval an hour instead of a minute. The other rate limiter is for the two-factor authentication feature provided by Fortify. Based on the definition here, the user cannot submit more than 5 two-factor verification per minute. Okay, now let's go into the Fortify config file and explore the configurations that are available to us. So firstly, we see a guard option here. In summary, guards define how users are authenticated for each request. By default, Fortify is using the web guard, and we can find its configuration inside the Auth config file. The web guard is using the session driver, which basically means that we are storing the authenticated user inside the session storage. And every time there's an incoming request, we'll simply verify if the user exists inside the session storage or not. If yes, that means the user is already logged in. If we use a token driver instead, then the user will be authenticated solely based on API token containing inside the request. The provider option indicates a way for Laravel to retrieve the user information. And the relevant option is defined further down in this file. And as you can see here, the user's provider is using Eloquent, and the matching model is a class name that refers to our user model. For most of the time, you don't really need to touch this option as they will just work out of the box. But if you really want to learn how to create our own customized guard and the details on how authentication works behind the scene in Laravel, we will explore more about this in another video. Otherwise, there'll simply be too much to cover. Anyway, let's go back to our Fortify config file. So the web guard simply means that we want Fortify to authenticate the user using the session storage and also Eloquent. For the next configuration, we have passwords, which is again a config to tell Fortify the password reset settings, and the corresponding configuration value will be inside our auth config file under the passwords key. Again, for most of the time, you don't need to touch these settings. The next config is username and email. Username needs to match with one of the model fields in our user model, and email refers to a field in the incoming forgot password and reset password request, where we need this field to send a user a reset password link. Home is the home URL of our app, and it is a location where Fortify will redirect a user to when the user has successfully logged in. Since we're building an API server, this value is not that relevant to us. Prefix is a great way to add a prefix to all the Fortify routes that will be registered. And domain is a way for us to add a subdomain in case we want to delegate of our authentication route to a different domain. And just for demonstration, we can list all of our routes now by using PHP Artisan route list. And as you can see in the list, hopefully it is not too small for you. These are all the API routes that are provided by Fortify out of the box. Now, if I add a prefix, something like API, rerun PHP Artisan route list again, and as you can see, all the Fortify API routes have now got an API prefix in front of them. The middleware option allows us to easily attach middleware to all of the Fortify routes, and the limiter option allows us to customize the limiter applied to the login and two-factor authentication routes, which by default is using the login and two-factor rate limiter as we define in the service provider. The views option will tell Fortify if we want to include the routes that returns the view for each authentication operation. Since we're building an API server and we don't need a front end, I'll set it to false. The next section is the feature of Fortify that we want to enable in our app. So we have registration here, which will allow people to sign up as a user in our app. Reset password will enable users to reset their passwords. Email verification would force user to verify their email before they can sign up or use our app. Update profile information and update password will allow users to update their profile and change their password. Two-factor authentication will enable the user to set up two-factor authentication, and the confirm password option here, if we set it to true, that means the user will need to enter their password during two-factor authentication. whether it is enabling or disabling two-factor authentication or getting or renewing the recovery codes for two-factor authentication. Enabling each of these features will tell Fortify to include the corresponding routes. For example, at the moment, we have the two-factor authentication routes inside our route list. If I comment out the two-factor authentication features, go back to our terminal and run route list again, we can no longer see those routes in the routes list. And that's a quick introduction to Laravel Fortify. I think it's a good place to stop here. In the next video, we'll discuss more about the features in Laravel Fortify, and I'll go through each one of them with you. Key takeaway for this lesson: Laravel Fortify is a package that takes care of most authentication logic for us. Fortify provides us several authentication features out of the box, namely registration, login, reset password, email verification, update profile information, update password, and two-factor authentication, so that we don't need to implement these common features from scratch. That's it for now, and I'll see you again in the next lesson. Hey there, Sam! In the previous lesson, we talked about the features in Laravel Fortify. Let's take a deeper look at them in this lesson. First thing first, let's comment out all the features in Fortify, and we'll investigate how Fortify will behave at its core level. Let's go to our terminal and run php artisan route list. And as you can see here, at the bare minimum, Fortify will only add a login, logout, confirm password, and confirm password status routes to our app. Let's test each one of these authentication routes out. Let's start with the login route. We'll need some dummy data, so I'll seed our database by running the php artisan dbseed command. Now at this point, we can't use Postman or any other external HTTP client to test these endpoints. The reason is because our API endpoints here in Laravel are protected by the Verify CSRF token middleware. Since we are applying the web middleware group in our Fortify config, and the web middleware group contains the Verify CSRF token protection, the CSRF or CSRF attack is a type of attack where a hacker would use to perform operation on a web app on behalf of the user without the user knowing it. A standard way to avoid the CSRF attack is to attach something called the CSRF token inside every API request. Only the legitimate request will contain a CSRF token. So if an incoming request does not contain a valid CSRF token, Laravel will block the request immediately. Let me illustrate this for you to better understand the CSRF attack. Let's say this is Joe, our average daily internet user. Now today, Joe logged into his favorite banking website to make some payment to his friends. The bank web app uses a session storage to store all the login sessions. Once the bank has stored Joe's login session, it now sends back a response to Joe along with a session cookie, which Joe's computer browser will keep as a proof that Joe has already logged into the bank. Any subsequent API request that Joe sends to the bank will contain this cookie, and the bank will use this cookie to identify Joe's session inside the session storage. Everything seems to be fine until suddenly HackerBan has joined the chat. You see, HackerBan has targeted Joe for quite some time now, and he knows exactly that Joe will do some internet banking at this time of the day. So HackerBan has previously prepared a malicious website that contains some nasty JavaScript code that will send API requests to the bank website that will transfer money from the victim's account to HackerBan's account. And on the surface, this website seems like a harmless website that has nothing to do with banking. Once everything is prepared, HackerBan then sends an email to Joe with the email title of "You have just won $1 million worth of Bitcoin," while prompting Joe to click on the link inside the email body that will redirect Joe to the malicious website that HackerBan has previously prepared. This happened while Joe still has an active session in his banking website. Immediately after seeing HackerBan's email, Joe jumped out of joy. He thought that he's the luckiest person on earth, and he can't wait to click on the link. Upon clicking on the link, Joe encountered a dodge staring at him in his eyes on the screen. Disappointed, Joe thought to himself, "There is no Bitcoin after all." But at this point in time, it is already too late for Joe, because HackerBan's JavaScript payload is already executing while Joe is staring at the dodge and thinking about investing in Dogecoin. So HackerBan's JavaScript payload proceeds to run in Joe's browser and sends the transfer money API on behalf of Joe. And since Joe is currently logged into the bank assumes that the API requests are authorized by Joe and went ahead and transferred all the money to HackerBan. This all happened within a few seconds and without Joe knowing it. And that is a simplified example of how a CSRF attack would look like. And now the question is, how can we prevent this? And one of the solutions is to introduce the CSRF token. So the idea is that a bank web app would issue a unique token known as a CSRF token to all of its website visitors. Whenever the website visitors sends an API request, it should also attach the CSRF token issued by the bank web app. So now all the requests that Joe sent to the bank will contain the cookie and also the CSRF token. And upon receiving a request, the bank web app would verify the CSRF token by comparing it against the CSRF token that it issued before. By introducing the CSRF token, HackerBan can no longer perform the CSRF attack. The reason is because there's no way HackerBan can get the CSRF token issued by the bank web app, because the CSRF token only exists inside the page that Joe has visited, and HackerBan is sending the API request from its malicious page, and he couldn't see the CSRF token issued to Joe, so he can't attach the CSRF token into his malicious request, and therefore all the money transfer API requests will fail. So the moral of the story is, don't be like Joe and click on any random link in the internet, and always use a private window or the incognito mode in your browser when you're banking. And now back to our code. We now know that in order to send a request, we need to attach a CSRF token issued by Laravel inside our request. And that means we can't use HTTP client like Postman, because we won't have access to the CSRF token issued by Laravel. I'll show you what I mean. So now if we go to Postman and send a post request to the login route, we see an error in the response saying that CSRF token mismatch. So the question is, how can we solve this? We'll need to install another package called Laravel Sanctum to address this, for which we'll talk about in more details in the next few videos. For now, just to keep this lesson going, I'll disable the CSRF token verification so that we can test the Fortify routes. We will revisit this topic again in the next few videos, and I'll show you the proper way of implementing CSRF token verification in the context of API server using Laravel Sanctum. Alright, now let's go back to Postman and we'll send our login request again, and now this time it works, returning us with a 200 response code. Alright, now we'll test the confirm password route. This route will only work if the user is currently logged in. It is a post request and the body should contain a password field. This route is very useful in situations where we want to reconfirm the user's identity. For example, when a user wants to change their profile information. Let's click on the send button, and our app returns a success response with an empty body. Now if the password is not valid, Fortify will return us an error response. Okay, next we have a GET request to confirm the password status of the user. Let's go back to Postman, change the request, and we see a success response. Great, let's move on. Next, we'll try to log the user out using the logout endpoint. And we see a 204 response with an empty response body. And now since we are logged out, if we try to call an endpoint that requires the user to log in, we'll see an error. For example, if I send a GET request to the confirm password status endpoint, we'll see a 401 status code with the response of unauthenticated. Alright, we just went through the basic features of Fortify, and now let's investigate the registration feature. We'll go back to the config file and uncomment the registration feature. And we'll go back to our terminal and run php artisan route list again. And this time we see a new addition to our route list, which is the register endpoint. Let's go back to Postman and test it out. We'll send a post request to the register endpoint, and in the request body, the register endpoint accepts 4 fields: name, email, password, and password confirmation. Once we're done, let's click on the send button, and we get a status code of 201 with an empty response body. At this point, we should have created a new user. Let's check it. We'll send a GET request to our user's index endpoint, and scroll all the way to the very bottom, and we see HackerBan, and that means our endpoint is working. We can customize the registration logic by modifying the create new user action file living inside the Actions Fortify directory. So if your front-end form contains other fields than the basic email and password, this is a place where you can customize the logic to create a new user. Alright, let's move on. Next, we'll enable the reset passwords feature, and it will add the forgot password and reset password routes to our app. The forgot password route will send an email to the user with the password reset link in the body of the email. And the reset password endpoint will actually reset the user's password. Let's go to Postman and try out these two routes. We'll reset the password for HackerBand. It will send a post request to forgot password, and the body should contain an email field, which is the email address of HackerBand. Now currently we're logged in. If we attempt to send this post request now, Laravel will throw us an error because we're not supposed to forget our password while we're still logged in. So we should log out first, and then we'll try to forget our password again. And now we see a new error, saying that the route password reset is not defined. So it turns out that a link inside the password reset email should redirect a user to a view where the user can reset their password. Since we have told Fortify to disable all the views in our app, and hence the password reset route was not registered by Fortify. So to work around this, we should define our own password reset route, where it will show a form for the user to reset their password. I'll copy the route definition from Fortify's source code, which is living inside the routes.php file inside the routes folder. And I'll paste this route definition inside our web.php. And I'll refactor the code so that it will simply return us the password reset token. Let's give this another try. We'll go back to Postman, click on the send button again, and we get a 200 response, telling us that Laravel has sent us the password reset link. I'm using Mailtrap.io to capture any outgoing email, and inside my Mailtrap.io dashboard, we do see a new email coming into our inbox, and it is sent from our app that contains the password reset link. Let's click on it, and we're redirected to our password reset page, which is returning us our password reset token at the moment, as defined in our route just now. And now let's try to reset our password. We'll copy the token and go back to Postman, send a post request to reset password. These endpoints accepts 4 fields inside the body: the user's email, the new password, and the new password confirmation, and lastly, the password reset token. Let's click on the send button, and we see a success response. Great! Our endpoint is working, and now we should really consider to make a proper view for this endpoint. Let's go ahead and do that. I'll create a new folder called Auth in our views folder, and I'll create a new blade file called password reset in it. And now I'll use my fast forward life hack to quickly create a form to reset the user's password. My life has been very productive since I learned this skill. I highly encourage you to learn that skill as well. Once we're done, we'll go back to our browser and hit refresh, and our form is showing on the screen. Great! I think it is a good place to stop here. We'll continue in the next lesson. Key takeaways for this lesson: Laravel protects all its web routes from CSRF attacks by default. We will need Laravel Sanctum if we want to protect our API routes from CSRF attacks. We can use Fortify action classes to customize the user registration logic along with other actions. The password reset post endpoint requires a get route with a name of password reset in order for it to work properly. Otherwise, Fortify can't generate the email for the user to reset her password. That's it for now, and I'll see you again in the next lesson. Hey there, Sam! Let's continue from where we left off in the previous video. We discussed about the registration and reset password features in Fortify, and now let's move on to email verification. In summary, the email verification feature, as the name suggests, will force the user to verify their email when they sign up to our app. Let's enable the feature in our config file, and we'll head to our terminal and run php artisan route list. And here, as you can see, the feature has added 2 new routes to our list. The post email verification notification endpoint will send an email verification link to the current logged in user. This typically happens right after the user has just signed up to our app. And if the user clicks on the link inside the email, which is the verification get route here, their email address will get verified and they can continue to use our app. Now, before we go through the whole verification process, if we want to force our user to verify their email, we need to get our user model to implement the must verify email contract. So let's go to our user model and implement the interface. And now the email verification feature should work. Now let's go to Postman and we'll test out the email verification routes. As I mentioned earlier, the post route for email verification will not work unless the user is logged in. At the moment, no one is logged in our app. So if I try to send a post request to the endpoint, it should fail. And as expected, we get an error. Okay, now let's try to go through the whole sign-up process again. First of all, I'll register a user by sending a post request to our register endpoint. And we get a 201 response. That means our user is created successfully. And since we have told our user model to implement the must verify contract, at this point, our app should have sent a verification email to our user. Let's go to mailtrap.io and we see an email in our inbox telling us to verify our email. Let's click on the link. Oops, we see an error saying that our login route is not defined, which makes sense because we have disabled all the views in Laravel Fortify. But why are we getting redirected to the login route anyway? And if we look at the stack trace, we notice that this error comes from the Authenticate middleware, which means we're trying to send an API request to a protected route. This email verify endpoint is protected, and the fact that our app is trying to redirect us to the login page means that we're not logged in. We are logged in Postman, but not in the browser. The browser did not have the correct cookie when it is sending the GET request to verify our email, and our app could not possibly tell our user is logged in without any cookie. So to get this to work, we should send this GET request inside Postman, where we do have the authentication cookies. So I'll copy the URL and go back to Postman and send it as a GET request. And now we get a status code of 202 back and did not see the error anymore. At this point, Laravel would have already verified our user's email. And now if we try to view our data in MySQL, we will see our latest user will have a timestamp for the email verified at column. And that means our latest user has verified their email. Now if you want to protect our routes so that only verified user can access them, we can apply the verified middleware to our routes. The verified middleware is defined inside our kernel and in a routes middleware mapping, as you can see here. And just for demonstration, I'm going to apply this middleware to all of our API routes by putting it inside our API middleware group. And now let's go back to Postman. I'll log out the current user and log in as Hackerban because Hackerban has not verified his email yet. Oops, I entered the wrong password. Let's try again. And we're in. And now let's try to call one of our API requests. Since Hackerban has not verified his email yet, we would expect an error. We'll try to call the getUsers endpoint, and we see an error. Great, that's email verification in a nutshell. Now let's move on. The next Fortify feature will enable us to update the user's profile information. Let's go back to our terminal and see the newly added routes. So Fortify has added a new put request that will update the user's profile information. To customize the update logic, we can go to the Fortify action folder in the Update User Profile Information class and refactor the code as we see fit. By default, the API only accepts two fields, the name and the email fields. Let's go back to Postman and we'll log in as a verified user and attempt to update the name of the user. We will send a put request to the user profile information endpoint, and in the body, we'll change the name of the user. Oops, the email is also a required field, so we'll put that inside the body as well. Let's try that again. And this time it works. By default, from the code that Laravel has given to us, if we attempt to change the user email, Laravel will send another email verification email to the user, and the user has to repeat the whole email verification process again if we have implemented the must verify email contract for our user model. Anyway, let's move on. The next feature will enable routes for the user to update their passwords. Again, let's go to our terminal and take a look at the routes. And we see a new put endpoint that is linked to the update method inside the password controller provided by Fortify. Again, we can tweak the update password logic inside Fortify action class, namely the update user password class. And as you can see here inside the logic, the endpoint expects two fields, the current password and a password field. Let's give it a shot and try to change our current user's password. We'll go back to Postman and send a put request to the update password endpoint. The body will contain a current password and a new password. Let's click on send, and we see an error saying that we also need a password confirmation field. The reason is because inside the validation rules, the password field has a confirm rule included with it. The confirm validation rules requires us to attach a confirmation field inside our request body. So let's go ahead and fix that. And now let's try that for one more time. And this time it works. We get a 200 response code. And just to make sure that our current user's password is updated correctly, I'll log out and log in again with the new password. And it works. The last feature that we will go through is the two-factor authentication. This is a bit more complicated than the rest, and we'll continue to talk more about it in the next video. Key takeaway for this lesson: Fortify provides us a handy email verification feature to confirm the user's email address. We can use the verify middleware to protect our app routes. So if an unverified user tries to call our API endpoints, our app will stop the user. However, in order for that to work, we'll need to implement the must verify email interface to our user model. That's it for now, and I'll see you again in the next video. Hey there, Sam! And now it's time to implement the two-factor authentication. Now, first thing that you'll notice is that this feature accepts an array of options in its argument. And currently, there's only one option in here where Laravel has set a confirm password option to true. In summary, if we set this option to true, Laravel will provide additional security by prompting the user to re-enter the password when they want to set up their two-factor authentication. For now, let's take a look at the routes that this feature has added to our app. We'll go to our terminal and run php artisan route list. And now, as you can see here, we have a delete two-factor authentication endpoint and a post two-factor authentication endpoint. The post endpoint is for the user to enable two-factor authentication, and the delete endpoint is for the user to disable two-factor authentication. We also have a get endpoint for the user to retrieve their two-factor QR code, where they can scan the QR code in their favorite authenticator app on their phone as part of the setup. Now we also got the post endpoint and get endpoint for the recovery codes. The post endpoint is for the user to regenerate the recovery codes, and the get endpoint is for the user to display their current recovery codes. And finally, we also have this post endpoint to the two-factor challenge route. This is the route where the user will send a two-factor authentication code on their phone to our app, and Laravel will verify the code behind the scene. Alright, let's bring everything back together and go through the whole two-factor authentication setup process and verification process. So after the user has logged in, if they want to set up two-factor authentication, they will send a post request to the two-factor authentication endpoint. And if we have set the confirm password option to true, our app should prompt the user to re-enter the password and send a post request to the user confirm password endpoint. Otherwise, the setup for two-factor authentication will fail. Once 2FA is enabled, our app should send a GET request to the QR code endpoint to retrieve a two-factor QR code from Laravel Fortify. And then the user can proceed to scan the QR code in their Authenticator app. Once the two-factor authentication is set up successfully, our app should send a GET request to retrieve the user's recovery codes. If the user is not happy with the current recovery codes, they can send another post request to the recovery codes URL to regenerate a new set of recovery codes. And now at this point, the user should be good to go. So the next time when they want to log in, right after they have entered their credentials, they should also send a post request to the two-factor challenge endpoint with the two-factor code from their Authenticator app. And if for some reason the user decided to disable two-factor authentication, they simply need to send a delete request to the two-factor authentication endpoint here. And that's basically the workflow of two-factor authentication in Laravel Fortify. And now let's dive into the code right away. First of all, let's talk about the confirm password option here. As I mentioned just now, if we set this to true, Laravel Fortify will force the user to confirm their password when they want to set up their account with two-factor authentication. But how does this thing work behind the scene? To answer this question, let's dive into the source code of Laravel Fortify. We will open the routes file, and this is where Laravel Fortify defines all of its endpoints. We'll go to the two-factor authentication section. And as you can see here, the code is very easy to read and understand. The first if statement here is simply checking if the two-factor authentication feature is enabled. And we will register the routes only if it is true. What we're interested in here is the two-factor middleware variable here. What it is doing is checking if the confirm password option is true or not. If yes, the middleware will contain the authentication guard and password confirm. Otherwise, it will just be the authentication guard. And then Laravel Fortify went ahead and applied this middleware to the rest of the routes registered down here. So the user has to confirm their password when they attempt to enable or disable two-factor authentication, or get a two-factor QR code, and also getting and regenerating the recovery codes. And now, here's another question. How does the password confirm middleware work? To answer this, we'll need to go back to our kernel class. And we see that the confirm password middleware is mapped to the require password class. And we'll go to the handle method of the require password middleware class. We can see that it is simply running a function called should confirm password to check if the user has confirmed the password or not. And inside the function, what it really is doing is getting a key in the request session called password confirm at, which is a timestamp when the user last confirmed their password. And we subtract it from the current time to determine whether if the user needs to reconfirm the password again by comparing against the password timeout property. And how would the user confirm the password? The answer lies inside the confirm password route. Let's go back to the Fortify routes file, and we'll look inside the controller of the password confirm route. And as you can see in the logic, once the password is confirmed, Laravel simply set a new key called password confirm at inside the request session with the value of the current time. And this value in the session will be put forward for future use, for example, in the confirm password middleware. So hopefully that makes sense. You should now have a better understanding on how these methods and functions connected together. Alright, now let's go ahead and test the two-factor authentication workflow. First thing first, we'll go to our terminal and list down all the routes. And then we'll go to Postman and log into our app. Once we're logged in, the first thing we want to do is to enable two-factor authentication. And we can do that by sending a post request to user/two-factor authentication. Whoops, we got an error because we have enabled the confirm password option. So we first need to confirm our password by sending a post request to user confirm password. And I have also forgotten one more thing. In order to get two-factor authentication to work, we also need to go to our user model and get our user model to use the two-factor authenticable trait. And now let's go back to Postman. We will send a post request to the confirm password endpoint. And the request body should accept the current user password. Let's click on the send button, and it works. And now let's go back to enable our two-factor authentication. And this time we get a status code of 200, and that means we have successfully enabled two-factor authentication. Great! And now let's try to get a two-factor QR code. I'll send a GET request to this endpoint. And in the response body, we get an SVG element. And in the front end, we're supposed to take this SVG element and render it in our browser for the user to scan it in their Authenticator app. And unfortunately, Postman cannot render this SVG element. Alright, let's move on. Next, we'll try to get all the recovery codes by sending a GET request to the user two-factor recovery codes endpoint. And in the response body, we get an array of recovery codes that looks sort of like gibberish. And in the front end, we should prompt the user to keep these recovery codes in somewhere safe. Next, we'll try to regenerate a new set of recovery codes by sending a post request to the same URL. And we get a 200 response with an empty body. We should have get a new set of recovery codes by now. Let's send another GET request to retrieve our recovery codes again. And we get a new set of recovery codes. Great! And just one note here, any given user can only have one set of recovery codes at one time. So that means if we keep calling the GET request to fetch the recovery codes, we will always get the same result. Alright, let's move on. Next, we'll try out the two-factor challenge endpoint. In Postman, we'll send a post request to this endpoint, and this endpoint is expecting the request body to contain either the two-factor authentication code from our Authenticator app or one of our recovery codes. I did not use an Authenticator app in this demonstration, so I'll go ahead and use one of my recovery codes. Let's send a request. And we get an error saying that this route is not found. Now this happens because currently we're logged in. Laravel Fortify will not allow us to do the two-factor challenge while we're still logged in. So let's go ahead and call the logout endpoint. And now we should have successfully logged out. And now if we go ahead and call the challenge endpoint again, we see another error saying that our authentication code is invalid. Why is that? Because in order to do a challenge, first we'll need to try to log ourselves in. In a typical web app, the user will only do the two-factor authentication challenge right after they have successfully logged in. So here, we should really log ourselves in before doing the two-factor challenge. Let's send a post request to the login endpoint, and in the response body, we see a field called two-factor set to true. The front end can use this value to determine whether to prompt the user to enter the two-factor authentication code or not. And now we're logged in, but we haven't done the two-factor challenge. And if we try to call any endpoint in our app, we should get an error. And as expected, we got a 401 error saying that we're unauthenticated. Okay, now let's try to do the two-factor challenge. We'll send a post request to the two-factor challenge endpoint, and we see a 204 success code with an empty body. And that means we should be in by now. Let's send a GET request to try and fetch all of our recovery codes again. And we no longer see the unauthenticated message, but instead we see an error telling us to confirm our password again. And the reason is because we're now logged into a new session. And in this new session, we haven't confirmed our password yet. So let's go ahead and do that. And once we have confirmed our password, let's try to refetch the recovery codes again. And we get a success response. But one thing to note here is that we got ourselves a new set of recovery codes. This is intentional because for security reason, if the user used their recovery code to log in, that means the two-factor authenticator could be compromised. And Laravel Fortify will issue the user a new set of recovery codes just to start fresh. And in the front end, we should really show the user this new set of recovery codes and prompt them again to keep them safe. Alright, lastly, we'll test our final endpoint, which is to disable two-factor authentication. We will send a delete request to the user two-factor authentication endpoint, and we get a success response. And that's about it. That's a lot of information, but it is everything that you need to know to work with Laravel Fortify. Have a go by yourself, and just play around with this endpoint until you're comfortable with them. Key takeaway for this lesson: we need to use a two-factor authenticatable trait in our user model in order for two-factor authentication to work properly. The confirm password option will force the user to confirm their password when setting up 2FA. Laravel will issue the user a new set of recovery codes if they log in using their recovery code. That's it for now, and I'll see you again in the next video. Hey there, Sam! Laravel Fortify offers us quite a number of ways to customize the package, and that includes customizing the views or email that Laravel Fortify will send out to the user. Let's take a deeper look at that. To understand how email verification works, we first need to look at how Laravel Fortify sends out the verification email. To do that, we'll go to Fortify's routes file and look for the post endpoint that sends out the verification notification. We'll go inside the email verification notification controller, and in the logic, we can see that Laravel is calling the send email verification notification function on the logged in user model instance. And that means if we define this function in our user model, we can customize the logic of sending out an email verification notification. But how does Laravel handle this by default? Let's go to our user model. And as you can see, our user model looks quite empty by default. Laravel has hidden a lot of code by default within a framework. And now if we look at the must verify email contract, which is also known as interface, we can see that there's a function called send email verification notification in it. Since this is a PHP interface, that means this function is defined somewhere inside the framework. Let's do a global search, and we found it. It turns out that this function is included inside the must verify email trait provided by Laravel inside the Illuminate Auth namespace. And the function logic here is quite simple. It simply calls the notify function from the user model and accepts a new verify email notification class instance. We haven't spoken about notification yet, but the idea of it is very similar to sending out an email in Laravel. However, with notification, we can get Laravel to send out to different channels like Slack, Discord, or SMS. These are the alternative ways for us to send notification to our user if we prefer not to use email. Anyway, let's go inside the verify email class, and we can see that there's quite a bit of things going on here. But the main part that I need you to look at is this toMail function. Out of the box, Laravel will use a mail channel to send out notification. And this toMail method is exactly what Laravel uses to build the email message to send out to the user. And the logic of it is quite simple. First of all, we'll create the verification URL, and then we'll pass in this verification URL into either a custom callback function or the built-in build mail message function. The fact that Laravel is checking and calling a custom callback function means that we can customize this verify email notification class without creating a brand new custom one from scratch. We'll go through the custom callback in just a minute. For now, let's look at how the build mail message function works. As we can see here in the function logic, it is simply returning a new instance of the mail message class. The mail message class is a helper class that allows us to quickly create a one-off email template without the need to create a separate view file. The API here is quite easy to understand. As you can see here, we just need to call the subject method to define the subject of the email, and the line and action method will allow us to define the body of the email. And we're calling the get method from the lang facade to fetch a translation of the provided key to a different language. This is part of the internationalization of Laravel. We will revisit this topic in more details in the upcoming videos. For now, you just need to think of the lang facade as a quick way to grab translation for a different language. Now, if we want to customize the mail building logic, we can either use the mail message helper class or provide our own view template. The verification email needs to have a verification URL contained in it, which is represented by the URL argument here. And by default, this URL is generated by the verification URL function. And again, if you look inside the function body, Laravel offers us a way to customize the URL generation logic. If we did not supply the custom callback, then Laravel will generate the URL by using the sign route method from the URL facade. The temporary sign route method will create a temporary link that has a signature or token attached to it. Having this unique signature can help us to protect a certain route so that we only allow a certain user to access the route. In our case here, we only want the current logged in user that is undergoing the verification process to click on this link. We are encoding the user's information into this route, which in our case here will be the user ID and the user's email. And we're hashing the user's email using the SHA-1 hashing algorithm. Since the user's information is encoded into the URL, if someone else attempted to click on this link, the encoded user information will not match the imposter's information, and therefore we'll know that this link is not clicked by the legitimate user. There's a lot more to talk about the sign route in Laravel. I think it deserves its own video, and I'll stop it here. Okay, for now, let's try to customize this verify email class. We're gonna set up the custom callbacks to build the mail notification and also the verification URL. We will write our customization logic inside the Auth service provider. To customize the mail building logic, we will call the toMail using static method. The method accepts a callback function that accepts two arguments. The first argument is the user, and the second argument is the verification URL. And what we want to do here is to simply return a view. Let's go ahead and create a blade file inside our views folder. And I'll call it verify.blade.php. I'll be using Laravel's built-in mail markdown component by using the mail message directive. And I'll go ahead and type in something stupid here and pass in a verification link for the user to verify themselves. And now we'll go back to Auth service provider. And inside the callback function, we need to return a new instance of mail message. Let's create a new mail class for our verification notification. We'll go to our terminal and type in php artisan make mail, and I'll call it verify mail. And now inside our mail folder, we can see our newly created verify mail class. Let's modify it so that it will send the verification email to the user. I'll get a mail class to accept our user and also the verification URL. I'll make these two properties public so that they'll be passed into our blade template automatically. And now inside the build function, we will return a markdown, which is referring to our verify.blade.php. And we also need to specify who do we want to send this email to, which in our case here, will be sending to our user's email address. Alright, let's go back to our Auth service provider, and we'll get our callback function to return a new instance of our mail class, and pass in our user and verification URL to the constructor. And now let's give our code a test. We'll go to Postman and register for a new user account. And we get a success response. At this point, the user should have received a new email telling them to verify their email address. And we head to mailtrap.io, and we see a new email in our inbox and our custom verify mail message. Great, so that's how we can customize the verification email in Laravel. We can also customize the logic to create the verification URL by calling the create URL using method and passing a callback function in it, where we'll write the logic to create our own custom verification URL. For most apps, I do not encourage you to touch this logic at all. Just use what Laravel has already provided us. We'll stop here for now. In the next video, we'll explore more ways that we can customize Laravel Fortify. I'll see you there. Key takeaways for this lesson. Laravel Fortify relies on a built-in verify email class provided by Laravel to send out verification emails. We can call the verify email to mail using method to define our own logic to send out the verification notification. We can encode information into Laravel's sign route for the purpose of validation. This is very useful if we want to create routes that is only accessible by a certain user. That's it for now, and I'll see you again in the next video. Hey there, Sam! Laravel Fortify also allows us to customize the login logic. The first thing I want to show you is a way to modify the default login function provided by Laravel Fortify. To do that, we'll go to our Fortify service provider, and we'll call the authenticate using static method from the Fortify class. Now this method allows us to override the default authentication logic provided by Fortify, and it accepts a callback function, and the callback function receives an instance of the request as its argument. Now we're free to write any logic that we want inside this function. In order to log a user in, we simply need to return the user instance, and that means look up the user from our database and return the user model instance inside this function. And again, for most cases, you don't have to customize the authentication logic, unless you're not happy with how Laravel does authentication out of the box. And now, just for demonstration, I'll not return any user instance in this function. Instead, I'll just return a false and expect all the login attempt to fail. And now we'll go to Postman and send a login request to our app with the credentials of a valid user that we have registered in the last video. Let's click on Send. And as suspected, it does not work. Now let's go back to our code, and this time I'll hard code the authentication logic to return a known user. So it doesn't matter what the credentials that the request has sent us, we will always log in with the user with ID number 1. And now let's go back to Postman. I'll duplicate our login request. And this time I'll type in some gibberish credentials. Let's click on Send again. And we're in. And that's how we can customize the login logic in Laravel Fortify. Again, what I'm doing here is just for demonstration only. Hard coding to log a user in is super dangerous, so do not do this at home. Alright, let's move on. Sometimes we want to add a few extra steps before or after the user is authenticated. For example, if we detected that the user has logged in from a different device or from an unusual location, we might want to send an email to the user to warn about this unusual activity. Laravel Fortify offers us another static method called authenticate through to handle this situation. And similar to authenticate using, this function also takes in a callback function that accepts a request instance as its argument. Now Laravel Fortify requires us to return an array of classes inside this callback function. Each of these classes should be invocable, and that means each of the classes should implement the invoke magic method, because Laravel will attempt to call each of these classes one by one from top to bottom. If you haven't heard about the invoke magic method in PHP, it simply means that making a class callable. And that means once we define this magic method, we can call a class just like a function. And this is the authentication pipeline provided by Laravel by default. You can customize it in any way you like, just make sure that every class that you put inside this array is invocable. I'll show you what I mean. I'll go ahead and create a dummy class inside our Fortify action folder. And I'll define the invoke method inside this class. Now Laravel Fortify will pass a request instance to all the classes inside the pipeline, so we'll get our invoke method to accept an instance of our request class as its first argument. And the second argument is a callback function for us to move on to the next class inside the pipeline, which is very similar to the next argument inside Laravel middleware. We will need to call this next callback function in order for the pipeline to progress, otherwise our code will just stop. And just for demonstration, I'll dump something stupid in here and refuse to call the next callback function for now. And we'll go back to our Fortify service provider and load our dummy class inside the pipeline. If everything goes smoothly, our authentication process should stop at our dummy class, because we did not call the next callback function. Let's try it out. We will log out and log in again with the correct credential this time. And in the response, we see our string dump without any other information. And now let's go back to our code and we'll go back to our dummy class. And this time we'll call the next callback function and pass in our request to the next class in the pipeline. And now just for demonstration, I'll put two dummy classes inside our pipeline so that we'll see two sets of hey yeah inside our response. Let's go back to Postman and I'll try to log in again. And now, this time, we see two sets of hey yeah. And again, one more time, if I go back to my dummy class and comment out the next function, go back to Postman, try to log in again, and we only see one hey yeah. Okay, so the next function is mandatory to call in order for us to progress inside the pipeline. Which in our case here, our pipeline stopped on the first dummy class because we didn't call the next function in our dummy class and our pipeline is broken. Alright, next, we can also customize the confirm password logic by calling the confirm password using static method from Fortify. Again, this static method will accept a callback function that takes in a user argument and also the password input provided by the user. What we need to return inside this callback function is a boolean. We will return true if the password is confirmed correctly, otherwise false. The user argument is an instance of the current logged-in user, and the password argument is what the user has provided inside the request. And it is entirely up to you on how you verify these two information. And again, in most cases, you don't have to override this confirm password logic. Just let Laravel Fortify to do the work for you. Alright, let's move on. We can also customize the views that Laravel Fortify is sending out by using the following methods. This is extremely useful when you have enabled the views option in Fortify's config. In each of these callback functions, you just need to return the view to the corresponding page. However, this is not that relevant to a single page application or an API server, so we don't need these in the app that we are currently building. But feel free to play around with it if you are interested. It should be quite straightforward as the function name tells you exactly which view is it customizing. Alright, it's a good time to stop here. I will see you again in the next video. Key takeaway for this lesson, we use the Fortify authenticate using method to override the default login logic. The authenticate through method allows us to customize the authentication pipeline. So in case if we want to add additional action in between the authentication pipeline, we can do so using this method. The confirm password using method provides us a way to customize the password confirmation logic. That's it for now, and I'll see you again in the next video. Hey there, it's Sam. As we discussed in a previous video, to create a fully working authentication system in Laravel for an API server, Fortify on its own is not enough, because API users typically authenticate themselves using tokens or cookies, and Laravel Fortify does not provide such features out of the box. However, the good news is Laravel does provide us two extra packages to compensate this, and they are called Laravel Passport and Laravel Sanctum. Passport is designed for big enterprise applications, where there's a need for OAuth and other advanced features. Sanctum, on the other hand, is designed for applications that only needs a simple means of authentication. We will be using Laravel Sanctum, and maybe we'll discuss more about Laravel Passport in another series. Alright, first of all, I would like to talk about how Laravel Sanctum works. In summary, Sanctums provide us two ways to authenticate ourselves. The first way is to use API tokens. So as long as an incoming API request contains a valid API token, the request will be considered as authorized. Typically, the client will include the API token inside the request header, and Sanctum will inspect the request header for the API token to authorize the user. Now, the second way is to use cookie. Similar to the token-based authentication, Laravel Sanctum will also inspect the incoming request for any authentication cookie that it issued to the user before. If the cookie is inside the header and it has yet to expire, then the request is considered as authenticated. When a client first made a request to the server, Laravel Sanctum will issue the cookie to the response. Any subsequent request that the same client sent to the server will have this cookie included in the header. If the client made a successful login request to the server will take note of the cookie inside the request and mark it as authenticated in the server-sided database. So now the client has logged in, and for any future request, as long as the client has submitted the same cookie inside the header, Laravel Sanctum will inspect the cookie and attempt to cross-check it against a record on the server side. If the server has a record of the same cookie, then the request is authorized. Since we're storing a state on the server side, which in our case here will be the cookie, this process is also known as stateful authorization. And now the big question is, which one should we choose? And I'm going to answer this question with the most hateful answer. It depends. You see, API token is very simple, but it is also very risky. The reason is because if your token is stolen by someone else, that person can simply use your API token and act on behalf of you. There's no way the server would know the API request was made by someone else, because the only means of identification is through the API token. As long as the incoming request contains the API token, the server will simply assume that the request was made by the rightful owner. So the only way to stop the hacker from keep using your API token is to simply revoke the token. On the other hand, the cookie method provides more protection compared to the API token method. Laravel Sanctum makes use of the WebGuard when it authorizes requests using the cookie method, and that means our app will be protected from CSRF attack and cross-site scripting attack. However, the cookie method is more complicated to set up and also stricter, and that means it is harder for the client to send API requests. It is a trade-off between simplicity and security. These two methods are very common in a lot of web apps, and it is really up to you on which one to pick in your next project. In this app, I'll be using the cookie method, and now let's dive into the code and get started with Laravel Sanctum. Alright, first thing first, let's go to our terminal and install Sanctum by typing in composer require laravel/sanctum. The next step is to publish Sanctum's configurations. I'll type in PHP Artisan vendor publish and look for Sanctum, which happens to be 12. And we also need to run PHP Artisan migrate for Sanctum to create a table to store API tokens. Next, we'll go to our HTTP kernel file and we'll uncomment the verified CSRF token middleware, which we previously omitted. Now we no longer need to exclude it because we have installed Sanctum and it should start working once we have set up Sanctum. And to let Sanctum protect our API routes with cookie-based authentication, we should also load the ensure front-end request as stateful middleware in our API middleware group. Including this middleware will make Laravel to inspect the incoming request for the CSRF token and also the authentication cookies. Next, we'll need to configure some of the environmental variables. We'll go to our .env file. The first thing that we want to change is the session driver. We want to change it from file to cookie. This will instruct Laravel to store our session details in the form of an encrypted cookie. Next, we'll need to add a new variable called session domain. This tells Laravel which domain is our app located at, so that Laravel can safely issue the cookie for the session. Now this value must match with the domain of your front end. Otherwise they'll be issued inside the browser. I'll talk more about this later in the video. Now if you have an actual domain name, you should put it right here. You can prefix a dot in front of your domain name to support any subdomains that you may have. This is very important, especially when we have our front end living in a subdomain of our main domain. In fact, due to security reason, our front-end client and our server should be living in the same top-level domain with the same port. If we don't do this, most browsers will refuse to save the cookie from the server response. Again, I'll show you how this thing works later. The last variable that we want to set is called Sanctum stateful domains. This variable determines which domains will maintain the stateful authentication using Laravel session cookies. So for every incoming request, Laravel will inspect this variable to check whether it should make a stateful cookie or not. And if your app has multiple subdomains, you can use a comma to separate your domains. And always include a port number if the domain is not using a standard port. Otherwise, Laravel Sanctum will not work. Alright, now we're done with the environmental variable. Let's go ahead to our API routes and protect our routes with the Sanctum Auth middleware. By default, Laravel uses the API Auth middleware to protect the routes. However, this will not provide the benefit that Sanctum offers to us. To get Sanctum to work, we simply need to apply the Auth middleware and passing in the Sanctum argument to it. Simple as that. Alright, our initial setup is now done. Let's give this bad boy a quick test. I'll quickly create a dummy web page and do our test in there. First, I'll create a new blade file, load the boilerplate, and go to our web routes and add the routes to it. Alright, back in our dummy web page, let's write some JavaScript to test Laravel Sanctum. Here's what we should do when we want to authenticate ourselves in the context of a single page application. Laravel Sanctum will protect its routes from CSRF attack. So the first thing that we want to do is to get a CSRF token from Laravel. And Sanctum will provide us this token in the form of a cookie. And to get this cookie, we need to send a GET request to this endpoint called Sanctum/CSRF cookie. And I'll pass in the standard headers and also the credentials include option. We should have this option in all of our API requests. Otherwise, the browser will not send a cookie to our server. Alright, now let's open this page in our browser and we'll go to our network tab and inspect the CSRF cookie request. In the response header, as you can see here, our Laravel server is sending back us multiple set cookies headers, and this is exactly where our journey of stateful authentication starts. The XSRF token here is really our CSRF token. And live post session is our session cookie, where Laravel will use this to track our current browsing session. And the third one down here is some voodoo magic. I have no idea what that is. Might need to do a bit more digging into the source code to find out more. If you know what this cookie is, please let me know down in the comments below. My best guess is that it is some form of encrypted data, and it is there for security reason. And now, if we go to the application tab, under the cookies section, we can see that all the 3 cookies has been set inside our browser. And that means our browser is able to take in these cookies without any issue. Now let me demonstrate what will happen if we did not set up Sanctum correctly. Let's go back to our .env file. And I'll change session domain to localhost. Now remember what I said earlier, the browser will need the domain of the web page to be the same as the domain listed inside a cookie. And if we go back to our browser now, I would expect our browser will refuse to set this cookie. Let me clear all the cookies. And I'll refresh my page. And now we see a little warning icon besides our cookie. Oh dear. The other thing I need you to take attention of is that the domain key in our cookie is now set to localhost, which is exactly the value that we set for our session domain environmental variable. Let's hover on the warning sign. I think this is a bit too small for you to see it, but it says that the browser cannot set a cookie because the domain inside the cookie and the API host are different. To resolve this, we can either change the session domain environmental variable or simply change our URL to localhost instead of the IP address. So if I change my URL to localhost, the cookies are now setting again. Great. Now let's move on to the second issue. For the other environmental variable, we need to make sure that the domain that we listed here have the same top-level domain and also the port. If we don't include the port number or if the domain is not matching, then Sanctum will not bake stateful cookies for our app. And since we're using localhost now, I'll add localhost to our stateful domain list. I will show you now how we can log our user in from our front-end JavaScript. Let's go back to our dummy web page. I'll create a new function called login and send a post request to our login endpoint with one of the dummy user credentials. And I'll call this function right after we have received the CSRF cookie. and it should just work, right? Well, let's go to the browser and test it out. And it doesn't work. Oh dear, we've got a 419 error. It says that CSRF token mismatch. Well, here's the issue. Although this request has included the CSRF token in the request header under the field cookie, it will still not work in Laravel. The reason is because Laravel Sanctum expects us to put a CSRF token in a different field called XXSRF token in the request header. We did not do that and Laravel is not happy. Let me show you how we can achieve this. First of all, in our login method, we need to get the CSRF token from the cookie. Once we got that, we'll add the XXSRF token field inside the request header, and our job should be completed. And now the big question is, how do we get a cookie? The answer is simple. Just copy it from the internet. Here's a code snippet that I shamelessly copied from Stack Overflow, and it works great. It basically grabs all the cookies inside our browser and split the cookie string by the name of our target cookie. Each cookie key and value pair is separated by a semicolon. We call the pod method on a parts array to get the last element, which is the remaining of the cookie strings, and we split it up again using the semicolon to break out the remaining cookies. Then we call the shift method to get the first element of the splitted array, which is our target cookie value. Let's try this out. We'll call the getCookie function and console log out our CSRF token. Let's go to our browser, hit refresh, and it works. However, you'll notice that the cookie string is encoded. The %3d at the very end of the string is actually a special character. In order to send our CSRF token back to Laravel, we first need to convert this special character back to its original form. And it's actually quite simple to do that in JavaScript. We simply need to call the decode URI component function, and the magic will just happen. Let's go back to our browser and refresh, and the %3d is now converted back to equal sign. Great! And now let's put our CSRF token into our request. I'll add a new field in our headers, and the value is the decoded CSRF token. Let's give this a go. And now our login API request is working. Great! We've got a login function. We should also implement a logout function. And now every time we want to perform an API request, we always need to include the headers, the CSRF token, and also the credentials option in the fetch function, which will be quite tedious after a while. Let's extract all of this into a generic request function where we can reuse it to easily call an API request. I'll create a new function called request, which is basically a wrapper around our fetch function with built-in headers and the credentials option. Let's refactor our login function to use our newly created request function. And also create our logout function, which is just sending a post request to the logout endpoint. And now before we test our code, we should really log out first before we log in again. So I'll call the logout function first in a promise chain before we call the login function. Once we're done, let's go back to the browser and refresh the page. And there's no error. That means our code is working. Beautiful. Now to test if our authentication is working, we'll try to call one of the API endpoints protected by Laravel Sanctum's Auth middleware. Let's call the user's endpoint after we have logged in. And go back to our browser. And we can see our user's data is returning successfully, and it's all working. Okay, now back to our main question. What will happen if I did not include my front-end domain inside the stateful domain list? Let's remove the port number from localhost and back to our browser, hit refresh. And now we see a 401 error on our user endpoint. And this is exactly what will happen if we did not include our front-end domain in a stateful domain list. Laravel will not authenticate the request because the request did not come from an authorized domain. Alright, let's go back to our .env file and put a port number back to our localhost. There's one last thing that I want to talk about before we end the lesson. If your front end is living in a different subdomain than your backend, you might encounter CORS error. And Laravel makes it very easy to fix this. We just need to head to our CORS config file and change the paths array, depending on which URL that you want to enable CORS. Also, one important thing to note here is that we always want to set the support credentials option to true. Alright, that's pretty much everything you need to know on how to set up and use Laravel Sanctum in the backend and also the front end. If you need more information, feel free to visit the documentation. The link is in the description. Alright, key takeaway for this lesson. Sanctum offers cookie-based authentication and token-based authentication. Token-based authentication is simple to set up and use, but it can be dangerous when a token is stolen. Cookie-based authentication is harder to set up, but it will protect our app from CSRF and XSS attacks. Cookie-based authentication is sensitive to domain names, so be sure to configure Sanctum before use. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! Now that we have installed Laravel Sanctum and all of our API routes are now protected, we now encountered a new issue. So if we try to run our tests again, a lot of them are returning us an error. The reason is because when we write our API test, we did not log in as a user to call the API endpoints. Now that we have applied the Sanctum Auth middleware to all of our API routes, it is normal for our test to fail. So to fix this error, we should refactor our test code to log in as a user before calling these API endpoints. Let's do that. Let's first refactor our user API test. Now to log in as a user in our test, Laravel offers us a very simple to use method called acting as, which will receive a user model record as its argument, and that user can be any valid user in our app. I'll go ahead and create a dummy user using the factory method and pass the dummy user into the acting as method, and that should do the trick. Let's try our code. We'll go back to our terminal, and you notice that currently we have 15 failures. Let's run our test again. And boom, we've got 14 failures now. And these two lines of code is exactly what we need to apply to all of our API tests. And now the question is, should we really copy and paste this to all of the test functions? The answer is a big no-no, because we'll need to repeat ourselves for an awful lot of time. There is a better way to do this, and it is through the setup and teardown testing hooks. So Laravel provides us two special testing methods called setup and teardown. Setup is a special function that will run just before each of the test function is executed. And teardown, on the other hand, will run after each of the test function is executed. So in our case here, we want to log the user in before each of the test function is executed. So let's go ahead and create the setup function. And we do need to specify the return type, otherwise our IDE will complain. Inside the function body, I'll simply move our login logic from the test index method to here. And now this setup method should log a user in before we run all the test functions inside this user API test class. Let's go to our terminal and we'll run our test again. And we're down to 10 failures. Beautiful. Now the next thing that we want to do is to copy and paste this code to the other test classes as well. We'll paste it in our post API test and also comment API test. Let's go back to our terminal, run our test again, and we're down to one error. Seems like this error is not about authentication, but we have an invalid request body when we're creating a new post. Let's quickly fix that. Our post body should be an array, not a string. So we'll go to our post controller and change the data type from string to array. We also need to include an array of user IDs, so I'll go back to our test method and quickly create a dummy user. And I'll pass the user ID as part of the request body. Since body is a required field, we will also go to our post factory and put in some random value inside the body field. Let's go back to our terminal and run our test again. And it's now all green. Great! Now before we end the lesson, I want to show you how teardown looks like. As I mentioned just now, teardown will run after a task is executed. It is useful when we want to reset any side effects that we might have when we are running our test. For example, clearing out database records or deleting files that we might have created in the test. And just for demonstration, I'll dump a random string in our teardown method here. Let's go back to our terminal and run our test. And we see 5 hey yes inside our terminal, because we have 5 test functions in our user API test class, and Laravel runs teardowns for 5 times. Now before we end the lesson, there's one more thing about the acting as method. It can actually take in a second argument where we can specify which login guard that we want to use. By default, it is using the web guard, but we can change it to API guard or other guards that you define inside the auth config file. And just for recap, guards are ways that we can log our user into our app. You can define as many guards as you like inside the auth config file. But for most scenarios, the default works great as it is already, so you don't need to touch them at all. And that is pretty much it. Key takeaway for this lesson: Laravel provides us a convenient acting as method to log in as any given user. The setup method is a handy special function that runs before every test function. It's good for us to put in logic where we want to apply for every test function inside a test case. Tear down is the opposite of setup, and it runs after every test function. Acting as accepts a second argument where we can specify which auth guard that we want to use. We can add more auth guard in the auth configuration file if we wish to. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. Internationalization is the notion of providing different translation to the end users based on their locale preferences. A lot of time in the internet you'll see people referring to this as I18N. Why? Because there are 18 characters between I and N. There's another common term in the web, A11Y, which stands for accessibility. Again, because there are 11 characters between A and Y. But if you ask me, how did they come up with such weird abbreviation? I'll be honest with you, I have no idea. But I'll tell you one thing for sure, programmers are weird, and you are one of us. Anyway, enough talking. Laravel makes internationalization very easy for us. Now if you look at the resources folder, underneath it there's a folder called lang. And this is exactly the folder where we put all the translation files. And by default, as you can see here, Laravel has already put a EN folder, which stands for English, in here. And in the English folder, there are 4 built-in translation files already. Let's take a look at the auth translation file. And as you can see, it's a normal PHP file that has an array of messages that we want to display to our user in our app. So the idea of these translation files are simple. We will write our app messages in different keys. And in our app, if we want to display these messages, we simply need to reference them by using these keys. I'll show you how to reference these keys in just a minute. Practically speaking, every messages that we display to the user in our app should be a reference to one of these translation keys. So by the end of the development cycle, we should have a lot of these translation files. And to create a new locale in our app, we simply need to create a new folder in the lang directory and copy and paste all the translation files into the new language directory. And we'll pass all these files to a translator and get the translator to translate each key into the other language. Alright, now let's talk about how we can get all of these messages out from the translation files. I'll go to our web.php file to play around with the code. So there are basically 2 main ways for us to get translation keys. The first way is to use the lang facade and a get method on it. The get method accepts a key argument where we can use the dot notation to access the relevant translation key. I know the auth file contains the key called failed, so I'll just say auth.failed. So now in theory, if I dump the string here, I should get a message associated to the failed key in the auth translation file. And now if we go to our terminal and run php artisan serve, and we did see our translation message get dumped inside the terminal, while Laravel is trying to boot up the development server. By default, our app locale is in English. That's why we are seeing our English translation in our terminal now. You can change the default locale in our app configuration file. However, if for any reason you want to change the locale on demand, we can call the setLocale function on the lang facade and change it to another language. The language that we put in inside the function has to match the folder name that we put in inside the lang folder. So now if I change it to Spanish, the get function from the lang facade will attempt to read it from the ES folder in our lang directory. And now let's go back to our terminal and run php artisan serve again, and we see a Spanish translation. Now instead of using the get method on the lang facade, Laravel provides us a helper function to get translation keys. The helper function is simply a double underscores. And now if I try to use the double underscore to grab the password key and go back to our terminal, run php artisan serve again, and it still works. So the double underscore is really a short and quick way for us to get translation keys. And now if we go back to our auth translation file, you'll notice that in the throttle key, there is a placeholder called seconds. The placeholder allows us to dynamically insert data to replace the placeholder string. So to replace seconds into some numbers, what we need to do is to pass in a second argument to the get function or the double underscore function. The second argument is an array where it contains the mapping of the placeholder string against the actual value. Let's run a code. And as you can see, the translation has replaced the seconds placeholder into the numbers that we put in inside the double underscore function. Isn't that neat? Alright, let's move on. To get the current locale, we can use the app facade and call the current locale function. Let's give it a go. And we see en dump in the terminal. And now you might be asking, I thought we have set our language to be Spanish on line 33. Why is it showing en now? And you're right. The set locale function, called on the length facade, is only setting the locale on the facade level. If we want to set the locale on the application level, we should use the app facade instead. The app facade also provides us a set locale function that works exactly as its counterpart in the length facade. And now let's go back to our terminal and try again, and now we see es instead of en. Great! To check for a locale, we can call the isLocale function on the app facade. So if I pass in en, I would expect to get a false here. Let's go to our terminal and run our code, and we do get false. So far, so good. Other than using PHP files, Laravel also allows us to use JSON files to write our translation files. But the convention is a little bit different. If we want to use JSON, we only need one single file, in contrast to the PHP files where we split the translation into multiple files. I'll show you an example now. So if I want to create a JSON for Spanish, all I need to do is to create a es.json inside the length directory. Now the way we write translations inside a JSON file is different to the PHP files. We will map a whole sentence to a sentence, instead of just a single key to the translation. The translations provided in a JSON file is normally used as a fallback when Laravel couldn't find a corresponding translation from the PHP files. Okay, let's try out our JSON translation. So back inside web.php, if I attempt to translate "this is Sparta," and in our terminal, we see the Spanish translation that we put in inside the es.json file. Great! But now here's a big question. Which one should we use? Should we use JSON files or PHP files? And my answer is, it's up to you. Pick whichever that you think is easier for your project. However, Laravel's documentation did suggest that to use JSON if your app has a large number of translatable strings. Alright, let's move on. Let's talk about pluralization. You see, pluralization is a hard problem to solve. Each language has their own rules when it comes to making plural terms. So Laravel leaves this complicated task to the hands of the translator. That means if we have a translation, we should provide the singular form and also the plural form in the translation file. And now let's take a look at how this thing works. Let's go to the auth.php files and I'll create a new key called pens. For the singular form, I will say I have only one. And now to provide the plural form of this translation, we'll put in a pipe operator right after the singular translation. So the left side is singular and the right side is plural. Let's try this out. We'll go back to web.php. Since we're using English now, I'll change the locale back to en by commenting out the set locale function. And now to get a plural form of the translation, we can no longer use the get method or the double underscore function. Laravel provides us another helper function called transChoice to get the plural form of a translation. So the first argument is the key to the translation, which in our case will be auth.pens. And the second argument is the number of the item. Any number other than 1 will resolve to the plural form of this translation. So if I put in 1 for now, we would expect to get the singular form. Let's run our code, and we see I have only 1 in the terminal. And now if I change the number into anything other than 1 and go back to our terminal, and we see I have a lot of pens. And remember, by default, in order for us to get a plural form, we can put in any numbers other than 1. This includes 0 or negative numbers. I'll show you what I mean. So if I change the number to 0 and go back to our terminal, we still see I have a lot of pens. And now if I change it to a negative number, we still see I have a lot of pens. It doesn't make sense, right? So to solve this issue, Laravel allows us to write more complicated pluralization rules to fit for multiple ranges of values. Let me show you a quick example. So let's go back to the auth.php file and I'll add in a new key called apples. I want to have 3 different translation sets. When the number is less than or equal to 0, I will say there's none. When I only have 1 apple, I want to say there's only 1 apple. When I have more than 1 apple, I want to say I have many apples. So for the first set, I need a range. We can use a square bracket notation to define a range of number. So square bracket star, 0 means that for any numbers that is below 0, I want to say there is no apple. And same as before, I'll put in a pipe operator to define the next set. For the next rule, I want to have exactly one apple. So I put in a curly braces and put in a number 1 in it. And the translation is, there is one apple. And for the third set, the range is 2 and beyond. So square bracket 2, comma, star. And the translation string is, there are many apples. So far, so good. Let's try it. We'll go back to web.php and call the trans choice function again. The key is auth.apples. Let's start with negative numbers. So if I put in -1, I should see there's no apple. And in our terminal, we did see the string there is no apple. It is working. Let's try 0. And we get the same string again. What about 1? And we get there's one apple. Let's try 2. And we see there are many apples. Sometimes we do want to show the numbers inside our translation string. For example, I would like to show there are 2 apples instead of there are many apples. And Laravel makes this very easy for us. Let's go back to our translation file. And to show the numbers, we can use a special placeholder called count. So I'll replace the word many with count. And go back to our terminal, run our code again. And now we see there are 2 apples. Great! The third argument inside the trans choice function accepts an array of placeholder values, and it works exactly the same as the double underscore function and also the get function from the lang facade. Let's pass in a placeholder called baskets, and I'll give it a value of 2. And now let's go back to our translation file. I'll put in the basket placeholder at the very end of the string. Let's run our code, and we see there are 2 apples in 2 baskets. Alright, last thing before we end the lesson. Laravel also makes it very easy for us to capitalize the translation string. For example, if we have a welcome key in our translation file, that would greet the user. We normally want the username to be capitalized. Let's say I'm using the name placeholder as the username, so to make the first character capital case, all we need to do is to make the first letter of the placeholder capital case. And just for demonstration, if I want to make the whole word in uppercase, I'll put the placeholder in all caps. And similarly, if I want it to be in lowercase, the placeholder should be in all lowercase as well. Let's give this a run. Back to web.php, I'll use the double underscore function to get the welcome translation and pass in the name placeholder as Sam. And now let's go to our terminal and run our code. And we see Sam in 3 different casing. So far, all of the examples that I have shown you in this lesson are quite trivial and just for demonstration purposes only. In a real-world scenario, it should be roughly the same as what we have done so far. Just call the double underscore or trans choice function wherever appropriate in our Laravel app. For example, in the welcome blade file that we created in the previous lessons, instead of hard-coding the welcome message, we can use our translation string. So I'll replace the whole line with double underscore of welcome and then pass in the name variable to the name placeholder. You can do the same for the rest of the app, and I'll leave this as an exercise for you. In theory, you should use translation string for all the strings that we want to show to our end user. Okay, that's roughly everything you need to know about translation. Key takeaway for this lesson: internationalization, or I18N, is the notion of providing translation to different locale. Laravel provides us the double underscore function or the get function on the lang facade to retrieve translation from the language files that we have in our project. Laravel puts all the translation files inside the lang directory that lives inside the resources folder. We can choose to write our translation files in either PHP or JSON file format. Trans choice is another helper function for us to handle pluralization. That's it for now, and I'll see you again in the next video. Hey there, it's Sam. Sometimes in our application, we just want to share a link that will expire or just send a link to a certain group of people. These features can be very useful in apps that involves resource sharing, like a cloud drive or a video sharing platform or even a private chat room. And now the big question is, how are we supposed to generate this link in Laravel? The answer is simple. Thankfully, Laravel provided us a nice to use API to generate this type of links. Let's take a look at the code right now. Let's say we are running a video sharing platform like YouTube, and we want a feature that will let our user to only share their videos with their friends and family, but not everyone in the world. Okay, first of all, let's create a fictional URL that will serve the video that the user wants to share. I'll create a get route and call it shared video and the video ID. And just for demonstration, I'll simply return the word getGood, just to motivate you. And now let's go to Postman to test this route, just to make sure that it works. And we see the word getGood as expected. And now I want to protect this route so that only people with the special link can access this route. To do that, we can use the source code sign URL to achieve this. In programming, signing means to protect a certain things from future tampering. If we are signing a route, that means if anyone attempted to change a part of the route will no longer work, and the server should refuse to accept the incoming HTTP request. If you're confused at this point, don't worry, we'll explore on how this works in the next few minutes. So to create a sign route in Laravel, we'll need the help of the URL facade. Laravel provided us two variants to sign a route. One is with an expiration time, which is useful to create a temporary link. The other one is just to call the sign route function, and that is helpful to create a permanent protected route. I'll go ahead and call the temporary sign route function in this demo. Now the first argument in this function is asking for a route name, which is a reference to an existing route in our app. In our case here, we want to turn our share video route here into a protected route. So let's give our route here a name. I'll call it share video. And then I'll go ahead and pass the name share video into our sign route function. The second argument is the expiration time, which is the timestamp that this route would expire. And just for demonstration, I'll only let this route to live for 30 seconds. Otherwise, this video will be a few hours long just for me to show you what will happen when the link is expired. Once we have added the expiration time, we can simply return a URL and we'll go to Postman and call our playground endpoint to see how this thing looks like. And whoops, I made a mistake here. We see an error. And if we look at the error message, it's saying that we're missing a required parameter for our share video route. Our share video route accepts a video URL parameter, so that means when we create our sign route, we should also pass in a third argument that will supply the value for the video parameter. Let's go back to Postman and try again. And this time it works. And we can see inside the response body, we see a sign URL. It is a URL pointing to the shared video endpoint, but it also contains two query parameters, expires and signature. Expire is the timestamp that this URL will expire, and signature is a unique hash that will stop people from tampering with this URL. It is the main mechanism that will protect our route from modification. Let's explore how this thing works on a deeper level. So now when someone attempted to visit a signed URL, we need some sort of logic to verify the route signature. And there are two ways to do this. One is through a helper function on the request object, which is called has valid signature. Two is to use the sign middleware provided by Laravel out of the box. So to use the helper function on the request object, we simply need an if statement to check if the request has a valid signature or not. If not, we'll abort the request with a 401 error code. Alright, let's give this bad boy a go. We'll go back to Postman. We will send a GET request to the playground endpoint again to get a new signed URL. And I'll copy the signed URL and send a GET request to it. And we get getGood in the response body, which is expected because we're still within the 30 seconds limit. And now if I attempt to change the signature hash to something else, this URL is no longer working. And we see a 401 response code because we no longer have a valid signature in our URL. And if I change the signature back to the original, we still get a 401 error because we have passed the 30 seconds time limit and the URL is now expired. Let's try again. We'll get a new sign route, and this time I'll try to be cheeky and attempt to see some other videos other than the one that is currently shared to me. I'll change the video ID from 123 to 122 and hit enter, and we see a 401 error. That means we cannot view the video. Change it back to 123 and we see getGood again. Can you see how the signed URL is protecting the route? We can only see the resources that was signed originally, and if we attempt to change any part of the URL, Laravel will simply not let us to pass.
You shall not pass!
So that was signed route by using the helper function on the request object. We can also apply the built-in middleware called sign to do the signature check. I recommend to use the middleware rather than the if statement because our code will be cleaner. Let's go back to Postman again. We'll get a new URL and attempt to visit video 122 again. And this time, the middleware is sending us back a 403 error with the message invalid signature. And that is all working. And now the big question is, how does this thing work behind the scene? To answer this question, we need to look at the source code. First of all, let's visit our HTTP kernel file. And if we look at our route middleware mapping, we can see that the sign middleware is mapped to a middleware called validate signature. And in the handle method of the middleware is really a wrapper around calling the hasValid signature function on the request object. And now if we follow through the function definition, we find ourselves inside the request class. And seems like this hasValid signature function is a magic function living elsewhere. And that means we can't see its implementation inside the request class. What should we do? That's okay, we can do a global search. We will need to search not only in our project, but also from the Laravel source folder. And looks like I have found it. It is a macro where the definition is living inside one of the Laravel's built-in service provider. We haven't talked about macro in this series before. It is one of the Laravel's feature that allows you to add functions to a class on demand. Personally, I'm not a big fan because it seems a little bit magical to me. And if you use too much of it, it'll be very hard for you to debug your code. Anyway, in here, Laravel has added the hasValid signature function to the request class, and it is simply a wrapper around the hasValid signature function on the URL facade. The URL facade is based on the URL generator class. Let's try to look for the hasValid signature function inside the URL generator class. And we have found it. The function is calling two methods in it. One to confirm whether the request has a correct signature, and the other one is to make sure the signature has not expired. Let's look at the first function for now. And here we are, we have some scary code in front of us. What's going on here? So the first line is to get the whole URL, and the second line is to remove the signature query parameter from the URL. So we get everything else, including the expiration timestamp, and store it to the query string variable. The next line is simply hashing the query string using the SHA-256 algorithm to recalculate the signature. Laravel is using the app's encryption key here as the salt of the hashing function, so we can guarantee that the signature is going to be unique. And lastly, we'll compare the calculated signature against the signature from the request query. So if someone tampered with the URL, there's no way that a person can make the hashes equal, unless the hacker is extremely lucky or they're using a supercomputer to brute force the hash. Because if the hacker changes any character in a URL, the hacker will also need to calculate the hash of the new URL that they created. And to calculate the hash, the hacker will need a salt of the algorithm, which is a long-ass string living inside the environmental variable in the server. Under normal circumstances, the server should be very secure, and it's very hard for the hacker to gain access to the environmental variable. And that makes SignRoute in Laravel to have a 5-star rated security level. Alright, that's basically how SignRoute works in Laravel, and now I want a feature in our app that will let our user to share a post privately. Let's go back to web.php, and just for demonstration, I'll create a new route to share a post. And apply the sign middleware on it. And we'll return some text in the response. In the actual app, this route should render the view to display the post, or the API JSON that contains the body of the post. And to share the post, we need a new endpoint to create the signed route. Let's add a new route to our post endpoints. I'll define a new post route in our post route definition file. And this endpoint should trigger a function in a post controller. I'll call it share. Once we're done, let's go to our post controller and create this new function. Within the function body, we'll need to generate the URL. So we'll call the URL facade and call the temporary sign route function. The name of the route will be the get route that I just created a minute ago. That will send back the body of the post that we want to share. And I'll keep this link alive for 30 days. And for the URL parameter, I'll simply set post to the post that the author wanted to share. Once we got the URL, we should send it back as a JSON response. Last but not least, we should also set the documentation for our share function. And now to test our share endpoint in Postman, I'll temporarily disable the Auth middleware. because the share route is protected by Sanctum and Fortify, and I'm too lazy to log in and set the CSRF token in Postman. Alright, let's go to Postman, and I'll send a post request to our share post endpoint. And we get a JSON response with the signed URL. Let's click on it, and in our browser, we see the post that is specially made just for you. Alright, key takeaway for this lesson. We can use signed routes to protect our routes from unwanted modification. This is extremely useful for apps that shares protected resources like videos or files. We use the temporary signed routes function in a URL facade to create a link with expiration, while the signed route function to create a permanent protected link. Laravel uses sorted SHA-256 algorithm to hash the route as a measure to counter modification in assigned routes. That's it for now, and I'll see you again in the next video. Hey there, Sam! Notification exists everywhere in today's web app. If you're using a social media like Facebook or Instagram, whenever someone commented on your post or give your post a like, you would have received a notification in some ways, either through the bell icon in the app or through an email that was sent directly to your inbox. Laravel makes it easy for you to send notification to your users in the form of email, in-app notification, SMS, or even Slack. And now let's dive into the code right away. To get started with notification in Laravel, we first need to create a notification class. And to do that, we can make use of the artisan command. So let's go to our terminal, and we'll type in php artisan make notification and type in the notification name. I want to send our users a notification after they have shared their post, so I'll call it post shared notification. And now let's go back to our project directory, and inside the app folder, you'll notice that Laravel has just created a new folder called notification, and inside it is our newly created post shared notification. Let's click on it, and it turns out that it's just a normal PHP class that extends the base notification class. Let's look at what's inside here. We have a queuable trait, a constructor, a via method, a toMail method, and a toArray method. It looks a bit scary, but it's okay. We'll go through them one by one. First of all, let's talk about the queuable trait. So Laravel allows us to send out notification asynchronously. That means to send out a notification at a later time, rather than immediately. You see, sending out notification is an expensive process. It is not something that can be done within a few milliseconds, especially when we want to send out a notification in the form of an email. It will take up to a few seconds for the process to complete. So if we send out our notification synchronously, it might cause a blocking in our script, and our app will not have a good user experience because our user has to wait for a few seconds before moving on. It's much better to perform this time-consuming task at a later time where the server is not that busy, or to delegate this task to an entirely new PHP worker. And that's exactly what queuing means. Queuing is rather difficult to implement, but thankfully Laravel provided us this helper trait called queuable, where it contains all the helper methods for queuing to work. In order for queuing to work, it's not as simple as loading the queuable trait. We also need to implement the shouldQueue interface on our notification class and also set up a queue driver for our app. Queuing deserves its own video series, and we'll discuss more about it in the future. Okay, next we have the via method, and this is where we define the delivery channels that we want to send out this notification. Laravel provided us a few delivery channels out of the box, including mail, database, broadcast, Vonage, and Slack. The mail channel will send out an email to the user. The database channel would log the notification inside our local database, and the user will be able to view the notification in the front end. The broadcast channel will send out notification to our JavaScript front end in real time through Websockets. We'll dive deeper into Websockets in Laravel in the next few videos. Vonage is a web service that will send out SMS messages to our users. And Slack is the popular messaging platform for workspaces. There are other notification drivers like Discord, Telegram, or Microsoft Teams that are actively maintained by Laravel's community. The link is in the description if you're interested. In this lesson, I'll be using the mail driver for demonstration. The via method also accepts a notifiable instance, which will be the user that will be sending out this notification to. The toMail method should return a mail instance class, which is a representation of the email that will be sent out if we're using the mail driver. And here in the starter code, Laravel is using a mail message class instance to quickly build a one-off email. We could create our own mail class and load it in here. And again, the toMail class accepts a notifiable instance where we can use it inside the mail body if we want. The toArray method is used when we're using the database or broadcast driver. Whatever is returned in this method will be used as a payload to store inside the database as a JSON or as the broadcast WebSocket body. Since we are not using the database driver or the broadcast driver, we do not need to touch this method. Again, if you want to learn more about the database driver, feel free to visit the documentation. Okay, now let's edit our toMail function so it is more useful to our user. I'll add a subject where I'll say post shared, and I would like to include the post title here. Let's make our notification class accept the post that we want to share and also the associated signed link. And I'll make these two arguments a private property inside this class. Now back inside our toMail function, I can now pass in our post title to the subject line. I'll keep our mail message simple. So in the mail body, I'll just put in a button and say view the post here and chuck the signed link in there. And that should do the trick. And now let's explore on how we can send out a notification in Laravel. Let's go to the share post controller function that we created in the last video. There are two ways to send out a notification in Laravel. One is to use the notification facade. Two is to call the notify function on the user instance. But before we go any further, we first need to make our user model notifiable by putting in the notifiable trait inside our user model, which should just be there by default. If you don't see the notifiable trait on your user model, make sure to load it, otherwise notification will not work on our user model. You can make any of your other model notifiable by simply putting in this trait. Alright, let's go back to our share method. And now let's use the notification facade to send the notification to our user. The send function accepts two arguments. The first argument is an array of user models. We don't have any users here inside this function scope, so let's do a query on our user model. I'll assume that our request body contains an array of user IDs where there are the users that we want to share this notification to. To get an array of users based from these user IDs, we'll go ahead and call the wherein method on the user query. That will retrieve all the user records based on the provided user IDs from the request. Once we got our users, we can simply pass it to the send function in the notification facade. The second argument will be an instance of a notification, which in our case here will be our post shared notification. The first argument in the constructor will be a post instance, and the second argument will be the signed URL. And that's it, we're done. Let's test our code. I'll disable the authentication middleware again in our API endpoint because I'm too lazy to log in and configure the cookies in my HTTP client. Alright, let's test our endpoint. I'm using Insomnia, which is another HTTP client, because for some reason, Postman refused to work in my computer today. Anyway, I'm sending a post request to the share post endpoint here, and I want to share post ID 1 to user ID 2 and 3 in a JSON body. Let's send a request. And as you can see, it's taking quite a few seconds to send out the notifications because we're using the mail driver. In the actual app, we should be using queue to send out the notifications. Alright, let's go to mailtrap.io and we see two notifications sent out by our app, and each of them is targeting a different recipient. And one last thing before we end the lesson, we can also call the notify function on a user model instance to send out a notification. This was the second way to send out a notification that I mentioned just now. It will work exactly as the send function on the notification facade, just that now we're sending the notification on a per model basis. Personally, I like to use the notification facade because I think the API is cleaner. And that's it. That's the basic on how you can send out notification via emails in Laravel. As I mentioned earlier, there are other ways for you to send out notifications. Please visit the documentation if you want to find out more. If you want me to make a video on the other notification drivers, do let me know in the comments below. Alright, key takeaways for this lesson. Laravel provides us a variety of drivers to send out notifications to our user. For example, the mail, database, broadcast, Slack, and Vonage drivers. There are many more community-maintained drivers like Telegram, Discord, and etc. We can use the PHP Artisan make notification command to generate the boilerplate to create a new notification class. We can use the send function on the notification facade or the notify function on a notifiable instance to send out notifications. That's it for now, and I'll see you again in the next video. Hey there, Sam! You see, a lot of web apps today have some sort of real-time features integrated with them. For example, when you're chatting with someone in a messaging app, you can see whether they're typing or not, or whether they're online or not. Or even when you're using a collaborative app like Google Docs, you could see the cursor positions of your peers and the text they have added to the document in real time. And now the big question is, what is the voodoo magic that powers these real-time features? Well, to answer this question, let's first consider our options. We could get this to work using HTTP. Let's use a chat app as an example. Let's say we have a person A here, and another person B on the right, and our app server sitting in the middle. Now A wants to send a message to B. So A go ahead and type in something in the Messenger app, and now practically speaking, on B's screen, B should see the status of A as typing. And now one of the many ways to get this to work in HTTP is for A to send a request to the server that would update the state of the current conversation record between A and B in the database. And now in order for B to get the latest status update of the current conversation, B needs to send in a HTTP request to the server once every few seconds to get the latest update on a conversation. Otherwise, there's no other way for B to check if A is typing or not. This method used by B is called polling, and it is far from being efficient. Why? Well, because HTTP is rather slow for real-time communication. Depending on the location of the app server and also the associated logic in the API endpoint, a HTTP request could take up to a few hundred milliseconds or even a few seconds in some cases. This delay is certainly not suitable for a real-time app. Secondly, HTTP request is rather heavy. Every HTTP request contains a header and also a body. And other than a request body, the HTTP request also contains cookies and also other metadata about the request. And the same goes with the HTTP response sent back by the server. In a real-time app, there'll be a lot of messages coming back and forth between the client and also the server. If we're using HTTP to facilitate the real-time communication, someone's gotta pay for the bandwidth overhead associated with these HTTP requests. And trust me, it won't be cheap. So what's a better solution then to create a real-time app in contrast to HTTP? And this is exactly where Websockets comes into the picture. We needed something that's fast, that's lightweight, and supported by the browser. And WebSocket ticks all of these boxes. But before we go on any further, let's first understand what is WebSocket. Well, WebSocket is another way for computers to talk to each other. And just like HTTP, we can use WebSocket to send and receive data from a web server. However, the main difference between WebSocket and HTTP is that in WebSocket, the connection between a client and a server is persisted and maintained, while in HTTP, the connection ends as soon as the server sends back a HTTP response. Now, the persisted connection in WebSocket gives it a huge advantage in building a real-time app. Because now, if the client or the server wants to send each other a message, they don't need to start a new connection, but instead they can just send the message through the existing connection. There is no need to re-establish the connection and go through the authentication processes again. We only need to do it for one time when we first establish the connection. And that is the reason on why WebSocket is much faster than HTTP when transmitting messages. Now, there are two common patterns when building app with WebSockets. The first one is what we call the pub-sub pattern or publisher-subscriber pattern. In a pub-sub pattern, there's always one publisher and a lot of subscribers. The server is usually the publisher, and there'll be a lot of clients subscribed to this publisher. When the server wants to send out or publish a message, the message will be sent out to all of the subscribers. This is a one-way communication method where the server can only send out data and the client can only receive. You can see the pub-sub patterns in a lot of financial apps where they are streaming real-time financial data on a price chart or a candlestick chart. The pub-sub pattern can also be used to stream live video data, where all the clients will receive streaming data from the camera on the server. So if you want to build a video streaming platform like Twitch.tv or a monitoring service like a CCTV system for your home, you might want to consider pub-sub when designing your app. The second common pattern is something called RPC, which stands for Remote Procedure Call. In contrast to the pub-sub pattern, which can only send data in one way, RPC is a two-way communication protocol, and it is very similar to HTTP. except the fact that we're using WebSocket and a connection between the client and server is maintained. So here's how it works. First of all, the client will establish a connection with the server. Once the connection is opened and persisted, the client will send a request through the connection to the server. The server will receive the request and process the request by running some logic on the server side and send back a reply to the client. This is very much similar to HTTP request and response, where the client and server are exchanging data. The request in RPC could contain a body, where it contains all the data needed by the server to run the process on the server side. And similarly, the reply sent back by the server could also contain a body to be used by the client later on. Once the client receives a reply, the client could go ahead and read the body of the reply and proceed to do some other processing. And if needed, the client could send another request to the server through the WebSocket connection. And the process repeats itself. And by looking at how RPC works, we can kind of understand why is it called remote procedural code. Procedure is another name for functions. And here we're really executing a remote functions on the server by sending out a request to the server. And the server will go ahead and send back the result of the function in the form of reply. And as I mentioned just now, RPC is a two-way communication protocol. The client can send data to the server through request, and the server can send back data through reply. However, due to the nature of RPC, the data transmitted in this WebSocket connection can only happen with one client only, in contrast to PubSub, where the data is sent out to multiple clients at the same time. A typical application that uses RPC is a chat messaging app. In fact, in a chat app, it could be a combination of RPC and PubSub working together. Here's one of the many strategies that you could use to build a chat app. Let's say we are in a chat group. There's one server and 4 users. Now Alice wants to send a message to her friends. What Alice could do is to make an RPC connection to the server and send a request to ask the server to record her message in a chat group. Once the server has saved the message, the server would then broadcast the message to everyone else in the room using the PubSub pattern. If someone else in the room wanted to send a message to the group, then they'll make another RPC connection to the server and the process repeats. Isn't that neat? Using WebSockets in your app in the right place could really make your app runs faster than Usain Bolt. But it doesn't mean that you should use WebSocket for everything from now on. WebSocket has its own overhead and it could be quite complicated to set up a proper WebSocket server. Regardless, WebSocket is a promising technology that can really improve your user experience by bringing in real-time features to your web app. Alright, key takeaways for this lesson. WebSocket is a communication protocol to transmit data between computers, where it's commonly used in real-time applications. In contrast to HTTP, WebSocket persists and maintains its connection with the server, so the subsequent data transmission between the server and the client will be lightning fast. And that makes WebSocket an ideal candidate to transmit data in a real-time application. There are 2 common WebSocket app patterns, PubSub and RPC, which stands for Publisher Subscriber and Remote Procedural Code, respectively. PubSub involves one server that broadcasts messages to multiple clients. It is commonly seen in financial apps where there's a need to stream real-time price data. RPC is very similar to HTTP, where the client will send a request and expect a reply from the server. RPC can be used in messaging app. That's it for now, and I'll see you again in the next video. Hey there, it's Sam. Laravel makes it quite easy for us to create real-time app. It has built-in support for PubSub pattern for WebSocket. And just a quick recap, the PubSub pattern is where there's one WebSocket server publishing data to multiple clients. So, in order for the PubSub pattern to work, we need to configure a WebSocket server in our Laravel app. And thankfully, we didn't need to start from scratch. Laravel provided us a few options for our WebSocket server. The first option is to use something called Pusher as our WebSocket server. Pusher is essentially a subscription-based web service that will provide us our WebSocket server once we sign up with them. It is very easy to use and Laravel is fully integrated with it. We just need to write the configuration in a few lines of code and that's it. Our WebSocket server will be up and running since day 1. But the only thing is we need to pay them for every single month. They do provide us a free plan, but with limitations. Now the second option is another web service called Ably. Ably is a competitor of Pusher and it is also a subscription-based WebSocket server. They offered a very similar pricing compared to Pusher and also fully integrated with Laravel. But if you're like me, who has no money to pay for these services and my coffee, we might want to consider some open source options where we have full control and no limitations. Alright, the first open source alternative is Laravel Websockets. This is a WebSocket server written in PHP, provided by Beyond Code and Sparty, two of the biggest open source contributors in Laravel's community. Laravel WebSocket is available as a composer package and it fits in perfectly in our app. There are two other open source options, Laravel Echo Server and Sockety. However, they are written in Node, so you'll need to install Node.js before using them. The other thing about Node is that we couldn't run PHP code in these two packages. That means we can't extend and modify those two packages at the time when we need it. So these two options might be less appealing compared to Laravel WebSocket. Our final decision is very clear, we'll be using Laravel Websocket. Now for the client, Laravel provided us an official package called Laravel Echo, which is a JavaScript npm package meant to be run on all the WebSocket subscribers. We will discuss more about Echo in the next few videos. For now, we'll be focusing on the server side. Alright, let's dive into the code and get started right away. There is quite a bit of configuration that we needed to do to get our WebSocket server up and running. Alright, first of all, let's install Laravel Websocket. We'll go to our terminal and type in composer require Beyond Code Laravel Websocket. The installation node is in the package documentation. The link is in the description. Once we have installed the package, we'll need to publish its configuration. So we'll go ahead and type in php artisan vendor publish and look for Laravel Websocket in the list. Seems like number 2 is the one. Let's type in number 2. And there you go. We have just copied the migration files and the configuration files to our app. And then we'll run php artisan migrate to create all the tables needed by Laravel Websocket. Alright, now let's take a look at the package config file. The first option here allows us to set a port to the package dashboard. The package does provide us a debugging dashboard out of the box for us to see any incoming and outgoing WebSocket connections. Don't worry about it for now, I'll be showing you around later on. The next option here is for us to set our app's information that we want to connect with this WebSocket server. Some people might want to set up a WebSocket server for multiple apps in one go, and this is a place for you to define all the informations about your apps. And this is referred to as the source code multi-tenancy architecture. And the next option, app provider, is simply a helper class for us to resolve the correct app for our tenants. You can pass in your custom provider class if you have a much more complicated logic. Allowed origins is where we define all the addresses that we were allowed to connect to our WebSocket server. Any addresses that's not listed here will be banned from connecting to the WebSocket server. Max request size is the size of the payload that's allowed to contain in a WebSocket request. Path is the URI to visit the WebSocket dashboard that I mentioned just now. The middleware listed in the middleware array will be applied to every request visiting the dashboard. The statistics section is where you configure on how we want the package to collect data. Each of the fields listed here has its own documentation in this file. You can have a read if you want to customize the logic. The SSL section is where we put in the configuration if we want to get our WebSocket server to use SSL certificate. You will need this when you want to encrypt the messages transmitted by your WebSocket server. And lastly, we have a channel manager option, and this will be the class that contains the logic to maintain all the WebSocket connections on this server. By default, Laravel Websocket stores all the connections in a PHP array. If you want to store the WebSocket connection details in somewhere else, like in a MySQL database, then you'll need to write your own manager class. Now, Laravel Websocket is used as a pusher replacement, and that means we can still pretend that we're still using pusher. And we need to install all the dependencies required by pusher, in particular, the pusher PHP server. So in our terminal, I'll type in composer require pusher PHP server. Once that's installed, we'll go ahead and configure our environment variable for the package to work. Let's go to our .env file, and we'll go ahead and change our broadcast driver to pusher. And we'll pass some dummy values to the pusher app ID and pusher app key and secret environmental variables. If you're using pusher, these will be your API keys and secrets for authentication. Since Laravel WebSocket is a drop-in replacement for Pusher, we are not using these values for authentication. Instead, Laravel WebSocket will use these values in its configuration to identify the app tenancy, just in case there are multiple apps connecting to the same WebSocket server at the same time. Okay, let's move on. Next, we'll need to set up a queue driver. As I mentioned before, Laravel is implementing the pub sub pattern, and the whole real-time architecture is driven by event. The very same event that we have in our app folder. Whenever there's a new event fired in our app, we could choose to whether broadcast this event or not. If we choose to broadcast the event, Laravel will then send the event to the WebSocket server, and the WebSocket server will broadcast the event to its client. However, the process of sending the event to the WebSocket server is rather time-consuming. It is much more efficient to do the job later. So what we can do is to send this job to a queue system, and we'll process the queue later on when the server is less busy. And that is how Laravel handles event broadcasting in a real-time app. Laravel provided us a few queue drivers out of the box. Typically, we would use Redis as the queue driver, but just for demonstration, I'll be using the sync driver for now. The sync driver, as its name suggests, will process the job synchronously, so there's no queue system at all. If we are using the sync driver, Laravel will send the job to the WebSocket server directly without listing them in a queue. Anyway, to set up the queue driver, we will go back to the .env file and set the queue connection key to sync, which should be the default value out of the box. You can take a look at the other possible drivers in the queue configuration file. There are other queue drivers like database, beanstalk, and Amazon SQS on our disposal. And now once we have set up our queue driver, we need to go to our app configuration file and enable our broadcast service provider. Otherwise, we'll not be able to broadcast our event through WebSocket. Alright, now we're ready to see if our WebSocket server is ready to run or not. We'll go to our terminal. Laravel WebSocket actually provided us a nice PHP Artisan command to start our WebSocket server. If you type in PHP Artisan, you can actually see that we have a few new commands. Let's type in PHP Artisan WebSockets serve to start a WebSocket server, and we'll visit the WebSocket debugging dashboard to test if our bad boy is running or not. So let's go to our browser and visit the URL as defined in the WebSocket configuration file, which by default will be Laravel Websocket. And you should see a web page similar to this. Let's click on the connect button, and if you're able to see this dashboard, that means you have set up everything correctly. If not, seek help. It's a good time to stop here. We'll continue in the next lesson. Alright, key takeaways for this lesson. Pusher, Ably, Laravel WebSockets, Sockety, and Laravel Echo Server are WebSocket servers that are supported by Laravel. Laravel WebSockets is a wonderful open source drop-in replacement for Pusher. Laravel uses the pub/sub WebSocket pattern to publish real-time app events. We need to set up a queue driver for Laravel to broadcast WebSocket events. The broadcast service provider should be enabled in the app config, otherwise Laravel cannot broadcast real-time WebSocket events. Laravel WebSockets exposed a debugging dashboard for our WebSocket connections. That's it for now, and I'll see you again in the next video. Hey there, it's Sam. In the previous lesson, I mentioned that every app event is broadcastable to the WebSocket clients. Let's discuss further on this topic. In short, when we want to broadcast our app event, Laravel requires us to broadcast these events through something called channels. There are three types of channels in Laravel: the public channel, presence channel, and private channels. When WebSocket clients want to connect to our server, they'll need to subscribe through one of these channels provided by the WebSocket server. Here's how they work. A public channel does not need authentication, and anyone in the world can connect to this channel. Presence channel and private channel requires authorization, and the difference between presence and private is that a presence channel is aware of all the users that are currently connected to the channel. In other words, all the users in the presence channel can see the information of each other. This is perfect for chat room application where the users know who is online, who is offline, who posted this message and that message, so on and so forth. A presence channel is useful when the identity of the user connected to this channel is important to the application. Private channel, on the other hand, is for situations where we don't want the users to know each other, and we simply only want authorized user to connect to this channel. We can use private channel for general purposes, For example, getting all the login users to connect to the same private channel in our app so that we can easily broadcast notification to all of our users. We don't need each user to know each other, so in this case, a private channel will be perfect. Alright, now let's look at how we can broadcast Laravel app events and define broadcast channels. The first thing that we need to do is to go to our app config file and uncomment the broadcast service provider under the application service provider section. The broadcast service provider here is different to the one provided by the core framework listed up here. The purpose of the core broadcast service provider is to set up the necessary code for broadcasting to work in Laravel, while the one down here is for us to set up our app broadcast service logic, like defining the channel authentication routes, setting up the middlewares, and so on. And now if we look inside the service provider, we can see that it is a very simple service provider class containing only 2 lines of code. The routes function from the broadcast facade will register the authentication routes for presence and private channels to work. And line 19 here will register the authentication routes for private and presence channels that we define inside the channels.php file, leaving inside the routes folder. Let's take a look inside it. And as you can see here, this file is pretty similar to the other routes file that we have in our app. But instead of using the route facade, we're using the broadcast facade here. And we're defining a channel this time, not a route endpoint. The syntax is pretty similar to its route counterpart. So the first argument is the channel name, and the second argument is a callback function that will determine whether the current authenticated user can subscribe to a given channel or not. The first argument in the callback function is the instance of the current login user, and any subsequent argument represents the value of the placeholders in the channel name. So in the sample snippet here, it is representing the ID placeholder in the channel name. For a private channel, we'll need to return a condition, and if the condition is true, that means the current authenticated user will be able to subscribe to this channel. In a presence channel, however, in order for us to authenticate a user, we need to return the user information in the callback function, rather than just returning a boolean. We will discuss more about this in the next video, where we'll look at how to connect our front end to the back end. But here is a simplified overview on how WebSocket authentication works in Laravel. So here's the client, and here's the server. When a client wants to subscribe to a private or presence channel, the client will first send a HTTP request to the server that is directed to the auth endpoint in Laravel, which is by default /broadcasting/auth. Upon receiving the HTTP request, Laravel will then trigger the callback function as we define in the channel.php file. If the callback function returns a truthy result, then the server will return a success response back to the client with the appropriate metadata for the client to establish a successful WebSocket connection with the server in a subsequent request. The data in a HTTP response is mandatory to make this WebSocket connection. Now, if the callback function that we define in the channel.php file is returning a falsy result, then the server will return a unsuccessful response, and therefore the client cannot establish a WebSocket connection with the server. This initial HTTP request and response is what we call as handshake. Okay, now let's look at how we can set up our event classes to get Laravel to broadcast them to the WebSocket clients. And just for demonstration, I'll be creating a dummy event class. Let's go to our terminal and type in PHP Addison make event, and I'll call it playground event. And now let's go to our newly created event class, and the first thing that we need to do in order to make this class broadcastable is to make it implement the should broadcast interface. Laravel will automatically broadcast any event classes that implements the should broadcast interface. And now if we scroll down a little bit more, we can see that there's a function called broadcast on. This is a function where we define which WebSocket channel that we want to broadcast this event on. And by default, Laravel has made this event to broadcast on a private channel. And now just for demonstration, I'll change it to a public channel instead, which will just be the channel class instead of the private channel class. Now the first argument in the channel constructor is the name of the channel. Now our app could have multiple WebSocket channels, so it's a good idea to have some sort of naming conventions, otherwise our channel names could go out of hand very quickly. Personally, I like to name my channel in this way. First, I'll start with the channel type. In our case here, we are broadcasting on a public channel, so it'll be public. Followed by a dot, the second part will be the resource name, and most of the time it'll be a model name. In our case here, since we're creating a dummy class, so I'll call it playground. You can put as many parts as you want, but for the final part, I always like to use it as the channel number or the channel ID. I'll hard-code it as 1 for now. Channel numbers or channel ID is great to manage WebSocket events. For example, if someone is working on post number 1, you wouldn't want events from post number 2 to affect post number 1, do you? That's gonna cause chaos and never gonna lead to a happy ending. Alright, let's test if our event is working. We first need a way to send out this event, so I'll go to the web.php file, and in the playground dummy endpoint, I'll fire an instance of the playground event. And now we'll go to our terminal and start our WebSocket server by typing in php artisan websockets serve. Once we're done, let's go to our browser and visit the debugging dashboard provided by Laravel Websockets. Let's click on the connect button and you should see some events pops up in the event list. And if we go back to our terminal, you should also see some debugging messages inside the terminal. Okay, now we'll attempt to call the playground endpoint to fire an instance of the playground event. Let's click on the send button. Oh no, we see an error. It says pusher error, auth key should be a valid app key. Now in the last lesson, I mentioned that Laravel WebSocket is a pusher drop-in replacement. We will need to configure Laravel to use Laravel WebSocket as the WebSocket server rather than using pusher. To do that, we need to go to the broadcasting config, and in the pusher driver, we'll add in a few more options. By putting in the host and port, we can define our own custom WebSocket server address. And since we're not using any SSL certificate, we should set use TLS and encrypted to false. Okay, now let's go back to Postman and try again. And we see a 200 response. Fantastic! Let's go back to the browser and look at the debugging dashboard. And we see a new event popped up in an event list, which is our playground event. And if we go to our terminal, we can see that our event is logged in a console with the event name and the channel name. And as you can see here, the default event name is the fully qualified PHP class name of our playground event. And here's a question. What if I want to use my own custom event name? The answer is super simple. We just need to define another function in our event class. And the function name is called broadcast_s. And we should return the custom function name that we want. I'll call it playground for now. Let's test our code. We'll go back to Postman and set another request. And back in our browser, we can see there's a new event popping up, and now with a custom event name called playground. Great! We can also attach information inside the broadcasted event, where the data attached in the event can be used by the front end. To do that, we'll need to go back to the event class and define a new method called broadcastWith. And whatever we return in this function will be attached as part of the event payload. So here, I'm just gonna return a simple dummy array, and we'll go back to Postman and try to send another request. And now if we go to our terminal, we can see that the latest event contains a payload in the data field, and it is exactly the same as what we put in inside the broadcastWith function. Isn't that neat? So that's a basic intro on broadcasting in Laravel and how to broadcast an event. We'll discuss further in the next lesson about the front end, private channel, and presence channel. I'll see you there. Key takeaways for this lesson. If a WebSocket client wants to subscribe to a WebSocket channel in Laravel, the client will first need to perform a HTTP handshake, in other words, to authenticate the user before establishing a persistent WebSocket connection. Event classes will need to implement the shouldBroadcast interface before Laravel can broadcast them to the WebSocket. We'll need to configure the host and port of the pusher driver in broadcasting.php config file to get Laravel to use our self-hosted Laravel WebSocket server. Otherwise, Laravel will attempt to use pusher out of the box. By default, Laravel will use the event fully qualified class name as the event name. If we want to use our own custom event name, we need to define the broadcast_as function inside the class. We can attach data inside the event payload by defining a broadcastWith functions inside the event class. That's it for now, and I'll see you again in the next video. Hey there, Sam. Let's learn how we can subscribe to a WebSocket channel on the front-end JavaScript. Thankfully, Laravel has provided us a client library called Laravel Echo that takes care of all the hard work for us, so we can easily subscribe to our channel and listen to events. So first thing first, let's go to our terminal and run npm install Laravel Echo. We will also need to install the client library of Pusher.js because we're using the Laravel Websocket server as a proxy to the actual Pusher server. And now once we have installed the npm packages, we'll need to configure Webpack in order for us to use these packages in our front-end JavaScript. And thankfully Laravel provided us a tool called Laravel Mix, which is a wrapper around Webpack to let us configure Webpack with an easy-to-use API. To configure Laravel Mix, we need to go to the file webpack.mix.js, which is living in the root of our project directory. Now, if you're not building the front end, this part might not be that relevant to you. We are really just compiling all of our front end code for our app. Now, I want to enable the hot module reload feature in Webpack. So what I need to do in this file is to call the option function from Laravel Mix and pass in the option, where I'll define the host and the port for the hot reload development server. The hot reload development server will serve as a proxy server to store all the compiled assets. And once we're done, we will create a new blade file for our WebSocket experimentations. And I'll go ahead and load our JavaScript where the source URL is in our hot reload server. Laravel Mix allows us to resolve the compiled assets in the hot reload server by using the Mix helper functions. And once we're done, we can ensure that the code in our app.js will become available to this blade file. Alright, let's take a look inside our app.js. It is quite empty, and the only line is loading the bootstrap.js file. And bootstrap.js is really loading all the global libraries into the Windows object. And at the very bottom of this file, we can see that in the commented code here, Laravel has provided us some snippets for us to load Laravel Echo. Let's uncomment it, and what it is really doing here is to load Echo and Pusher into the Windows object, so that we can call these libraries globally in our app. Let's take a brief look at the configuration of Echo. The broadcaster option is for us to define the broadcast driver, which in our case will still be Pusher since we're using Laravel Websockets. Key is the API key of Pusher, and we're simply reading it from the .env file. Laravel Mix will automatically load all the env variables with the mix prefix. Cluster is the cluster information about the WebSocket server. We don't really need it in our case because we're not using Pusher. False TLS is only required when we are using SSL. We will set it to false for now. And on top of this existing configuration, we also need to pass in a few more for Echo to work correctly. The first one is the WS host key, which is a host name of our WebSocket server. And in our case, it has the same domain name as our front-end client. We can just use window.location.hostname. And we also need to set the port of the WebSocket server and also set encrypted to false, and again, because we're not using SSL. And finally, to set the enabled transport property so that will restrict the transport of data to the WebSocket protocol only. WSS is a secure version of the WebSocket protocol that utilizes the SSL certificate, just like HTTPS in HTTP. Okay, now we have finished setting up Echo. We are ready to connect to our WebSocket server. Let's go to app.js, and currently we have only one public channel defined on our server from the previous lesson. To subscribe to a public channel, we simply need to call the channel function on the Echo object that we have set on the Windows global object. This function will return us a channel object that contains a multitude of helper functions for us to work with our WebSocket channels. We can call the subscribe function to register a callback that will be triggered when we have successfully connected to a channel. I'll simply console log out subscribe just for demonstration. And now let's try to run our app. We'll go to our terminal, start our server, and start the WebSocket server. And we also need to start the hot reload development server. And thankfully Laravel has provided us a script called hot in our package.json. And now the last thing that we need to test our code is to set up an endpoint to serve our WebSocket dummy blade file. I'll simply go to the web.php file and register a new endpoint called WS, which will simply send back the WebSocket view. Okay, now everything is ready. Let's go to our browser and visit our app. And in the browser console, we can see that the callback has been triggered and we are subscribed to the public channel. And just to double check, if we go to our terminal, we can see that in the console, it says that subscription succeeded and there's a new connection subscribed to the public channel. Great! And now let's look at how we can receive events in the front-end client. To do that, we need to call the listen function on the channel object. The first argument is the event name. So in the playground event that we created in a previous lesson, we have made it so that it will be broadcasted under a custom name called playground. Since we have used a custom name, so in the listen function, we need to put a dot prefix before the event name. Otherwise, Laravel Echo will be using the default prefix, which is the fully qualified event namespace in Laravel's app. The second argument that the listen function will receive is a callback function to handle the event. And the argument is the event payload. Just for demonstration, in the function body, I'll console log out the event for now. Let's go back to our browser. I'll hit refresh and go to Postman and send a request to the playground endpoint that we created in a previous lesson to fire the playground event. And in the browser console, we see the event payload printed out in the console, which is exactly the data I have attached inside the playground event that I have defined inside the broadcast with function. Isn't that neat? Can you think of any application that you can build with this feature? Let me know in the comments below. But for now, just as a quick example, we can easily build a simple messaging application using Websockets. Let's give this a go. First of all, I'll add an input box in our HTML for the user to type in their messages. Next, I'll add an event listener so that whenever the user has entered a message, we'll send an API request to the server, and the server will broadcast an event to the other subscribing clients, and the broadcasted event will contain the text message that the user has just entered. So within the event listener, we'll grab the user input and go ahead and send a post request to an API endpoint, which will be defining it very soon in our API server. Okay, now let's go to our web.php file and we'll quickly define a new endpoint called chat message. This post endpoint should fire an event that will be broadcasted to the WebSocket. I think it's a good idea to refactor our playground event to something more meaningful. I'll refactor the playground event class into chat message event, and this class will accept a string message in the constructor. And I'll rename the channel name to public chat1 instead of public playground1. And I'll also rename the event broadcast name to chat message. And the event payload will only contain one property, which is the message to be broadcasted. And now back inside our app.js, we'll change the subscription channel to public chat1 and also refactor the event name. Alright, let's test our code. We'll go to our browser, type in a message, and oops, the page refreshes because I forgot to call prevent default on the submit event. Let's try again. The page stopped refreshing, but we got nothing in the console. And the reason is because we haven't defined anything in the body of our chat message post endpoint. So let's go back to web.php. We will fire the chat message event in the endpoint and pass the message inside the request into the constructor of the event class. Alright, let's go back to our browser and try for one more time. I'll hit enter in the input box, and this time we see our message appearing in the console. Great! And now if I open a separate browser window and type in 123 in the text box, and we see the message 123 appearing in the first browser window because both of the browser windows are now subscribing to the same channel and the message event is broadcasted to all of the subscribers. That's the reason on why the first browser window is receiving the message 123 that I typed in the second browser window. Alright, let's keep going. Now I want to keep a history of all the messages that we have typed in the DOM. Let's see how we can achieve this. I'll go back to the HTML and create a list, and I'll put in all the messages inside this list. And now I'll go back to app.js, and every time we got a new message from the WebSocket, we'll create a new list item and add it to the message list. Okay, let's test our code. I'll type in 123 in the browser window and the message shows up in the other. Let's try it on the second browser window. I'll type in 222 and it shows up in the first browser window as well. Isn't that great? We got the basic aspect of a chat app working. Now the next thing that we need to do is to make use of the private or presence channel so that will only allow authorized user to send messages. We'll continue in the next lesson. I'll see you there. Key takeaways for this lesson. Laravel Echo is the official JavaScript client for us to subscribe and receive WebSocket events from the server. Laravel Mix is a powerful wrapper around Webpack that provides a painless API to configure Webpack. We use the channel function from Echo to subscribe to a WebSocket channel. And the subscribe method lets us to define a callback that will be triggered when we have successfully subscribed to a channel. The listen function allows us to listen to WebSocket events, and we should use a dot prefix when we want to listen to a custom event in Echo. Otherwise, Echo will be prefixing the fully qualified class name of the WebSocket event. That's it for now, and I'll see you again in the next video. Hey there, Sam! Let's look at how we can authorize a user to join a channel. As I mentioned in a few lessons ago, we will need to use either a private channel or a presence channel if we want to implement authorization. Let's start by changing the channel of our chat message event. Currently it's on a public channel, so I'll change the class name to private channel instead, and also refactor our channel name. Next, we'll need to define the authorization logic for our newly created private channel. We'll go to channel.php that lives inside the routes folder, and we'll define the new channel in here. We will call the channel method from the broadcast facade, and the first argument will be our channel name, which will be private, chat, and an ID. The second argument is a callback function that takes in the current login user as the first argument. And the second argument is the ID placeholder that we have in our channel name. And in the callback function, we'll return a condition where it will determine if the user is allowed to join the channel or not. For now, I'll just return true just for demonstration. And that means to always let the current login user join our channel without any extra conditions. Now also note that if our website visitor is not logged into our app, they cannot join a private channel. By default, if someone wants to join a private or presence channel, Laravel will authenticate them using the default authentication guard, which was defined in an auth config file. And if you want to have a final control on a per channel level, you could pass in a third argument in a channel function where you define the guards that you want to apply to authenticate the user. But 90% of the time, you don't really need to touch this option. Anyway, let's test our code. We'll go back to our app.js and subscribe to the private channel instead of the public channel. Now, instead of calling the channel method, we should call the private method to connect to a private channel. And now we'll go to our browser and we see a 403 error coming from a post request sending to the broadcasting auth endpoint. This is the HTTP handshake that I mentioned in the previous lessons. So the client attempted to establish a connection with the server but got rejected by the server because we're not logged in, because of the default authentication guards that Laravel has attached to the channel. To fix this error, we first need to log in before we subscribe to the channel. And we'll copy and paste the login logic that we have created in several episodes ago from the app.blade file. And then we'll move our channel subscription logic after we have logged in. And now let's go to our browser, hit refresh, and we no longer see errors. And that means we have successfully subscribed to the private channel. And now let's see what will happen if we return false in the authorization callback function. Let's go back to our browser, hit refresh, and we see the 403 error again on the broadcasting auth endpoint. And that means the handshake is rejected. We definitely don't want that, so let's change it back to true. Alright, let's move on. I would like to display the author of each message in the DOM as well. And that means every time when we emit the chat message event, we should also attach the current login user in the event. So let's go to our chat message post endpoint and we'll pass in an instance of the current login user to the event constructor. And within the event class, we'll set a user as a class property and attach the user in the event payload. We don't want to attach every information about a user inside the event payload, so we'll just put in the name and email field. Okay, now let's test our code. Let's go back to the browser and send a message. And in the console, the event payload that we received contains the user email and name. And we can certainly make use of the information inside the event payload to make our UI better. Let's do that. And I'm going to turn on my 10x speed boost life hack to code faster. I would also like to put in all the people who are online in this chat room in the Env Var. I'll put in some placeholder avatar for now. And there we go. We've got a nicely styled template to work on now. We just need to populate the data into our DOM. First of all, let's clear our hard-coded data and we will modify our list item creation in JavaScript. I'll copy one of the hard-coded block and paste it inside our app.js as a reference. And I'll go ahead and replicate the structure in JavaScript. And we'll go to our browser and test it. And it works. And now I'll open a new browser window and test if it is working as expected. And it works great. And now the next thing that we need to do is to put all the online users on the Env Var. And that means we need to keep track on who's entering the channel and who's exiting the channel. Unfortunately, this is not something that a private channel can easily achieve. So instead, we need to use a presence channel. And just a quick recap, the difference between a private channel and a presence channel is that a presence channel is aware of all the users that's currently in the channel. I'll show you what I mean. First of all, let's change the channel that the chat message event will broadcast to a new presence channel. And I'll go to channel.php and refactor the authorization logic. In a private channel, we need to return a boolean in the authorization callback function. However, in a presence channel, we will need to return the authorized user. So if we decide to let the login user to join the channel, we should return the user instance. Otherwise, we don't need to return anything in the callback function. And now let's go to our app.js. To subscribe to a presence channel, we'll need to call the join method on echo instead of the private function. And now we'll have access to a few more API. In a presence channel, the function to define the onSubscribe hook is called here instead of subscribed. And the callback function accepts an argument which represents an array of all the users who are currently in the channel. So later on, we'll be populating every one of these users into our Env Var. We also have another method called joining, which will be triggered whenever there's a new user join the channel. And also a leaving method, which will be called when a user leaves the channel. Alright, let's give this bad boy a test run. And upon reloading our browser, we can see that the user array is printed out when we subscribe to the channel. But when I refresh the second browser window, we are not seeing the joining method being called. And that's because currently we're logged in as the same user. I'll quickly make a login form so we can log in as other users. Alright, our form is ready. I'll log in as the first user and the second user in a private window. Alright, as you can see, as the second user logged in, the console is printing out the newly joined user information, which is what we return in a channels.php callback function. And now, if user number 2 tries to exit the chat room, we'll see the leaving callback function got triggered as well. So that means our presence channel callbacks are registered correctly. And now, let's polish our code so that we'll show all the online users in an Env Var. I'll create an empty array to store all the online users, and when the here function is called, I'll reset this array to be the users currently in the channel. And I'll also create the helper function called render avatars, which will simply loop through all the users online and generate an avatar for each of them, and append it into the Env Var. Let's give this a go. And it's working, but I forgot to put in the initials inside the avatar. I'll create a helper function to retrieve the user initials. And put the initials within the avatar. Let's try again. And it's working great. And now let's write the logic for the leaving and joining callbacks. So when a user has joined the channel, we will add the user to our users online array and re-render the avatars. And when a user is leaving the channel, we will filter out the user from the users online array and again re-render the avatars. Alright, let's run this bad boy for another time. We'll log in the first user and the second user, and we see both users' initials are popping up in the nav bar. Great! And we'll send a message on behalf of each user, and they are showing correctly in the chat box. Wonderful! And now if the second user is leaving, the user's avatar in the nav bar disappears. Great! Our app is working as we expected. And one last thing, I would like to show a divider whenever someone joins the room or exits the room. Let's refactor our code. I'll create a helper function to generate a new text box in the app. And the function body is pretty much what we have done in the event listener for the chat message event. So I'll cut and paste it and modify it accordingly. And now, when a user joins or leaves the channel, I would also like to add a new chat message to notify everyone in the room about it. Alright, let's test our code. We'll log in as the first user and second user in the private window. And upon logging in, we see the message the second user has joined the room in our first browser window. And when the second user leaves the room, we see the message has left the room. Isn't that neat? And now we're still lacking of one feature, which is typical in a chat room. That is, whenever someone is typing a message, I would like to show a typing notification to everyone in the room. We'll talk more about this in the next lesson. Key takeaways for this lesson: private and presence channel will only allow authenticated user to join in. They uses the default Auth guard to authenticate users. Presence channel keeps tracks of all the subscribing clients, while private channel doesn't. We use the private function in Echo to subscribe to private channel and the join function for presence channel. We need to define an authorization callback in channels.php for private and presence channel. The private channel auth callback should return a boolean, while the presence should return the authenticated user instance. That's it for now, and I'll see you again in the next video. Hey there, Sam. HTTP is rather slow compared to WebSocket, and in a real-time app, speed is the utmost priority. So if you want to get more juice out of our app, we should make good use of WebSocket. Currently, our chat app is not perfect. Here's what has been happening behind the scene. This is our client number 1, and this is our server. So client 1 wants to send a message to the group chat, and it will do so by sending in a HTTP request to the server. The server receives the request and proceed to send out an event. Then the event will be broadcasted through the WebSocket server to client 2. Now, as we know, HTTP request is slow. It could cause some delay for the event to arrive in client 2 and will be the bottleneck for this WebSocket architecture. And things get even worse if we are using an asynchronous queue driver to broadcast the event, which will cause further delay in the whole process. Now, the point here is that if there are events that we don't need to pass through the Laravel server, we could have established a connection directly with the WebSocket server and transmit the data to our peers without going through our Laravel app at all. By using this path, we can transmit data to the peers in a near real-time speed. And now the big question is, how are we supposed to achieve this? Well, there are two ways that I can think of right now. One is a long way, which is more powerful, but at the same time more complicated. That is to set up a WebSocket RPC API on our WebSocket server. The second way is a shorter and easier way, which is to use a built-in Laravel echo function called Whisper. That will allow WebSocket clients to talk to each other without going through our Laravel server. We'll discuss the short way in this lesson and the long way in the next video. Okay, now I want to implement the someone is typing feature in our chat room. So the idea here is that if someone started to type something in the chat box, we will broadcast the event to everyone else in the channel. Alright, let's get into it. So here in our app.js, I'll add an event listener to the input message box. So for every keystroke, I will whisper or broadcast a typing event to everyone in the channel. The whisper function accepts two arguments. The first argument is the event name and the second argument is the event payload. And I'll just put in the user email here. And now to listen to the incoming whisper messages, we will need to call the listen for whisper function on a channel. And upon receiving the typing event, I would like to show a small display in the DOM to notify everyone in the room. Let's go to our HTML and do exactly that. I'll add a span just above our input element, back to app.js, target the element. And when someone's typing, I'll simply set the text content of the span to the email in the event payload and adding a text is typing at the end of it. And now before we test our code, we need to make sure that in our WebSocket config, we have enabled the client messages option. And remember to restart your WebSocket server after that. Okay, now let's go to our browser and test our code. I'll log in as two different users in two browser windows. And now if I type in something in one window, the other window shows the typing notification. Great! And now here's another problem. When I clear the content in the input box, the typing notification still exists in the other window. And it is also a good idea to leave a small spacing on the left-hand side of the notification. Let's fix these two things quickly. I'll add a small padding left on the span. And in the input event listener, when the value in the text box has a length of 0, that means the user has cleared everything in the text box. We'll whisper a new event called stop typing. And back to our channel listen chain, I'll listen for the stop typing event, where we'll set the spam typing to empty when a user has stopped typing. Alright, let's test our code. Okay, as you can see, as I clear out my text message, the typing notification disappears. And that's how the whisper function works in Laravel Echo. Alright, key takeaways for this lesson. HTTP is rather slow for real-time application. It is quicker to communicate with the server through WebSocket connections. The whisper function from Laravel Echo allows us to send events to each other without passing through Laravel. The listen to whisper functions listen to peers event in a channel. That's it for now, and I'll see you again in the next lesson. Hey there, it's Sam. HTTP is rather slow, and in some real-time app, the delay in processing HTTP requests could be the bottleneck of the whole application. So, what's the alternative then? The answer is something called RPC. And just for a quick recap, RPC or Remote Procedural Call is a WebSocket pattern that is pretty similar to HTTP. So the WebSocket client will send a request to the server to execute a function in a server, and the server will send back a reply which contains the result of the functions. Since we're executing a remote function in a server, and that's why it's called Remote Procedural Call. Unfortunately, Laravel does not support RPC by default. The WebSocket architecture that Laravel utilizes is the pub/sub pattern, not the RPC. To implement the RPC pattern, one has to have the full control on the WebSocket server. And thankfully for us, since we're building the WebSocket server by using Laravel Websocket, we have full control on the server, and therefore it's possible for us to implement the RPC pattern. And furthermore, Laravel Websocket is written in PHP. Therefore, it means that we can access to all the Laravel components in the WebSocket server. If you're using a WebSocket server that's based on other languages, then you might need to build your own custom bridge to connect the WebSocket server to Laravel. Okay, now let's take a look at how we can implement the RPC pattern using Laravel Websocket. If we go to its documentation, on the left-hand side, there's a section called Custom WebSocket Handlers, and that is exactly what we need to implement RPC. In short, we can define these WebSocket handlers to directly accept WebSocket requests in Laravel. All we need to do is to create a handler class that implements the message component interface. The class contains a list of WebSocket lifecycle methods for us to customize the WebSocket logic on different stages of the WebSocket connection. Once we have defined a handler, we simply need to go to the web.php file and register the handler to a WebSocket route, which is very similar to how we define a HTTP request endpoint using a controller class. Let's create one of these handler files in our project. I'll create a new folder called WebSockets in the app folder and a subfolder called Socket Handler. And we'll create a new class here called UpdatePost Socket Handler, where the main purpose is to update a post. And just like what the documentation has said, the socket handler should implement the message component interface. Now the message component interface has 4 methods. The onOpen method will be called upon establishing the WebSocket connection. OnClose will be called when the WebSocket connection is ended, and onError is called when there's an error, and onMessage is called when the WebSocket server receives an incoming request. The first argument contains the details about a connection, and the second argument is an instance of a message interface, where it contains the message body of the incoming WebSocket request. Whoops, seems like I have implemented the wrong interface. It should be the message component interface under the wretched WebSocket namespace. Now every WebSocket handler will need to implement these 4 methods. While the onMessage method could be different from class to class, but the onOpen, onClose, and onError methods should have a very similar logic for all handler classes. And that means we can abstract these 3 methods to a base class. Let's create an abstract class for that. And just for demonstration, I'll just dump a few simple messages on each method. Now for the onMessage method, we will need to write the logic to update a particular post. Let's leave it for now. We will first need to register our handler in our web.php file. We can easily do that by calling the WebSocket function on the WebSocket's router facade. The first argument will be the route name, and the second argument will be the handler class. We'll go to our front-end app.js and attempt to connect to our WebSocket server. I'll create a new function called updatePost, and now we're connecting to our WebSocket server directly, so we're not going to use echo. Instead, we'll be working with the built-in browser WebSocket API. So we'll create a new socket instance and pass in the URL to our WebSocket updatePost endpoint. The socket object has a few properties for us to set a few lifecycle hooks on the WebSocket connection. We'll go ahead and set the onOpen function for now. And when the WebSocket is opened, we'll simply console log out onOpen. And then we'll call this function after we have logged into our app. And I'll comment out everything about echo for now. Okay, let's head to our browser and test our app. We will log in, and we see onOpen in the console. We have successfully established a connection with the RPC WebSocket server. However, now there's a few concerns about the security of our WebSocket endpoint. Currently, our WebSocket route is defined as it is without any middleware applied on it. It has zero protection whatsoever. And that means everyone can connect to this WebSocket endpoint without logging in. I'll show you what I mean. We'll go back to app.js and we'll call our updatePost function outside the login callback function. And we'll go back to our browser and I'll open a new private window, visit our app, and we still see onOpen in the console without even logging in. That is a big no-no. We definitely don't want everyone in the world to be able to connect to our precious WebSocket endpoint. How do we fix this? Well, we are using the WebSocket protocol here, so we can't really use HTTP middleware. One of the possible options is for us to define our authentication logic in the onOpen lifecycle hook. We could access the incoming HTTP metadata here by reading the HTTP request property on the connection instance. I'll dive and dump it here just to look at what's inside this property, and I'll restart our WebSocket server. And as you can see in the terminal, we can see all of the incoming details about the initial handshake. And we can go ahead and use all the data here to perform our authentication logic for the WebSocket connection. I won't be writing the authentication logic here, otherwise this video will be too long. For now, we'll look at how can we send data to our WebSocket server from our JavaScript client. But there's one thing that I'll do, which is to attempt to read the app key from the incoming connection. So if we look at the default WebSocket handler in the Laravel Websocket package source code, we notice that in the onOpen function is calling a function called verify app key. Now the verify app key will attempt to read the app key query parameter from the incoming HTTP request and check if it is a legitimate app key from the config file. If not, it will throw an error. Now in our own custom WebSocket handler, we should be consistent with this approach. So we'll copy and paste the verify app key function to our on-base handler and call this function on the onOpen lifecycle hook. And now since our WebSocket server is checking the app key query parameter in the HTTP request, so that means in our app.js, when we want to create a new WebSocket connection, we should also pass in this app key. Let's restart our WebSocket server and go back to our browser, and it's all working. And now let's try to send some message to our server. So in app.js, upon connecting to the WebSocket server, we'll try to send a payload by calling the send function on the socket object. We can only transmit string data or array buffer, so we'll stringify our payload by calling the JSON stringify function. And I'll say the payload contains the ID of the post that we want to update, and also a payload property which contains the post attribute that we want to update. I'll hardcode the value for now. And we'll go back to our update post socket handler, and I'll dump the message in the onMessage lifecycle hook. The message object provided us a few helper functions, and we can code the getPayload helper method to grab the content of the message. Alright, let's restart the server, and we'll see an error. And it says undefined property socket ID. So it turns out that we need to define a socket ID for each of the incoming WebSocket connection. How do we do that? Let's take a look at the source code of Laravel Websocket again. In the provided socket handler class, we can see that in the onOpen lifecycle hook, it is calling another method called generateSocketID. In the function body, it is simply generating a random number and set to the connection object. Let's copy and paste this function to our base handler class, and I'll call this method in the onOpen hook. Alright, let's restart our server again and refresh our browser. And now our server console is no longer printing out an error. Instead, we see our payload inside the console, but it is in the form of a string. To work with this JSON string, we need to convert it into an array in PHP. I'll call the collect and JSON decode function so I can work with the payload using the collection API provided by Laravel. And now we'll retrieve the payload and the ID from the message body. We'll dump the payload and ID variable to check if our code is working correctly. Let's restart our server, visit our browser again, and inside our terminal, and we can see that our payload and ID is dumped in the console exactly as what we have sent in a JavaScript client. Okay, now let's update our post using these two information. We'll first find the existing post in our database, and then we'll call the update function on the repository to update our post based on the payload. Once the post is updated, we will create a response using the post resource class, and we'll send the response back to the client by calling the send function on the connection instance, which is represented by the from variable. And now we'll go back to app.js and add the onMessage hook on our socket to receive the reply coming back from the WebSocket server. Okay, let's restart the server, and we'll go back to the browser and refresh the page. And nope, we're not receiving any message coming back from the server. And if we go to our terminal, we can see that our server did receive the request, but for some reason, our app is stuck in between the dump and the send function. Why is this happening? So it turns out that in our post repository, we're sending out a post updated event upon updating our post. Now by firing this event, Laravel will attempt to broadcast it to all the WebSocket client. At the moment, we are using the sync broadcast driver. We are still in the middle of an RPC connection. We can't instruct the server to send out another broadcast. It's like someone who's buying a walking sleeping bag, who wants to sleep and walk at the same time. So the code will stuck here forever. So to rescue this code, we'll have two options. One is to comment out the post updated event, so our app will not attempt to broadcast another message while the RPC is still ongoing. The second way is to use an asynchronous queue driver, like Redis, for our post updated event. Alright, let's restart our server, and we'll go back to the browser. And now we see a message event popping up in the console. Great! However, the event data is a raw HTTP response, so it might be better if we call the toJSON function instead of the response method in our update post socket handler. Alright, so that's an overview on how we can implement RPC using Laravel WebSocket. And now you might be asking, does that mean RPC can replace HTTP? And my short answer is yes. But you'll need to make sure that the server has the capacity to handle all the incoming WebSocket connections. Alright, key takeaways for this lesson. RPC or Remote Procedure Call is a WebSocket pattern that works very similarly to HTTP, following a request and reply pattern. HTTP is rather slow. RPC could be a faster alternative for real-time apps. Laravel WebSockets allow us to work with the low-level WebSocket API using WebSocket handlers. Although it is faster, we need to write a fair amount of code to handle security as it is not provided out of the box. That's it for now, and I'll see you again in the next lesson. Hey there, Sam! When we deploy our app to the live production environment, it is inevitable for us to configure our WebSocket server to use a SSL certificate for WSS encrypted connection. And it is also probably a good idea to test your development environment with self-signed certificate before you push to the live production environment. Now here, I'm using a Docker environment as an example to show you how I set up the SSL certificate. If you haven't learned about Docker yet, this section might be a little bit confusing to you. But that's okay, just think of Docker as a virtual machine and try to follow along with this tutorial. Let me know in the comments below if you want me to make a Docker tutorial series. I have a few Docker containers here, but what we need to focus now in particular is the Nginx container, which is our main web server, and also the workspace container, which is where I run our WebSocket server. And currently I'm running a shell instance inside the workspace container. And I'll start Laravel WebSocket by typing in php artisan websocket serve. To configure the SSL certificate, the first thing that we need to do is to supply the path to our certificate in a .env file. Laravel WebSocket will read these values and attempt to read the certificate and its key when it's trying to set up a secure WebSocket server. So make sure that your app has read access to the certificate that you specify in this path. Otherwise, you'll encounter an error. These values are being read inside the WebSocket config file under the SSL key. And if you're using self-signed SSL certificate, you might want to disable some of the built-in authorization feature like verify peers and verify peer name, otherwise you might encounter an error. Next, we need to go to our broadcasting config file, and there's a few things that we need to configure here. In the option key, the host will be the host of your WebSocket server. In my case, it will be the name of my Docker container. If you're using Docker, make sure that you have configured your network correctly. We need to set encrypted to true and also scheme from HTTP to HTTPS, and also set use TLS to true. If you're using self-signed certificate like me, you might also want to put in these two curl options. The reason is the same as before, to disable some of the authorization feature for self-signed SSL to work. And now the last thing that we need to do is to configure echo. Let's go to bootstrap.js. In addition to WS port, you now also need to set a WSS port. And we want to set encrypted to true and also false TLS to true. And now it's time to test our connection. And if you have edited any of your WebSocket server settings, remember to restart your server. Let's go to our browser and I'll visit our WebSocket dashboard. I am greeted by a warning sign. And that's normal because I'm using a self-signed certificate. Just ignore the warning, it's totally safe. I can guarantee you your safety. And now once we're in the dashboard, let's click on the connect button. And oh dear, we see an error in the console saying that we could not establish a connection to the WebSocket server. And the error message is not helpful at all. It did not tell us any reason whatsoever. And I've spent several painful hours figuring this one out. So it turns out that it's an issue with self-signed certificate. We have enabled the certificate for our web server just now in our browser, but we have yet to do so for our WebSocket server. So what we need to do here is to visit the WebSocket URL and change the protocol to HTTPS rather than WSS. And we're greeted by another warning page. And by clicking on proceed, we are enabling the certificate for our WebSocket server. Now back to the dashboard, we can now connect to our WebSocket server. Problem solved. If you're using a SSL certificate with a valid authority, you won't be having these problems at all. And that's how you configure SSL in Laravel WebSockets. Alright, key takeaways for this lesson. To configure SSL certificate for Laravel WebSocket, we need to set the certificate path in the .env file. And in the broadcasting.php config file, we will need to set the encrypted option to true and set scheme to HTTPS and set use TLS to true. For Laravel echo, we will need to set the WSS port and encrypted to true and also false TLS to true. That's it for now, and I'll see you again in the next lesson. If you enjoyed the content of this video, don't forget to hit the like, subscribe, and the bell icon for more content to come. It will really help me out. Thanks for the support.